Hello everyone and welcome to Simplilearn YouTube channel. Every second, businesses generate data. A customer places an order, clicks an ad, completes a payment, cancels a subscription or receives a delivery. Each action creates another record in a database. But millions of records do not automatically create useful information. The real challenge is turning rows and columns into answers. Which product generated the most revenue? Which customers purchased repeatedly? Which region is losing sales? What is the average order value and which campaign actually drove purchases? This is where SQL plays a major role. Even with Python, AI, cloud platforms, data lakes, and advanced BI tools growing rapidly, SQL remains one of the most widely used technologies in the data ecosystem. SQL is not limited to traditional databases either. Modern platforms such as Google, BigQuery, Snowflake, and Databricks continue to provide SQL-based analytics. So SQL is not surviving simply because it is old. It survives because the problem it solves is still essential, asking structured questions about the structured data. So in this session, we will follow this journey from raw data to actionable insights. We will see how SQL retrieves and filters data, converts thousands of records into meaningful KPIs, connects multiple tables using joins, and ultimately feeds dashboards, reports, analysts, and business decisions. So by the end, SQL will feel like more than a collection of commands. You will understand why it remains one of the connecting languages of the modern data world. So in this course, we will understand why SQL remains relevant despite the growth of AI, Python, cloud computing, and NoSQL technologies. We'll see how relational databases organize operational information into tables, rows, columns, and relationships. We'll understand how select, where, and order by help analysts locate useful information. We'll also explore how SQL handles missing values, conditional logic, and data changes before analysis. You will learn how aggregate functions and group by transform detailed transactions into business KPIs. Understand how related tables combine to reveal complete business stories. We'll follow the process of converting business problems into analytical SQL. You'll also understand why indexing and efficient querying matter when databases grow. We'll explore how SQL across cloud warehouses, lakehouses, BI platforms, and analytics workflows. See how SQL ultimately supports reports, dashboards, decisions, and business actions. So before we move on, let me share something exciting with you guys. If you want to build deeper job-ready skills in data analytics powered by AI, check out Simplilearn's professional certificate program in AI-powered data analytics in collaboration with IIT Pravartak. This program covers SQL, Python, Power BI, Tableau, machine learning, deep learning, generative AI, cloud AI platforms, and AI agents for data analytics. You will gain hands-on experience with 15 plus AI integrated tools and work on 11 plus industry projects, including real-world applications and a capstone project. You'll also get access to an agentic AI masterclass by IIT Pravartak faculty and a 2-day campus immersion at IIT Madras Research Park. So if you want to move beyond basic data analysis and learn how to use AI, automation, and intelligent agents to generate business insights, this program can help you take that next step. So before we move on, let me ask you a quick question. Which SQL clause is mainly used to group rows for aggregation? Your options are A, where, B, group by, C, join, and D, order by. Let us know your answers in the comment section below. Now over to our training experts. Data analytics is ultimately about turning raw information into something useful for decision making. A company may collect information about sales, customers, marketing, campaigns, finance, inventory, products, employees, websites, or business operations. But simply collecting this information does not automatically create the value. The value appears when the data helps answer an important questions. Suppose a retailer wants to know why did the revenue decrease this month. Traditionally, an analyst may first identify the correct data set, clean the information, calculate important metrics, compare the different periods, create visualization, and then interpret the findings. Generative AI adds another layer to this process. Instead of manually deciding every analytical operation, users can increasingly describe what they want to understand. For example, compare revenue across every region and identify 3 largest declines. AI may help translate that request into analytical steps. It could help generate SQL or Python code, calculate the metrics, summarize the results, or create an initial visualization. Microsoft's Power BI Copilot is one example of this shift because it allows users to interact with analytical data through natural language requests. So analytics itself is not disappearing. The important change is how analysts interact with the analytical process. Data analyst is becoming more conversational, faster, and increasingly AI assisted. Conversational analytics is already becoming part of everyday business operations. According to McKinsey's State of AI 2025, 88% of organizations use AI in at least one business function. OpenAI's enterprise research found that 75% of surveyed workers said AI improved the speed or quality of their work. Users also reported saving around 40 to 60 minutes per day with AI Assistant. This shows that AI is moving beyond experimentation into real-world workflows. The biggest shift is not just faster calculations but faster improvement from a business question to analytical action. In simple terms, AI is helping teams turn questions into insights much more quickly. So to understand the difference clearly, consider So to understand the difference clearly, consider a simple business question. Why did the customer churn increase last quarter? In a traditional workflow, an analyst may first identify the relevant customer tables, then customer records, subscription history, support information, product usage, and cancellation data might need to be combined. After that, churn must be calculated. The analyst may compare customer groups based on location, subscription type, tenure, or usage. Several charts might be created before the actual cause becomes clear. Generative AI can assist during many of these stages. The analyst might ask AI to generate a SQL query for calculation churn. AI could create Python code to segment customers. It could explain an existing query, it may summarize patterns in the results, or suggest additional areas worth investigating. This can reduce a lot of repetitive analytical work. But AI assistance and analytical correctness are not the same thing. Suppose the organization defines churn as a customer being inactive for 60 days. If an AI-generated calculation uses 30 days, the result may be technically correct while answering the wrong business question. So the better workflow is human defines a problem, AI assists with execution, and human validates the result. The analyst ensures that the analysis remains meaningful. To understand the true impact of generative AI, we should not think of it as one separate analytics tool. We can place AI across the complete data analytics lifecycle. Everything starts with collecting data. Information may come from spreadsheets, databases, APIs, websites, business applications, sensors, customer platforms, or cloud systems. Next comes data preparation. The information must be clean, standardized, combined, and checked before meaningful analysis can begin. Then comes exploratory data analysis. This is where analysts examine trends, distributions, relationships, patterns, and unusual values. Depending on the business problem, they may then create calculations, statistical models, or predictive models. After that comes visualization. Insights need to be presented through charts, dashboards, reports, or KPIs. And finally comes the most important stage, that is decision making. Generative AI can support every part of this journey. During modeling, it can assist with SQL, Python, or DAX. During visualization, it can help create or explain the charts. And during communication, it can translate technical outputs into simpler business language. So generative AI is increasingly becoming one intelligent layer across the complete analytics lifecycle. Good analytics begin with good data. Real-world data sets are rarely perfect. They may be duplicate records. Dates may appear in different formats. Some value may be missing. Customer names may be written differently across systems. Numerical columns may accidentally contain the text. And information from different systems may need to be combined before analysis can begin. This is where the ETL becomes important. ETL stands for extract, transform, and load. First, data is extracted from one or more sources, then the information is transformed by cleaning, filtering, reshaping, combining, or standardizing it. Finally, the prepared data is loaded into a destination where it can be analyzed. Generative AI can assist with many of these activities. For example, an analyst may request, find duplicate customer IDs, standardize the date format, and identify rows where revenue is missing. AI may generate Python or SQL code to perform these operations. It can also explain existing transformation logic or suggest possible data cleaning steps. But AI still needs context. Suppose a missing revenue value represents a cancelled transaction rather than incomplete transaction. Automatically replacing that value could change the analysis. So the principle remains simple. Poor quality data plus powerful AI can still produce poor quality conclusions. AI can accelerate preparation, analysts still need to understand what the data actually represents. So once the data has been prepared, analysts normally move to exploratory data analysis or EDA. This is the stage where analysts begin investigating the data set before making final conclusion. Suppose we have a sales data set. We may want to know which region generates the highest revenue, which products are declining, which customer group products are highest order value. Are there unusual transactions? Is there a relationship between discounts and profitability? Traditionally, analysts answer these questions using SQL, Python, spreadsheets, statistics, dashboard, and other analytical tools. Generative AI can make this process much more conversational. Instead of manually deciding every operation, the analyst could ask, show me the most important trends in this data set, or identify unusual values that should be investigated, or compare the profit margins across customer segments. AI can assist with calculations, generate code, suggest additional questions, or help explain the results. That allows analysts to explore more possibilities in less time. But interpretation remains important. If two variables move together, that does not automatically mean one caused the other. An unusual value may represent an error, but it could also represent an important business event. The analyst therefore needs to distinguish between a statistical pattern and a meaningful business insight. AI increases the speed of exploration. Human judgment determines whether the findings are useful. Finding an insight is only one part of the data analytics. The next challenge is communicating that insight clearly. A business leader usually does not want to inspect thousands of individual transaction records. Instead, that person may want simple answers. What is our revenue? Are we above or below target? Which region is performing best? Which product is declining? What requires immediate attention? Visualization help answer these questions. Charts make patterns easier to identify. KPIs highlight important measures. Dashboards bring several analytical views together. Generative AI adds another layer by helping explain what these visualizations mean. Suppose a dashboard allows the total revenue increase but overall profit decrease. AI could help generate an initial explanation by pointing the analyst towards possibilities such as higher discounts, increased costs, product mix, or regional performance. AI can also help summarize reports in natural language, but good data storytelling still requires human judgment. Adding 20 charts does not automatically create a better dashboard. The analyst still needs to determine which KPI matters most, which comparison should the audience see, what is the key takeaway, what action should follow. AI can help create and explain a visualization. The analyst provides a business meaning behind the visualization. As analytical problems become more advanced, analysts may need to create calculations, data models, or predictive models. In business intelligence, data modeling may involve connecting tables, defining relationships, creating measures, and calculating the business metrics. In data science, it may involve selecting variables, preparing features, choosing algorithms, training models, and evaluating the performance. Generative AI can assist with both. An analyst might ask, write a SQL query that calculates monthly revenue growth by region, or generate Python code for basic customer churn model, or explain what this calculation is doing. AI can create an initial solution and explain the logic behind it. This can reduce some of the technical friction involved in analytical work. However, generating code is very different from creating a reliable analytical model. The analyst still needs to determine whether the right variables are being used. The data must represent the real population. Data leakage must be avoided. The appropriate evaluation metric must be selected, and the model must answer the actual business problem. AI can help analysts experiment faster, but it should not remove the need to understand how the model works. So analysts may spend less time remembering every piece of syntax and more time deciding whether the analytical approach itself is correct. Traditional analytics often begin with understanding what happened in the past. Revenue decreased, customer churn increased, inventory fell, and one region missed its target. But business leaders usually want to go further. They want to ask what is likely to happen next. This is where forecasting becomes important. Organizations regularly forecast sales, demand, revenue, expenses, customer behavior, inventory requirements, and staffing needs. Traditionally, analysts may use statistical models, machine learning techniques, spreadsheet functions, or dedicated forecasting software. Generative AI can assist with this process. For example, an analyst could ask AI to generate code for a time series model, explain forecast results, identify assumptions, or suggest different forecasting approaches. AI can also support scenario analysis. Suppose expected demand is 50,000 units, management may ask, what happens if demand increases by 15%? Or how would inventory requirements change if demand increased while delivery times became longer? AI can help calculate and communicate these scenarios more quickly. But forecasts are estimates. Historical trends do not guarantee future outcomes. Pricing changes, competitor activity, economic conditions, seasonality, customer behavior, and unexpected events can all affect the results. The analyst determines how much confidence should be placed in that forecast. So where are these AI-powered analytics capabilities appearing today? One major area is business intelligence. Power BI Copilot allows users to interact with analytical data through natural language, ask questions, analyze visuals, and generate summaries. AI assistance is also becoming part of data engineering and data science workflows. Microsoft Fabric Copilot can assist with analyzing, transforming, debugging, and understanding data in notebook environments. General-purpose generative AI models can also assist with SQL queries, Python code, spreadsheet analysis, documentation, explanations, and recurring analytical tasks. These capabilities can be applied across almost every business function. A marketing analyst may compare campaign performance, a finance analyst might investigate unusual expense movements, a sales analyst could summarize customer performance, and an operation team might analyze inventory and demand. The important point is that generative AI is not creating a completely separate world of analytics. Instead, AI is increasingly being built into the tools and workflows analysts already use. The technology may change from one organization to other, but the overall process remains similar. Business question, data, AI assistance, validation, and decision. AI speeds up part of the journey. The business objective and the evidence still determine the final decision. So what does the future of data analytics usually look like? It's unlikely to be a future where professionals simply stop learning analytics and ask AI to do everything. Instead, the analyst role is likely to move higher up the decision-making process. AI can increasingly assist with repetitive analytical work such as generating queries, creating code, cleaning data sets, summarizing information, producing initial visualization, and identifying potential patterns. This can give analysts more time to focus on questions such as, is this data set reliable? Are we measuring the correct KPI? Why is this pattern happening? And what information might be missing? Or does this conclusion make business sense? What decision should actually be made? These are not simply software questions. They are analytical thinking questions, and that distinction is important. So as AI tools become more capable, simply knowing how to operate software may not be enough. Analysts will increasingly need to understand the business, frame better questions, evaluate evidence, identify misleading conclusions, and communicate findings clearly. So the future analyst combines four strengths. Business understanding plus data skills plus analytical thinking and AI capability. Generative AI can make analysis faster, more conversational, and more accessible. But humans still provide context, judgment, accountability, and decision making. And that combination is what turns raw information into reliable and actionable business insights.
Full name is Shruti Nikam. I have been associated with Simplilearn, and I have been in this industry for now more than 11 years. I've been in corporate training and consultation so far. I've been with more than 55 plus organizations, majorly for corporate trainings. I take corporate trainings in MS Office 365, applications, office productivity skills, basically. And with that, I have transitioned myself 5 years before into Power BI, Tableau, and data science. So this is a short introduction about me. And we are here together for data acquisition manipulation using SQL. First we will get introduced to SQL here, and then we will learn about what we have in the course, right? So in the course here, what we are going to learn in the entire course, we will go ahead and learn about what are data types. You'll also see what is data, what is database. We have to go ahead and understand here about database context here. Plus, we will understand about few more concepts of DBMS like normalization and other efficiency skills. However, within this course, we are also going to look into select queries. It means what SQL can do. So within SQL, what is SQL? Why are we using it? And we will learn everything from very beginning on how to extract the data, on how to create a database, till the Windows functions. So we are going to cover the entire SQL in upcoming sessions. First, before we simply deep dive into what is SQL, there are a few terminologies that we need to clear out so that everyone is on the same page. So let's go through some terminologies and then we will come back again. And first we have to understand what is database. We have to also understand why do we need it. Okay. What is data according to you? Information. All right. Raw facts, collection of information, set of information, specific format, set of information. So basically we are saying that data is information. Correct. So if I go ahead and write some things here. Is this data? It is data. There are some numbers, there are some text. But does this make any sense? So what is data? In very simple words, in a very, very simple words, data is structured information saved in a proper format. Saved in a proper format. Format can be anything. That format can be CSV, that format can be TXT, but it has to be some format. So that the context is also clear. Okay, it can be Excel also. It can be in JSON also. It can be anything. So there are many formats that we can go ahead and look for. It can be saved in multiple different formats there. Now that's a simple structure or definition of data. Then what is database here? Data refers to collection of facts, figures, or symbols that can be processed and analyzed to extract useful information. So now here, if this is data, and we are saying that we are saving that data in a proper structured format, it can be any CSV text file or Excel file, or it is saved in a table, anything there, in under any object. So what is meant by database? What is a database? And why do we need it? Data is stored, multiple data, system where data is stored, huge amount of data, storing facility of data, where data is organized and can be referred to when needed, where collection of structured data is stored. Okay, so we are saying here where all information has been collected. So basically we are saying that there is a proper base. Inside this, we are going ahead and saving our data set, right? So let's understand it one by one. Data here is fact. It can be a fact, it can be numbers, it can be any other form of information, an image, text, icon, pictures, anything, right? They are generally structured in a specific way or stored even for a particular purpose. You cannot simply go ahead and store any random information together. It has to be stored for a particular purpose too. Now, this data here, when it is in one single file, let's say there is one CSV here, then we are good. That one CSV is saved in our system in some folder there. Even now, if in your system you have multiple folders, everyone, You have got multiple files, maybe those are Word files, PowerPoints, PDFs, Excel files. They are all saved for a particular purpose in a certain folder. Yes. So basically what you do here in your own system is you go ahead, you manage it, organize it, and accordingly, time to time, you alter it and you change it, update it, correct? And you keep on adding more data into it as required. So in the similar sense here, this entire system or the folder that you have within your system, you can call this also a database, right? We can call that also a database. Why? Because database here is just a structured collection of data that is generally stored on a computer so that we can access it, manage it, and update it easily. So that becomes a database. However, within the database, if we go ahead and refer our own systems as database here, because it fits the definition here, is it easy to go ahead and find two connected files if they are in absolutely two different drives? We know that logic, that how these two files are connected to each other. For example, your salary slips and your tax returns. They are connected to each other, but definitely they will be in two different folders, two separate folders right there. Your investment details are in another folder, your salary slip in another folder. But you don't know that these two things are connected to each other logically. So that is not very easily managed, accessed, and organized because all logic is in our minds right now. Okay, that is why we have multiple different type of database management systems. In database management systems here, these are the systems specifically designed just to manage, organize, and collect the data there. And to ensure that multiple users can easily access it without even touching the data there. So if we are if someone else is modifying the data, multiple users can access it, extract the data too. Plus, while modifying and updating the data, this particular data management system makes sure that data is consistent, their data has validated properly, and plus the correct data is getting uploaded. So all of this can be done within that management system there. So database definition, you all are absolutely correct. So what is DBMS? Management system they have created in which they're saving this data set and still and working on extraction, modifying, updating the data set there. So within the database, now we agree that there are multiple data set. Done. Now the problem here is, why do we need database system here? Whenever we create a database system, there are few things that are very, very important here. So for example, right now, you have files in your system, right? So let's say you have got two files in your office laptop. One is for employees and one is for department. And there is two separate Excel files, Excel workbooks. So if I will ask you that, can you go ahead and get me the marketing manager personal details? How will you find it? So I understand the question again. Let's say you have got two Excel sheets, okay, on your system right now. Let's say two Excel workbooks here. One is have employee details and one has department details. And if I ask you here that, can you go ahead and get me the personal info, like personal info here of marketing manager, how will you get it? What we have to do? Because we have to go ahead and figure out who the person is. And employee details, let's imagine here, okay, we have the personal employee details data separate, only with the employee ID. So we have to go ahead and open the two Excel sheets in front of us, and we have to first figure out any department details. We'll go ahead and filter out any manager or wherever the marketing manager is. We have to go ahead and filter that out. Once we filter that person out, we check for the employee ID. Once we have the person's employee ID, we go back to employee details, we filter out that employee ID, and then we get the details out of that. So either we do it manually or we apply VLOOKUP or anything, we have to go ahead and merge both the tables together, or at least open them together. Since we cannot merge, the data is huge. Okay, so you have to go ahead. We are talking about Excel workbook, Krishna, so nothing like that will happen. We are in the Excel workbooks right now in the exam, right? So this is how it doesn't happen. This is why they came up with that this file management system is not working. Okay, with it is here, there are two very important things here. First, retrieving the data is the huge limitation here is retrieving of the data set. If I want to go ahead and retrieve the data, it is very, very difficult. If we are saving the entire organization's data into Excel files only, in some shared drive only, Then we had no idea, okay, how people, who is updating the data set, how many people are updating the data set, right? So in that case here, we have too many limitations. The first point is there is no security, okay, because it is in a shared drive. All the Excel files are there for finance, for marketing, for digital marketing, for HR. So first of all, security is not there. And if a if new person joins an organization, they go back and update its data set in their HR file. Someone is manually doing it. Someone is manually going ahead and updating the data set, and only not one person is responsible for that. So if there are multiple people there, there are chances that we are going to have multiple duplicate of data set. If I'm saving employee ID, employee name, employee last name, employee phone number, email ID. So if I have employee personal details, that will be there also. If I have employee work details, I have to keep their contact details there also in case we have to go ahead and contact them. So like this, there will be a lot of duplicate data there. And like this, there will be more limitations here. That is why they came up with DBMS, that is Database Management System. It was an entirely different type of a system. Inside the system, each table was saved as an object called as, each data was saved as an object called as table. And that table was made with rows and columns. They must be thinking that why are you telling us about table? We know how a table looks like. I'm sure about that. Let's learn a little bit more about it. What we call as a table technically. Our data is called as a table structure, that we are saving it in a table structure only when it has rows and columns both. Plus, the first row will always be called as a header. First row has to be a header. And each column header should have its own data type. If it is a number, it has to be a number. If it's a date, it has to be a date, all from first row till the end. And when we are reading this data set or this table here, we will read it from top to bottom, always, right? So that is DBMS. Now, DBMS has just one problem, okay? It has eradicated data validation issues, it has eradicated data consistency issues, because now we can have security. Because we're securing on the row level there, we are securing on the table level there. We are good. We can give access to the people we want to. That was good with DBMS. However, they had one huge problem that these tables were standalone tables. They were not connected to each other at all. So if there is one table saved inside the object, I can go ahead and extract table from there. However, those are not connected to each other. So employee table is not connected to department, department is not connected to customer or the vendor table. There is no common key between them at all. So when they faced this issue here, they came up with relational database. They came up with relational database. Now they understood that see, if we need to have a table, okay, we need to go ahead and connect these tables too. So only keeping in table structure is not working for us. Since database is scaling every day, we need to go ahead and connect multiple detailed tables with each other. But how do we connect them with each other? They go ahead and they connect them based on common columns. So if we had a department table, let's say if we had a department table like this, if we have a department table like this, we will make sure that we will go ahead and add employee ID. So this employee ID will act as a key or a common column. If I added an employee ID here, that this person's employee ID is, let's say 101, maybe this person's employee ID here is 103, 106, and likewise. Okay, so we can go ahead and we have to go ahead and update the employee ID right here. After this here, if now, what do we connect it with? Now we can easily connect it with the employee table. Why? Because employee table is also going to have the employee ID. Now this becomes easier. Now I don't have to go find and filter. So this is relational database. In relational database, okay, we will go ahead and connect the multiple tables with based on common columns. If common column is there, good. If it is not there, we go ahead and we create the relationships by creating the keys, right? So this becomes relational database. Now these databases nowadays are of very, very different types. One of the types here is MySQL. Okay, we are going to learn with MySQL. We will see that right now. This is called as a relational database where we have the common columns and we connect them together. So let's see different type of databases that exist nowadays. Nowadays things have changed because a database here, like relational database, it can save only date, numbers, and text. That's it. If the data is within that, a database can easily save it in a tabular structure, right? So how many types of databases we have here? First, we have DBMS. Now we have relational database here. This is the first here. Then we have a NoSQL database here. Then here is graph database. Then we have centralized database and distributed database. Now you must be wondering why I'm writing first, second, third here, but I'm writing first and second right here again. Because these are databases of different types based on different bases here. So relational, NoSQL, and graph database here, these three databases are differentiated based on type of data we are saving inside it. These are based on type of data we save inside it. And these are based on these distributed centralized. This is based on location. This is based on location of data. Location of database. This is based on location, or you can say type of location. So let's go ahead and learn what is relational database, what is NoSQL, and graph. So as I have just explained to you, okay, what is relational database, everyone? It's the collection of the objects, data objects. We are not calling them tables here. We are saying these are data objects, which are structured into tables. Okay, they are linked together with predefined relationship. What is a predefined relationship here? Common columns, right? And of course, sometimes rows are also called as records. Columns are called as attributes here. And each attribute has one single type of data type, and that is fine with us. We have already seen that in table runner structure. Plus, we will create the keys and the common columns to establish the relationship. This is the most common type of database here. And these are the few examples: MySQL, MySQL, PostgreSQL 2. Now, next here is NoSQL database. What is a NoSQL database, everyone? Since the social media, okay, after 2010, it has scaled up to the data that they are started collecting. Okay, it has been scaled up to billions now at that time only. So these social media websites, they have data set like not only your email ID and passwords and the bank details, meaning not only number, alphanumeric, date, and text. They also have now your images. They have got podcast, some audio clips, videos, and comments, blogs, articles, entire web pages out there. So now we have non-tabular databases, the databases that cannot be stored in just a table there. So they came up with NoSQL here, and these now stored as JSON documents. What is JSON documents? These are JavaScript object notation documents. They are written differently. They are programmed differently. If you will look at them, okay, it looks like curly brackets and lot of commas and colons. But the hierarchical data and a huge data can be saved in a very, very small amount. So JSON documents here, okay, they are classified into several categories like data models, document, key values, byte columns, and graph databases. NoSQL databases are scalable, very easily scalable. Now, if there is any kind of social media application, right? JavaScript object notation. I will write it down here. It's like we have Excel files, right? I will show you a file there. So this is JavaScript object notation file. It is like excel.csv.json. Okay, .geo.json. You might have heard of that too. So these are kind of the extensions of the dataset. It is a different kind of format. It is written with a lot of semicolons and very easy to define the hierarchy inside it. I'll show you an example later. So this NoSQL database can save pictures in pixels. It can identify that too, right? So NoSQL database examples here are MongoDB, Amazon Dynamo, Apache HBase. If you have heard of Hadoop, it is also linked together with this only. So when we have these kind of data and we want to save that, we don't save it in Oracle or MySQL. We go ahead with NoSQL databases. Then we have got graph database. To understand graph database here, whenever you go to link them, right? And you are looking at somebody's profile. Does that tell you that whoever has visited this profile have also visited these profiles? Or these are the mutual connections you have? This is your first connection. This is your second level connection. This is your 3+ level connection. Have you ever noticed that on LinkedIn? How do you think they're saving the data set with them? So let's say if this is you. Okay, you have got, let's say, 1,000 connections there. This is you. Now you have 1,000 connections here. Now, all of these connections here, how do they know which is falling on a second level, first level, second level, or first level? If anything new is coming up, new person is coming up, they also know that they're connected to each other. They know that whoever the next person, a new person is coming up, this person has mutual connections with you, meaning this person's network is coinciding with you. And this person, of course, has its own network again, first level, second level. Is it possible to save it in an Excel type of file? Okay, where if you try to do that, there will be a lot of redundancy, repetition every time, because if you are saving one person's network, is it possible to save one person's network? How many people are there on LinkedIn? And they're all connected to each other. So saving this in any kind of format is very difficult. And of course, it is a huge data set there. So what they do is they use graph database. This graph database, okay, they use graph structures, okay, which has nodes, edges, attributes, parent and child relationships, and likewise. So that's how they go ahead and say. So that's just graph database. We are not going to work on, we are going to work on our DBMS. We are going to work on relational database only, right? We are going to work on this and we are going to learn with MySQL. Now let's talk about what is centralized and what is decentralized. So what is centralized database here? As it is said, that it is a stored, located, changed, maintained at a single location, such as a mainframe computer. So there is a mainframe computer, a huge computer. Those who are from the non-tech background, it's a huge computer. Okay, it is kind of a server physically with all the hardware connected with it. And it is somewhere located at one single place. Now, everyone who works in the organization, they don't have to be at exactly that location. Okay, with the help of internet here, they can go ahead and access whatever data they want from here. Okay. So this is called a centralized database. Do you think it is going to have any difficulties or some limitations here? There are advantages, clear advantages. That is going to be low cost, easy maintenance. But what are the limitations? Yes, we are storing the data here, Vaishnavi. Entire data is stored here at one place. Yes, if we have to scale the data, we have to make sure that our hardware can handle that. Correct. Both me know. If I have one computer, I will place it at one geographical location, right? It is not going to be costly. Yes. If it gets corrupted or slowed down, entire organizations will be like, server is down today, we are not able to do the work. Yes, it is easier to secure the data because it is just one single place. It is easier to manage the data too because it is just one single place. But if anything happens here or the server slows down, okay, we are going to face that difficulty quite often if the data is scaling rapidly. Right. If there are too many people trying to access the same thing here and the hardware is not designed for that much scale or for that many people at once, it is going to lag. It can be slower in fetching the data too. And if it gets corrupted, our backup is still in this mainframe here. So it will go ahead. So we are at a risk of losing it, but we always have a backup. Okay. So this is the centralized database, and most of the organization will be having the centralized database only. All the organizations that we usually see, they work with centralized database only because it is easy to access and handle and scale. Now, after centralized database here, we have the distributed database. What is distributed database here? Okay, it is the unified collection of linked databases that are physically dispersed across multiple locations. So here it is saying that they have distributed the database at the physically multiple locations here, but they are still connected with the computer network. And they do have databases inside it. They will have the databases saved inside it. And since it is RDBMS, everything will be connected to each other. Now, what happens when the database is like that? Now, when we have the users here, they can still go ahead and connect with the data set, okay, by using the servers. But yes, of course, they will be distributed too as per their requirement. As per their requirement, access permission and job roles, they can go ahead and access the data accordingly. Now, what are the advantages or limitations do you feel will be there? Network dependency, it was in brief. High cost maintenance, that's correct. It may be faster, yes. Data security is the issue you have to maintain at all the levels. And you need now a bigger team to handle all the physical locations too. But if there is a huge data, they cannot save it at one single place. They will disperse it across the locations. Google uses that. Google uses the distributed database system of different databases right here. Yes, and scaling is easier. Meaning, for to scale up, they don't have to keep adding up too much hardware or systems. It will be easier. Great. So now we here understand that these are the different type of databases here. What we are going to work with. We are going to work with RDBMS here. RDBMS is the most sought after. Why? Because most of the organization's data is that they want to analyze is date, numbers, and text. So RDBMS is best. Right. And plus, it is a simple mainframe computer. We can connect it with local internet and we can connect with it easily. So that is the most sought after. But yes, with the need of in the social networking systems and too much different types of data set, they might need to scale up to NoSQL or Graph database. Very good. So the question here is, the system is characterized by having its data structured, logically interconnected, physically distributed over several sites within a computer network. As it says here, distributed. Okay, this is the key that we need. So the answer will be C. Now let's go ahead and understand about SQL. What is SQL? We will deep dive into what is DBMS and RDBMS then. So first here is SQL. So let's go ahead and part of this SQL. First in SQL is the language. What is language? So any language. So this is a language through which we ask something. What do we understand that now? Now here is, it is a language through which we ask something. Since this is a language, it has to have its rules and grammars, right? This is why it is structured. So it will have its own rules and regulations that we follow while talking to each other. We do go ahead and we follow those rules while talking. That how would you make a sentence? Which are the vocabulary that you have to go ahead and keep it with you, right? So structured query language. So it is a query language, a language that has been created to ask the questions to the database and retrieve the data that you want. Or if you want to maintain the data set, you go ahead and you simply ask the questions to the system there. Remember that it is not a programming language. What is a programming language? We create something new there. We program something new there. So we're not asking or creating something new out there or the entire structure of something. No, a structure is already there. We are simply going ahead and retrieving the data from there. And that's it. Okay. So structured query language here means we are using a language which has its own rules, regulations, and vocab. And using that language, we are talking to the machine and asking the questions to it. That's it. That is SQL. A structured query language. Yes, absolutely correct. Now, let's understand here what SQL can do. SQL can perform if we say here, it can go ahead and perform the operations like create, read, update, and delete. These are the operations that we can perform with SQL. What we are creating here. We can create a database inside the hardware structure that we have available. We can create a table. We can insert the values inside it. We can, if you want to update it, if you want to alter it in some way, you want to delete that structure or a row, or maybe I want to update some data set inside it. Now, when we are modifying and saving data inside it, once it is done, it is my part. Another person who wants to simply extract the data and analyze the data, that person will be reading that data. So while reading the data, again, we will have multiple steps to follow. So this is the CRUD here, and this is how we can read the data here. So these are the four operations, basic four operations here. Now, MySQL is a language. It is not only used at one, SQL is not a language that we use only within one single database. Okay, it has multiple uses across multiple applications and platforms. And why we are learning via MySQL? Because MySQL is free to use. Second, it is the easiest way to learn SQL. If you learn the fundamentals here, you will be able to adapt to any changes that you find in MySQL, Oracle, PL/SQL, or Snowflake as you will move forward, right? So the fundamentals remain same. It is an open source system here, okay? And it is easier to use. A very, very simple graphic user interface. That's why we'll use this here. Okay, so now let's understand the difference between DBMS and RDBMS. It stores data as a file. We know that right now. RDBMS here stores data in the form of the tables. Now, RDBMS can have multiple users. We can now connect the tables with common columns that are the foreign keys and the primary keys there. And it is easy research in RDBMS. And all of that is not present in DBMS here. Data fetching is slower and complex. We have already been through that. Now, a quick check again. Which system is considered most popular and advanced version of DBMS? With examples like MySQL, Oracle, and MySQL. As we've just discussed, it is our DBMS here, right? I hope you're on your LMS portal. In your LMS portal, on the right-hand side, when you click on self-learning here, on the right-hand side, you will find a vertical menu card. Okay. In your vertical menu card, you can see all the lessons that we are going to cover. You can see all the lessons that we are going to cover. Okay. So as you can see, we are going to cover, right now we were having introduction. Then we start working with the database and tables. Within that also what we are going to go through, different type of commands you can see here. And then we will see how to work with the operators, constraints, and everything else. There are there are everything defined here, what we are going to cover with the topics and subtopics. First here is look at instructor slides. These are all the PowerPoints you will see me download using in the class. Then here you have two types of practices. What are these two types of practices here? First here we have practice project, and then we have here guided practices. You also have demos, right? What are these demos? These demos are the ones that are used inside the slides. So when you go through the slides here, you will see that they are doing some small activities within the slides, and there are a few queries written there. So on what particular lesson, which particular data set has been used to write that query, you can go ahead and find it from here. Now you have guided practice folders here. Guided practice are lesson-wise folders given to you. And the practice projects that you see here, these are the projects, lesson end project. So once your entire lesson is completed, for example, you have learned about all these small commands still here, right? So the lesson 2 practice project is going to contain almost everything from this lesson number 2. So these are the projects. What does these folder have? These folders have PDF files, and two PDF files are there. First is the problem statement, and another is the solution to that. Solution consists of the screenshots and the explanations for the query. Now, whatever data set has been used in any of these projects here, it will be provided inside the dataset folder. Inside dataset folder, you're going to find three things, three folders inside it. One dataset for demos, one dataset for guided practice, one dataset for practice project. So this is your reference materials available. Now I would like you all to click on live classes. When you click on the live classes here, you have this box right now with today's date. Can you click on the box, please? When you click on the box here, you'll find here session materials are written. And you will see a list of session materials here. You will see some PDFs. You're going to see YouTube links. Those links that you're looking at, you have to go to the epsilon or the three dots there and copy it and paste it in the next browser. So session materials and reference materials are two separate things. The session materials are the live session materials, whatever we are using here in the live session or whatever I solved within the live session. Now in the session materials, go ahead and find out there is a PDF file, one for Mac OS, one for Windows. Whenever we talk about data, everyone, okay, so let's say we talk about MySQL. Now in the MySQL here, when we talk about our DBMS database here, it is made up of three entities, or you can say three components. What are the three components here? Okay, one is going to be hardware, one is going to be data that we save inside that hardware, and then we need an application to access whatever objects we have saved inside it. So if we talk about like this, right? So we have software, hardware, and the data. Now these three components require a container, a physical container that is hardware, an application program, a software application program, which will help us to connect with the hardware and the save data inside. These three components have three types of users too, based on data abstraction. Understand data abstraction as a security here. So who has how much access to database or individual data tables? First person here is the end user. Who is the end user in server? End user is the person who has the access to data as per the job role. Their main job is to extract the data and create reports. They will be using the minimal coding possible. And their only job is to extracting the data and making the reports, analyzing the data, and then moving on to other applications. These are end users. They work on the external view or as the end user on the application level. Then the second here are application programmer developers. To those we are called them nowadays data engineers, right? We call them data engineers. What do these people do? They are the persons who will interact with the data directly. These are the persons who will decide how to get data inside this particular server, how which relationship has to be created, what data should be stored, what kind of model should be created, so what kind of schema should be there. This is all decided by the application programmer. This application programmer has got nothing to do with data analysis. They are more concerned about how the data is managed and secured inside the software. Now the third person comes in here, that is database administrator. This is the trend in the entire structure here, because this is the person who is responsible for the maintenance, operability, recovery of this entire connection, meaning the network should work properly, right? It should be operable so the end users can go ahead and access that and extract the data set. Plus, this is the person who will give instructions, access to the user. This person will control the entire data access. So as per the job role, whenever there is a requirement, you keep asking for data and they will provide you with the data set, or they will give you the access to that part of the database. These people work on internal level. These people work on internal level or physical level, creating user ID passwords, providing and replacing the security levels there. So these are the three type of users here. So now what type of which course are we doing, everyone? It is concerned with analysis of the data set. This entire program is concerned with the analysis of the data set. You're supposed to analyze the data set. So either you're a data analyst or you're a business analyst, or you will move forward to data science. Any one of these three, whatever is your upcoming path there. Yes. So who are you? Which user are you? 1, 2, or 3? We are the first users. I don't know why you're not sure. Maybe you are the experienced professional right there. Okay. And you have worked with the mixed job roles. That's why you're saying that you are not sure where you are going to go and end up. So if you are from the programming background, you have already been working with APIs and connecting multiple portals and extracting data inside the server, then you will be working as a data engineer, right? However, when you will join as a data analyst, you will not have the access to SQL at all, unless you're joining there with the 10, 15 years of experience and on a manager level, then you will have the access to all the three levels right there. But those who are learning for the first time and you do not have any experience, you will be working only with the analysis and the extracting the data here. Okay. Not the entire team will have the access to it, or anyone who joins as a data analyst after this program, neither they are going to have access to make sure that data is getting there. Unless, yes, they join in a job role where they're supposed to modify access and make sure data is properly stored there. So now it depends on which job role you go. But yes, as a data analyst, you should know about two things there. First here is, as a data analyst, your first step always to collect the data. You have to first figure out, as per the objective, okay, which data tables are required and from where are you going to get those data tables and the required data. Now it can come from one single server or multiple different sources. Once that is done, your step number will be, now you go ahead, you analyze your data set. Maybe you import it into Power BI, maybe you in Tableau, maybe you want that data in a CSV, you will go ahead and analyze with Excel. So you go ahead and analyze and create your reports. And at the end, you need to share those reports. Of course, you're not creating reports to save it with us. So we go ahead and we share the reports with others. We go ahead and present them to BPMs, like the person who take the decisions. Those are the business process managers. However, okay, if you are an absolute beginner with no job experience, okay, you might go ahead into the level where you will be writing the SQL queries, okay, to extract the data right from here. Or maybe you will be asked to assist in updating and modifying the data if you have been given that permission. Usually it is not given. Let's talk about our here MySQL. Now in say SQL operations, let's talk about SQL operations, right? In SQL operations here, what is the first thing that we will learn here? SQL operations here can help us to do four things. What we have learned about those four things there. Remember that? What were the four things that SQL operations can do? What were the four operations? So first thing that we see here is, so let's talk about read here. Create, we understand. Okay, we create a database, we create a table. Create is fine. Let's understand about read, right? Let's understand about read. What read is going to do? Read means here that it will help us to fetch or retrieve the data from data tables or data set or subset of a data. Okay, from a table inside the database. While fetching this data here, while retrieving the data here, we might want to go ahead and give the filter. Maybe I want to go ahead and only want to view the marketing data set, only want to view the last 6 months data set. It means we can go ahead and bring, I need to filter out the data from the rows, right? First thing is that. Second here is, maybe I don't want all the columns there. Maybe I want to go ahead and only keep the columns that we need right now. But now after retrieving it or while retrieving it, we might want to sort it properly. If I want last 6 months data, it has to be sorted in a proper time series or in proper date column. So we can go ahead and sort the data too. Sometimes while sorting the data, okay, and let's say I have the data here from the cash tills. So what the kind of data we have here, we have the customer ID, what product they have bought, what is the date and time, what amount they have paid, any kind of coupons were there or the cards were there that they have used there. So what data I have is just the sales amount data. If you want to go ahead and I want to calculate profit there, I want to calculate what was revenue there. If we need more calculations there, we can go ahead and add that too. So if you want to add any kind of calculated column, we can do that. If we want to aggregate by anything, we can do that. Any kind of mathematical calculations can be done. And not only mathematical calculations, we can also go ahead and work with conditional or logical statements too. So this is what we can do with read and more. So we can go ahead and add, calculate and aggregate the data too. Maybe I want to simply see total sales by some country, total sales by product. We can go ahead and create an aggregated reports too. Now, when we talk about create here, all right, so within create, what do we create here? We create the databases, we create data tables, we insert data records inside it, okay? And since we've created those things, we have to manage that too. Update the table or the data inside it, we might want to delete. Now to do these all operations here, to do all these operations here, we need some commands, right? Vocabulary, remember, I've told you there will be keywords and commands and vocab there because it's in a structured language. So to do all of these commands here, what are the types of statements that we will be working on? What are the types of statements? Command groups or types of statements to write these operations. And we call them DQL, data query language here. So the selected statements that you're seeing here, right? That is meant query language there, correct? Now this is data query language. It means the keywords that are used to query Second is data definition language, DDL. What is the definition here? We are defining the database structure or a schema. What we are doing here, we are defining the database structure or schema, meaning how many number of columns we have, what is the data type of each column, what kind of limitation we have to put into that. Is it date? What kind of format? Right. So that is data definition language. Yes, correct. Like create the table, alter the structure of a table, drop the entire column from the existence, and lot more. Third here is DML. Yes, very good. Third here is DML. What is DML here? Data manipulation language. What does manipulation language will do? It will help us to insert the data, update the rows, delete the rows, maybe merge the data together. This is manipulation. Third here is DCL. Yes, very good. Thank you. DCL is data control language. What is the data control language here? This data control language is going to help us to give access to people, grant permissions, revoke permissions, and likewise. This is usually used by the DBA, the person who is supposed to give permissions, get user IDs for everyone else. This is DCL. Then we have one more here, that is TCL. TCL is transactional control language. Why transactional control here? What is a transaction? Okay, transaction here is we are trying to update the underlying data. We're trying to modify, delete a column or delete few rows here, or you want to add few more rows there. And it is not done by a single person, it is done by the entire team. So the entire team is working on that. Who is keeping a check on that? Are they doing it correctly? Is it correctly done? Whatever changes they have done, it is correct or not. So while doing these kind of transactional queries, okay, they use TCL with that. And like these are few examples here, like save point, rollback, and commit. Meaning save up to a point, you should be ready to control Z, undo it, that is rollback there. Or commit the change, it means completely update whatever data we have done here, right? Whatever changes they have done there. That is TCL, transaction control language. Of course, who uses this? Your data engineers. They are the ones who are responsible for modifying and maintaining the entire data set there. Now, so these are the types of commands. Our main focus going to be here. Our main focus is going to be here. Okay, I can show you few examples at the end. Maybe I will provide you with some examples here, but our main focus is going to be here. Just letting you know, right? So these are the command groups here. You will already have Microsoft Windows selected. Yes. Once you have the Microsoft Windows selected here, go ahead and click on download. Select the first one here. Select the first one here. Once you select on the first one here, it takes you to this page here right now. In this page here, you're supposed to click on no thanks, just start my download. So the one with 2 MB here, you will go ahead and download that one. Once you click on no thanks and start my download, then you can see all the next steps here. The first is custom, you get the server here first. Say they are giving you very good instructions here. You have to click on the plus sign, then you will have the all the versions expanded, then double click on this, get it on the right hand side here, then find the workbench, follow the same instructions. So everything is properly written here. Once you will go through each and everything here, you will have at the end, you might see this dialog box. Few of you will see this, few of you will not see this dialog box. So, and you're good with that. Okay. So you have to click on the plus sign and get the workbench and the server on the right hand side. After this here, everyone, you have to simply click on the plus sign here as it, you can see it clearly. There's a plus sign here. Okay, everything is properly given here. So Meenu and everyone else, just follow the instructions here. It's a really good PDF. It will take you through entire steps. If you face any difficulty, you let me know. So plus on server. Then once you see the list of servers, select the first one and click on the green arrow. Now you click on minus. Then we click on plus on workbench again. Then the list of versions of the workbench will appear. And you get the workbench here too. After getting these two here, we click on next. And after that, okay, keep clicking on next. It will take some time to execute. In few of your versions, if you're using Windows 10, it might ask you to get the visuals in here, Microsoft Visual there. Agree to the terms and condition and install it. After installation, just keep clicking on next until you reach to the password there, until you go ahead and reach to the password. About the password here, please let me clarify you. This password is not an easy password to recover. It's an open source application, everyone. So the root password, please make it easy. Okay, that should be in your memory. Write it down somewhere. Write it down somewhere. If you think that you can remember it, okay, you can. It is not possible to remember this. I would suggest that go with the 1, 2, 3, 4 ABCD or QWERTY, these kind of passwords that you can remember. There is nothing to save and secure here. Okay. So keep your root password easy, as easy as possible. So that if you, and because it is not just clicking on forget password, you get an OTP and it is reset. It is not going to be like that. Once you forget the root password, even uninstalling and installing will not help you. You have to go inside it and then change it and update. You cannot recover it. So make sure that when you reach to the root password, it is easy and memorable. Okay. In this welcome screen, everyone, we can see local instance. Okay. So let's go ahead and click on local instance here. This local instance is, when you click on the local instance here, it will take you to the workbench. What is a workbench here? Is the graphic user interface tool so that we can go ahead and access the server. When you click on the local instance here, this is the interface you will be looking into. So we have nearly 4 quadrants here, everyone. In first quadrant here, you will find you have schemas here. You might not be looking at schemas, you might be looking at administration management like this. Yes. So on the left-hand side here, you will find your navigator management here. And just above this, observe here, you have your quick access toolbar. Above this, you have got drop-down menu toolbar. And here we have home tab and the local instance tab right there. What is this home tab and the local instance tab? This, if you go to home tab, it will take you to the welcome screen and back to local instance. You can have many instances open up here separately. Now we are in Navigator. We see the management instance options here. Within here, you will also find an option called as a schemas. Click on these schemas, please. In these schemas, do you see a cylinder right now? A cylinder kind of a structure? Please click on this here. Now you click on local instance, type in your password, and it will take you here. So let me now go through the interface here. Okay. Okay, so as now here do we see this container, everyone? I hope we do. This container is our database. What is this? This container is our database. But what is written here? It says it is a schemas, correct? So in MySQL here, let's talk about the MySQL right now. In MySQL, what is the database? In MySQL, data is database, the term database, okay, it is going to be equivalent or synonymous to schemas. So now we understand what a database is, right? It's a storage system. But what I'm trying to say, tell you here is that you need to, this schema and database are synonyms in MySQL, right? So in database in MySQL is implemented as a directory that contain all the files that correspond to the tables of database. We can, if you want to create the database inside the MySQL, okay, you require admin privileges, admin access. Without admin access, you are not allowed to create, the database or the tables. And the term is schema and database are synonymous in MySQL here. And in MySQL, we can copy and clone the database features. We can keep a backup of the copy of the existing database. Plus, we can also, it also includes table structure and lot many properties like indexes, constraints, and values. As we move forward, we will learn about those terminologies too. Now, within the database here, there is one thing that we all should know about. What is that? While we are working in database, okay, there is something called as asset properties of database. This is something very, very important here. These asset properties of database here, transactions, ensure us reliable handling and management of the database. Now listen to this very, very carefully. This is something that is asked a lot for the beginners interview here. And this is something that you should understand that how things work. So there are 4 things here: atomicity, consistency, isolation, and durability. What is atomicity here? Let's understand it with an example. Okay, what it's written here is it ensures that transactions are executing in all or nothing manner, right? So let me give you an example. Has this ever happened with you that you have paid you paid online for something and they say that your transaction has failed, or if you go ahead and pay there online, okay, the amount is out of your account, but they say it is not reflected yet on their part. And if in next half an hour it doesn't reflect, they will make sure that the transaction doesn't take place and you get your money back. Have we ever faced these situations? Yes or no? Yes. That is atomicity, meaning either the transaction will take place or it will not take place at all, but it will not be left in the middle. That okay, I have updated some rows, okay, and only half of the row got updated, other half was not there. It is not going to work like that. That is atomicity. These enable developers to focus on application logic rather than failures, as well as recover of the complexity of the environment. Okay, that will be easily done too. And all of this here, right? These are solely concerned with how a database recovers from any failure, any kind of transaction or system failure that may occur during the process or the update of the dataset. And all the databases that we see here are asset compliant and ensure that only transactions that were completely successful that will be processed. If the failure occurs before we update something, If the failure occurs before a transaction is completed, the data will not be modified. So for example, I want to go ahead and based on the credit limit of a person, we want to go ahead and see which credit card they're eligible for, so that we can go ahead and call them and connect them with them via emails that you're eligible for this credit card and please connect to it. So what we want to do, we want to go ahead and modify that database and we want to add that credit card there. Yes. So we went ahead and we have kept our logic that up to this particular level, and if these conditions are met, this person should be eligible for these credit cards. And we want to go ahead and create a formula for that. But when we create the formula here, either it will go ahead and calculate for each and every person or the customer ID present there, or it will not even add that data there. That is all or nothing. All or nothing means either the transaction will happen or it will not happen, right? So the easiest example that Ali we have talked about is whenever you pay online, okay, and your amount is out from your account, but they say that we have not received your amount yet, and in next half an hour, if we don't receive it, the amount will be given back to you by the system. So that is all or nothing, because this is an example of atmosity. I'm not saying this is how database works. Database works like I want to add a column, something happens or error comes in between, all right? It is not going to go ahead and update it halfway through. It was not going to update the entire column at all. Unless it can go ahead and update each and every row within the database, it is not going to add that column. So that is atomosity. What is consistency here? Consistency is simple. Okay, it maintains a transaction, maintains that a transaction follows a set of rules. Now, what is consistency here? Consistency here says that it maintains a transaction and it follows a set of rules. Meaning, if we are about to go ahead and modify in the database, within the team itself, we will go ahead and set some rules that, okay, how does this work? And what are the set of rules that we all should go ahead and follow there? So that becomes very important within consistency. How the consistency will be maintained? If you know that if we want to go, the entire process is saved, right? If you want to modify that, or you want to alter the changes, or you want to update a database, so everything is going to be consistent. So data should always be valid. So if I'm using the date here, DDMMYY, so date will exactly be like that. That's consistency. So for example, once you transfer the money to someone, right? Once you transfer the money to someone, what happens? The bank balance will remain same. Whatever transactions you have done, the bank balance or total bank balance will remain the same. So if you have given 1,000 rupees to someone, it will only deduct 1,000 rupees. Automatically, it is not going to simply change the data there unless you don't do the transaction. So it maintains the consistency there. So that's consistency. So data must always be valid, whatever the rules of database are. So if the database rules and the limitations are set, then it will go ahead and follow those set of rules, data validations, and data types, and other limitations and constraints too. That's consistency. Third here is isolation. Isolation is pretty interesting. It ensures that transactions do not affect each other. What does that mean? It means that each transaction will happen independently without interfering each other. So for example, if I am going ahead and adding a column, then the column will be added. If I'm deleting other column, the column will be deleted separately. They're not going to affect each other. A real-time example, for example, there are two people, okay, two separate people. They're transferring money at the same time. And do you think that will happen in the world a lot of times? There are multiple people, they're transferring money within the same bank at the same time. Is that going to corrupt each other's operations? Is it going to mix up the amounts or the bank details? No. Why? Because these are isolated transactions. They will occur independently for them. So that's isolation. So while we are updating the database also, this has been taken care of and we work within that. So that's isolation. So if you're doing any kind of update, modification, adding of data, deleting of data, or adding columns, deleting columns, or any calculations inside it, or creating relationships or anything, each and every transaction statement will be separate and isolated. Now, the next to the fourth one is durability. What is durability here? Durability guarantees that written data will not be lost. So durability says that, okay, once the transaction is committed, once we have finalized that and we have committed that, then it will remain. even if the power failure or it crashes, whatever happens. But once the transaction is completed, let's say I've added a column, I've added the column values. And after that, even if the power fails or the server crashes, the data will remain within that particular server. So when you switch off your laptop, okay, the data will still remain there. So it is something like that. So that's durability. So for example, once you are paying to someone and on your screen, it displays like transfer is successful on the screen. So when it says transfer is successful there and the 1,000 rupees goes out of your account, that is permanent. Can you reverse that on your own? Okay. Once the record is created there, it will be created. We cannot undo that. So that is durability. That once the transaction is done, transaction will be finalized. And whatever changes it has done, those changes will be finalized too. So that is asset properties of databases, and all the databases must follow these properties here. So in the complete asset system, the database engine guarantees that the synchronous write options are used, hence it is preferred to physical media. So basically, we are trying to say here is in the entire asset system here, right? We the data engineers basically those who are designing the entire system and maintaining data set, they will follow this here, and it is designed based on these four properties. Now we have talked about the database and schema are synonymous in MySQL, right? So we will now see how we can go ahead and see some very small few keywords. When the instructions are given under, right? For example, I will give instruction to SQL that go ahead and add a column in the existing table. It will go ahead and add a column, right? Because I'm the one user. But as if I'm the one user, like me, there are multiple users in a team. Everyone is doing their own work. Maybe I'm updating the customer data set. Another one is updating the employees data set. Okay. So if I'm giving instructions to add a column, add the data, another person is also giving the same instructions to another table, but within the same server, these instructions or transactions are not going to affect each other. They are not going to get mixed up. I'm saying that in customer, go ahead and create a column. At the same time, if that person is saying go to employees and update the rows there, nothing is going to affect each other's transactions here at all. Or a very simple example, when you go to ATM, two people are simultaneously taking the money out of the ATM. Does that mean if you type 5K, another person write 10K, suddenly the transaction get mixed up and you get 10K from that person's account? Does that happen? No, that's isolation. That even though the more multiple persons are working in that same system, right, they are not going to affect each other, right? So let's go ahead and understand about schema and how to write the syntaxes here and what does the syntaxes and parameters mean. We'll see that too here. Now, when we say database here, right? So there are three type of database schemas. Now, what these schemas are, basic or logical and physical schema here. However, to talk about the schemas here, first we need to go ahead and understand MySQL graphic user interface and run some queries there. Then we'll come here and talk about the commands. Okay, we have already seen that these are the core type of commands there. So let's go ahead and see. Now here, this here is a schema. So we have established that there. This is where we write our queries. This particular portion also have a quick access toolbar, everyone. On the right hand side, this is the help section. Okay, what is this? This is the help section. And this is where we see the action output. What kind of action output here? Whatever query we will type here, okay, when we execute that, then the execution time, what action or what query was executed, what is the result of that execution, and how much duration does it took. That action output will be here, right? So let's go ahead. Let's go ahead and see, first learn here, how do we type something here? So first here is, do we have any database here? No, we don't have any database here. So let's understand how to go ahead and first add a comment, and then we'll see how to get data set here. So first thing we will always remember, database and a schema will be used synonymously here in MySQL and nowhere else. How do we add a single line comment? So if we go ahead and type the pound sign here or the hashtag that you call it, we can add a single line. If we want to add a single line comment, either we can go ahead with this or we can go ahead and type two minus signs or hyphens and a space here. This also adds the single line comment. Now, what is the comment here and why is it important? Single line comment here is the non-executable part. What is it? It is a non-executable part. Basically, it's the description of whatever codes and queries that you are writing here. But what are you doing? What are you working on? So whatever you're writing here, you have to write the description of that, and that is going to be the query. But not every time we can write everything, every explanation in one single line. So what we have here is the forward slash and the asterisk sign and the asterisk sign and the forward slash. So we start writing like this, all right? And if you want to the multi-line comment, we want to write in multiple lines, right? So we have to enclose them, enclosed within these here, forward slash and asterisk. Now what we want to do, we want to insert, we need to go ahead and get database, right? We need to get database here because right now what we have is a system database. It is not going to have any tables or something. It has some system details only, right? See, what tables does it have here? System configuration. It is not going to help us here. So we need to get the database. How do we get the database here? So we have got either we should have SQL codes through which query and codes through which data is created, right? So a created database here. Or we can have a CSV file. We can have a CSV file that we can import here. Okay, so we can go ahead and import the tables too. So first that we will see here is how to get the database by using the SQL codes right here, right? And how we go ahead and create the database. So let's talk about create database right now. Whatever I am writing here, okay, almost in the real time, I will update there too. Now, Excel is quite direct. SQL is quite direct. Okay, if we want to go ahead and create a database, we have to simply go ahead and write CRE. In the drop down, you can see create is there, right? So from the drop down, you can press on tab and the create will be there. You can also go ahead with the mouse there and double click on that. It will be written there. And if you're getting it in the drop down while you're writing something, select the keywords from the drop down. That will be easier to type. Now, what we want to create here, we want to go ahead and create a database. So we can go ahead and write DA. We have the database right here. Now we are creating our first database here, right? So I'm going to go ahead and name it this here, first database. I'm naming it first database here. You can name whatever you want. So this is create database, first database here. Now, first focus on what I'm doing. See, whenever we are learning queries here, follow along with me. Meaning, first, see what I'm showing you on the screen, right? I will execute this. I will show you where to execute it, how to do it. And I will show you where the output is, what is the output, and where is it. Is attention on the screen, please. You can see I have written create database and first database here. And then I have given a semicolon here. Yes. Why do we need this here? Reason is semicolon here terminates the statement. It tells the it tells the SQL that see, this is where your command or the instruction stops. Correct. So it terminates that statement. That does here. This is the statement. This is the only command that you have to go ahead and execute right now. Now, how do I execute that command here? To execute the command here, where either you go ahead and press Control Enter, right? That is the shortcut key here, or you can go to the query drop down here and see first. If you go to query drop down, there are two options here. First is Control Shift Enter. That is, it will go ahead and execute whatever you select. Select means proper select. It will should highlight it and get selected. Otherwise, it will go ahead and execute whatever codes or queries are there inside the script. We call this a script. Otherwise, if you want to go ahead and execute the current statement that we have here right now, where our cursor is blinking, right? That is execute current statement, that is Control Enter. We can also go ahead and use these here, okay? So this first lightning bolt that you see here, it will go ahead and execute all or selected. This here executes current state because it has a cursor there. So lightning bolt with a cursor will execute the current statement wherever you are keeping the cursor. Since we are doing this, we are executing this for the first time here, right? Let me show you like this. So if this is the statement, you select it like this and you execute with lightning bolt. If you want to use the second lightning bolt and we are only executing one single line, you can keep the cursor here and execute with the lightning bolt with the cursor or press Control Enter. So when we click here, see what happens. In the action output, it is saying green sign and we have create database here, one row affected, right? But even when when it is affected here, are we able to see anything right now here on the schema part? No. So you have to go ahead and refresh the schema right here. So first, We kept our cursor inside. We have executed this, right? Now go ahead and refresh the schema. So once we go ahead and refresh the schema here, we find our database right there. Of course, currently it's empty. Okay, it has got nothing inside it. Once we execute the statement, okay, we will see the output. We see the action output here. But if we want to go ahead and view the schema here, we need to refresh the schema. And there is a small refresh button here. Click that, you'll find this here. So first, this is first, this is second, and this is going to be the third step. Okay, this is administration. Just towards the right, there is schemas. When there is a small refresh button here, I have given too many highlights on this. Can you find this on your own, please? See, right. And what were the what were the ways to get to the database here? First, we could have created the database by ourselves, but now we have to create the table. Inside the table, we have to insert the individual row too. So now, instead of doing this, let's go ahead and import the data. Now, how do we import the data here? From the .sql file, in which already the codes are written for us. This .sql file is in the session material that is called as MySQL sample database folder. If we will go ahead and expand and extract that folder, everyone, go to the file drop down, left and upper corner. On the file drop down, we have fourth option, Open SQL script. So we are here, file drop down, left and upper corner. You click on Open SQL script. Those who are working in their systems, just follow along and find where your file is. And the person who is working on the lab, go to desktop. In the desktop, you will find a classic. You will find the classic models folder. Inside the classic models folder, you might find the file. So we are going to the file here. Click on Open SQL script. Find where your script is, wherever you have saved it. And click on Open here. When you click on Open, do you see these blue colored lines? If I scroll down here, you will find that, okay, they have created a database on the 26th line, and then they have created the table, and then they inserted a lot many rows there. So it's all written. Now we don't have to do anything else. Just keep your cursor anywhere, doesn't matter where you're keeping the cursor. Keep the cursor anywhere, doesn't matter. Just go to the query drop down here and click on execute all. Once you have opened the SQL script here, go to the query drop down and click on execute all. So when you click on execute all, everyone, okay, there will be action output. Some will be green colored checkboxes, some will be warnings. For now, please ignore all of that. So once you click on execute all, okay, wait for 5 seconds there, and you will see a lot of check signs and the green warning signs there, and that's perfectly fine. We don't see classic models right here, okay? So please go ahead and refresh, please. Again, please refresh these schemas here. When you refresh the schemas here, please confirm, are you able to see classic models right now? Yes. Now I would also like you to pay attention here. Do you see now we have two tabs here? Do you see we have two tabs here? One is MySQL sample database and another is where we were writing the queries. Do we see that? Yes. So we have classic models right here. We have refreshed it, and yes, we have got two tabs, everyone. One tab will be for MySQL sample database and one for query one, right? So please switch back to query one and close the MySQL sample database. We don't require it anymore. So please close this one. It will be saved in your system. Please close this here and keep only query one. And go ahead and save this too. Once you'll try to save this, dialog box will open up. You can save the query by going to File drop down and save. Then you click on save here. Okay. You will get the dialog box and you can go ahead and save your file within any name that you're looking for. So make sure you are where you are here, where we are saving, where we are writing the codes. Now this is the classic models, right? Now we inside the classic models here, I would like you to expand, please expand the classic models. You will see tables here. When you expand the tables here, you will see list of tables right here. We have got multiple databases also here, correct? So how do we go ahead and see what all the databases that are present here? Okay. So we can simply ask it that why don't you go ahead and show? Why don't you go ahead and show databases? The next step, Ali, is to write show databases, because now we have multiple databases here, right? So we simply go ahead and ask it to show databases. Then it is going to give us the hidden databases too that we don't see here in these schemas. So we simply go ahead and write show databases. We can see the list of databases here. Yes. Now, what do we see here? What is this? We are looking at this particular quadrant for the first time here, because the output is there, right? What is this? This is called as result grid. This is called as result grid. Result grid will show us a temporary output. This is a temporary output. So when we write a show databases, what it is doing here, it is showing us the list of the databases here. And this is going to be a temporary output that we can see or export. So we can see it here, okay, and export it from here. So whenever you ask for a whenever you go ahead and ask for data from any database administrator, what do? They give you a CSV file, right? Most of the time they will give you CSV files. So you get to export it from here. This is your temporary output. We will go ahead, keep my cursor here. My cursor is here. And this is the lightning bolt with the cursor sign. So I will go ahead and execute this. And here we are. Or you can press Control Enter. And we see a temporary output. This temporary output can be closed. We have talked about different databases, right? We have talked about DBMS. DBMS is simple file systems that we have in our own laptops. Second, RDBMS. What are RDBMS? Like Oracle, MS SQL, PL SQL, PySQL. We have MySQL here, right? All the Snowflake is there. It is also a type of RDBMS, relational databases, where data is connected to each other, correct? Then we have got object-oriented, NoSQL. In NoSQL, the data is not saved as a table. It is saved as an object or JSON values there. Why? Because it contains unstructured data set. Like you have videos, you have your videos, podcasts, comments, blogs, posts, pictures. So it geographical data set that is too huge to be saved in a table. Those kind of things are saved within the objects there. Then we have graph databases. Graph databases save the networking within the hierarchy or a flow chart. It has got parent node, parent and child relationships, start node, end node, relationship node. So that is graph databases right there. So as we have already discussed, when we talk about graph database, we are talking about LinkedIn, social networking website, how they are tracking that whom you are connected with and how they are interconnected with it. That's your LinkedIn. You go to Facebook, you see the recommendations right there, right? That is the real scenarios there. So this is where these databases are created. Whatever databases are there, when we talk about our DBMS, for example, there is an office, an organization there. That entire organization is collecting data from multiple sources. What are the multiple sources an organization is creating data set? So here, how do you think the data is getting into the servers? All of us go there. All of us go to the office, correct? And do you go ahead and swipe your card? Or maybe you use the biometric attendance? Do we all do that? Yes. You are creating data. You're creating data. Where does that data is going? Where is it getting saved? We all have a portal in which from you can go ahead, regularize your attendance, check your attendance, and apply for leaves. You can download your salary slip. You can check everything. We have a portal, right? That portal is like a website. That portal is like a website, correct? Now, if that portal is like a website, where are they collecting their data set? So at the back end, that website is collecting their data set somewhere. That is their database. But is that database your server? No. Is wherever their data set is getting saved at the back end, is that your database? Or is that your Oracle server or MySQL server? No. So what happens here is, like we have HRMS software there, and the similar basis, we also have, okay, we also have database engineers that will go ahead and connect these application data set to our server, and they will make sure that whatever data is getting created from all the departments, maybe the sales people are using Salesforce and data is getting updated there. So what are they going to do with that? They will go ahead and they get that data first. They'll go ahead and they get the data first from multiple different options. Now those can be multiple different websites or portals or APIs where that data is getting saved. And once they will go ahead and get the data in here, then end users like us will get to go ahead and extract the data and actually work on that. So as an end user, I am not concerned from where the data is coming into the server. What I am concerned is if my job role is in finance, if my job role is in operations, and I have been given an objective as a data analyst, we have been given an objective that as a data analyst or a business analyst, that you are working in an insurance sector. You have to increase the sales by 10%. You have to increase the sales by 10% in next quarter. How will you do it? So what will you do as a data analyst, everyone? Yes, we have to gather the data. You can get the previous sale detail. You can get multiple product details, customer details. After gathering the data here, now you have to go ahead and manage the data, meaning ETL. You'll extract the data. Do you want data from the server? Do you want data from certain department? Or do you want data from the outside? Correct. Now you will go ahead and extract that data. From where do we extract? Any server or cloud, right? Not every time you'll have a server. Might be your data is saved in a cloud. You need to get your data from the cloud there. Once you have data in any kind of BI tool, then you go ahead, visualize it, analyze it, predict it, forecast it. Now that goes there. So where SQL is getting utilized, everyone? SQL is getting utilized where we are extracting the data from a server. Remember that as we have established first here, SQL is a language that is used almost in every software. If it is not SQL, then SQL-like language will be used. So it is a foundation here to understand and learn so that you can extract the data from whatever server you will face. Okay, as per the discussion. Right. So there is something called as DSA. There is something called as DSA. What is a DSA here? That is your data source administration. This is done by database engineers or the developers, right? These engineers or the developers, they actually go ahead and they will connect. See here, it is called as data source administration, okay? First, they will connect the raw data, right? It can be any kind of, it can be any other database also. It can be a website, it can be a file, it can be any cloud, AWS, Azure, Snowflake, or your Tableau cloud out there, or any kind of cloud, or any portal that you guys have, right? Or in your office. It will go ahead and connect with everything. And then it performs the actual ETL here. It can be your Tableau, it can be your SQL server, it can be Oracle, or you can use Python for that. You first go ahead, extract every raw data from there, and you go ahead and perform the ETL. Within your SQL, then they build the data model. Who does that? All database engineers, not us. These engineers will decide the data model, meaning which tables are there, what should be the common column there, what is how the tables should be joined, or they should be normalized or denormalized, whether they should blend together or not. They will build the data model, they will create the entire structure of the database. And then the data governance is applied, meaning security is applied, row level security, column level security. Metadata means your information about the database and the primary keys, limitation, constraints, everything is put in place. Security as per the user will put in place. Different layers will put in place for security. And after that, data profiling will happen. They will conduct EDN validation. They will make sure everything is working fine. And then at the end, they will go ahead and they will publish that data set for everyone. After publishing that there, now they will be managing it, updating it, and taking care of it. Once everything is done, then we go ahead and get everything here. You don't have to know about it. This is done at the back end. What we are concerned with that I have a database. Now, in the database, I have these many tables. I need to solve how my customers are doing. So how do I write the query? So that we can go ahead and extract the data. Okay. So this entire structure here is huge. And it has multiple people working in that. So let's have a quick recap here. Let's recap our interface, everyone, right? In this interface here, these are menu drop-downs. These are menu drop-downs. This is our quick access toolbar. Once we open it, we already have the previous day one opened up right here, correct? Now in this day one here, and this is our schemas. This is the schemas here. How do we reach to these schemas? We have got two tabs here. One is administration and one is schemas. We have to simply click on it to switch between them, right? Schemas and database. This terminology here in MySQL is used synonymously. Okay. Now we have learned about the comment first. Why we have learned about the comment here? Let's see, understand this here. For example, get database is a comment. What is a comment? Comment is a non-executable part because someone has asked that why we are using these symbols. These are not symbols, these are notations. Okay, we are communicating to SQL that see, this is not a command. This is not a command because if I am not typing the pound sign or the hyphens here, it what does it think that this entire part is a command? This entire part is a command, which is not, right? This is why we have to go ahead and either we will go ahead and type two hyphens and a space to inform SQL that see, this is a comment. What is a comment? Comment is any kind of description we are about to write. So as in when we move forward, you will understand that why comments are necessary. And when we are writing a direct statement, okay, we don't have to give any symbol right here. We can directly start writing the comment. All right. When we go ahead and write a statement here or a command here, you can say, meaning we are commanding MySQL to do something here, we write create database. Let's see how do we go ahead and get this classic models right here. So we go to the file drop down. We click on open SQL script. Go ahead and find out where your MySQL sample database is downloaded. Wherever it is downloaded, select your .sql file here. You might not have the extension written there, but you will find this .sql because that is the only file it will search for. Once you will find the file wherever it is, go ahead and click on open. Once you click on open, you will see another tab is opened up, right? As soon as you see another tab opened up here, go ahead and execute it. How do we execute it here? We keep the cursor inside, we go to the query drop down and click on execute all. Okay. Just keep your cursor here anywhere, doesn't matter where. Go to query drop down and execute all. You can see the keyboard shortcut Control Shift Enter. Once you'll execute all, wait for 5 to 7 seconds there and then click on refresh right here. Click on refresh. This is a refresh button here. Refresh the schema and you will find classic models right here. You can expand the tables here. You will see the list. Just below the file tab here, we have a plus SQL icon just below the file tab. So let's open up the day 2 file here. So go ahead and click on plus SQL here. When you click on the plus SQL here, you will find the file will open up in the next tab right there. First thing that we do here is we save it right from here. So there you will find a small quick access toolbar just below your script file. This is again a small quick access toolbar. So here we have a save icon right there. So after clicking on plus SQL, go ahead and click on the save here. The save will open up a very familiar dialog box here. You can save it with any name you would like here. Once you have added and saved, yes, file is saved. This is where we work. Very good. So this is our action output. There is too much action output. See here, output is filled because we have executed the classic models. If you want to clear your output here, you can go to output, right click here and clear. So if you go to your action output window, everyone, okay, if there are too many output lines are here, you can right click and clear so that now when we write any new query, we will be able to identify easily about the output. If say, there is something in the output, right click and clear. While you're doing it, let's go ahead and talk about today's agenda. So before we have already seen the how to create a database and we have imported the .sql, right? We have imported the data.sql. We can also go ahead and import CSV files, everyone. We can also go ahead and import CSV files. So what we are going to see today first we will go ahead and see how to import CSV, right? How to import CSV here. Next, we will move forward and look for, we have seen create and show databases, right? A very simple thing here. But today we are going to talk about first data type in SQL. But we have to understand the data types in SQL. After understanding the data types here, then we will move forward with the select query. Now, what is select query? Why? What is the sequence of select query out there? What is the syntaxes of that? We will understand about the select query. So first is importing the CSV, then learning about data types in SQL. This is about today's agenda. Do we have the first database here, which is empty? It has got absolutely no tables. So now let's go ahead and import a CSV file. So under the assisted practice dataset, there is under the lesson file, there is an employee table. There is an employee table. So it is inside the dataset folder. Inside the dataset folder, you will have the assisted practices folder. In there, you have got lesson number 5. In that, we have this one CSV file, employee table CSV. So let's go ahead and import this table inside our database here. How do we import it? We right click on the tables, everyone. Right click and go to the fourth option, table data import wizard. Go to the fourth option, table data import wizard. We go to tables, first database and tables. All right, the blank database that we have here. Go to tables, right click and table data import wizard. When you click on table data import wizard, what are you looking at? This dialog box here is asking us to browse. So let's click on browse here and find your database, please. So inside the materials, you have dataset folder. It is assisted practices, lesson 5, employee. Find your CSV table, please, and click on open. When you click on open, the file path will be here. After this, just keep clicking on next. Do nothing. Keep clicking on next until you reach to the finish button. So click on next here, no changes. Click on next again, no changes. Click on next again. This is only for us to read. Absolutely, you don't need to go ahead and do anything here. Just click on next again. Once it is executed properly, it will simply check it by itself. Then click on next again. It will tell you 20 records imported. And then click on finish. So keep clicking on next until you see 20 records imported. Once you see it there, just click on finish again. Right, so right now we've imported CSV, everyone. Now we want to view what kind of table it is. How do we go ahead and view the table right there? To view the table here, over the cursor over here, and you will find 3 gray colored icons, information settings here, and a table with a bold sign here again. So go to the third icon, a table with a bold sign, and click on it. When you click on it, observe what happens. When you click on it, observe what happens. Table is displayed. How is it displayed here? A new tab is opened up and a query is written for you. Correct. Now what see here, now the entire employee data is selected here, right? Properly in tables and columns, rows and columns here. This is employee ID, first name, last name, gender, role, department, and everything else is right there. We can see it here, right? And what we will be focusing on the query that is written for us. See what is written here. Select asterisks from first database, that is the database name, and the table name right there, ending or terminating with the semicolon right here. So what is the syntax right now? So I will go back to day 2. Remember to switch back to day 2, everyone. Remember to switch back here. How does this select query is looking like? What is asterisk here? Meaning all the columns. Okay, what does this mean? That we need all the columns. Now within the select here, we are asking it that go ahead and select all the columns from where? From first database, inside first database, go to the table. So we have to give the entire address here. In the entire address, first we are giving database address that go to this database. Inside this database, go and fetch the entire columns of this particular table. So we are talking in a very simple language here. Okay. So if someone will ask you here, you are having dinner. If you ask ask someone that can you go ahead and get me the salt and sugar from kitchen. It's that simple. So they will go ahead, whatever they find, they will bring it back to you. Either you can select everything or you can pick what you need. So here, the entire address right there. Let's go ahead and understand here, how does that work in real time? So we are going to work on classic models, everyone, right? So in this particular table here, I would like you to observe here, employee ID, first name, last name, gender, role, department. What what type of data it is? Text. These are all text. Whether it is alphabet, alphanumeric, it is going to be text. And most of the time, we are holding on to text, right? Let's look into the experience and salary, employee rating. This is all numbers. So first is data types in SQL. Let me cut and paste this here. So first type of data here is always text or character. Most of the time, the dimensional detail that you will find is that you're going to find in a text format or text data type. Text data type is sometimes also called as character or string. In SQL, how these data types are defined? In SQL here, these data types are defined with CHAR. CHAR, that is car. What is car here? Car means a fixed length character. Car means a fixed length character that all in all, the length will be similar. What is meant by fixed length here? In a fixed length mean any kind of ID or unique code or unique ID that we provide. For example, employee ID. Employee ID is fixed. Everyone will have either alphanumeric employee ID. It might have 6 characters, or it might have 7 characters or 10 characters. Character means any kind of code or ID is given. Employee ID for the entire organization will be fixed. If there is a product ID, it will be standardized. Or any kind of error codes or defect codes, if we have during the operation cycle, that will also have a fixed structure and the format. Okay. So that is character. That kind of columns are defined by character. Next here is varchar. What is varchar here? Very simple. Varchar has variable. What is meant by variable name? Name of anything. Name of anything. Name of city, product, first name, last name, country, whatever is out there. That is varchar. Varchar means variable length. What is meant by variable length here? Whatever data we are going to write in multiple rows, we cannot say that their length is going to be always same. Not everybody's name is same. Not every city name is similar. There is no fixed format for that. So it will have a variable length across the rows. That is why it is varchar. We do have more text or string, but these are the most used ones. Then we have numeric. In the numeric here, first is the integer. Example for the integer. We know that it's a whole number. What will be the example of integer? A whole number. What kind of data will be whole number? Without decimal, Lokesh. Whole number can be number of projects someone assigned with. Whole number can be number of cars parked on a certain day. Sometimes we are only looking for the whole number age, quantity in inventory, correct? That's also that is also integer. How much quantity we sold out? How many total employees are hired this month? How many got retired? Defective number of product, number of defects in a product. Marks can be in decimals, not always whole number. So these are the few examples of whole number, okay, in real time. Now we have float or double. So either we call it float or we call it double in here. Yes, no worries. We are all learning. So this is float or double, right? What is float or double? So here it is with decimals or fractions. So maybe we give me examples for decimals and fractions, everyone. What kind of data set can be in decimal or fractions? Right, sales, profit, any kind of continuous numerical variable with the larger number out there, it will be float or double. But we do have one more type here called as decimal. What is decimal? It means again the number with decimal or fractions. Again with decimal and fraction. Then what is the difference between them? Then what is the difference between float and double and decimal if both the numbers are written with decimals or in fractions? Right? It is again based on where are we using it. First, in the float here, okay, in the float here, we are using float or double data type whenever we are working with wherever we can round off the decimal, wherever we can round off the decimal, where we can use rounded off decimal values, right? So we can have, for example, we are writing here 45 point, let's say, multiple options right there. If I can round it off to 45.9 only, I can go ahead and write it with 45.9, for example. Then I can go ahead and write it because I can round it off, or I can simply get rid of the extra decimal points there. And it is not going to impact my last answer. What kind of values are there where we can work like this? Any kind of mathematical or statistical value calculated, like your average, mean, median, mode, standard deviation, variance, probability. Whenever you are going ahead and calculating any kind of values like these, right? And if we have too many decimals at the end, we can round it off or cut it off. That, okay, I don't want too many decimal points, let's cut it off to one or two. In that case here, we use float or double. Where we don't have to stick around here, we can round it off. Then where do we use decimals? We use decimals here where my decimal numbers are fixed, and no matter what happens, we cannot go ahead and simply round it off or cut it off there. What can be the examples here? I will give you a very simple example. Would you like anyone to round off your compensation for the work you have done? No. So when people are actually writing the any kind of accounts and finance data, right? They don't round it off. They'll keep every decimal out there. Correct, Avani. Any kind of commission calculation, salary calculation, any calculation based on any kind of accounts, they don't round it off, right? So this is where the data type will come. Now you will also find there are many other data types too, like big integer, small integer, medium integer, tiny integer, based on the length of the integer out there. And you will find more. So when we will actually encounter that, we will see multiple different numerical values or numerical data types there. Then we have date and time. Now, where do we find date and time? So in date and time here, we can of course go ahead and type date separately. We can go ahead and type time separately. Of course, if we have date and time, we will have the date and time stamp also with us. So either we have date time stamp here or we have only time stamp here. This is standard everywhere. Okay. Another standard here is that your year should be separately written, because sometimes if it's a time series data, we'll only have years. Now, years can be either in 2-digit format or 4-digit format. That is also true. That's how we also write it in general life. However, in MySQL, the date format is fixed. In MySQL, date format is fixed. So if you're importing CSV or you are just inserting the file data inside it, right? Your format should be year, month, and date. If your data is written like this within the double quotes or single quotes there, then only it will recognize this as date and time. As date and time. Time is hour, minute, and seconds, similar to Excel. If we will go ahead and we will not type any spaces, anything out there, okay, like this, again, it will be considered as a date and time. You want a timestamp only, then it will be hour, minute, and seconds. It will look like this. And a 2-digit or 4-digit year format, we all understand that. 25 or 2025. You can write it anything like that. So this is your date and time here. There are a few things that I would like to remind everyone. Always end the command with semicolon, right? And if you want to go ahead and execute a certain statement, right, then go ahead and you can type, you can simply go ahead and execute with keeping a cursor there and pressing Control or Enter. Okay. So all in the script, or select, or I will type or here for clarification, or select current statement, or keep your cursor there and execute. To execute, you can also go ahead and press Control and Enter, or we can use these lightning bolts right here. Use the second lightning bolt. For one statement, we use the first and second lightning bolt here, which is a cursor on it. Okay? Now we already know how to create a database. We have seen that. We need to create a database and we can have a name there. We can go ahead and show the databases too, right? There is one very important thing that we should know. Keywords are not case sensitive. Only the keywords that we use, like create, database, and more, these are not case sensitive. All right. So how many databases do we have right now in the server? To see that, we will simply go ahead and type show. When you type sh, in the drop-down show is here. We can go ahead and select show space. We are looking for databases. So we type databases here and we end the statement with semicolon right here. Now see here, when the cursor is blinking here, I want to execute this statement. Either press Control or Enter, or simply go ahead and click on this lightning bolt right here. Why I'm explaining this in a very detailed manner right now? Because I've been asked at the start of the session that show it again how to execute it. That's why. So I don't remember your name there, but now do you understand how to execute a statement? Write a statement and execute it, please. Now, this temporary output that we have right now with us, it can be exported to CSV. This is how you get CSVs whenever you ask your organization, give me the data. So this is from where you get your CSV files. So MySQL exports to CSV, right? So if you want this to be exported, you go ahead and ask it that export this to a CSV. Your HTML, JSON, Excel, whatever you want, you can get it from. Okay. So it can be exported to from. This is your temporary output. Now next here is we can cross it and close it. We have a cross sign here, an X here, right? We can close it right there. Now let's move forward and let's learn about the select queries, everyone. Let's learn about the select query here. When we talk about the select query right now, we are talking about reading the data set or retrieving the data set, right? There is a writing sequence. There is a writing sequence. Do you remember the SQL operations? First, retrieve the table, but I want to choose the columns and filter out the rows based on maybe country or credit limit. Then I want to sort the data set. So first option that we have here is select. The writing sequence here, first is select. Select will help us to choose columns, right? If I want to choose a column here, then I can use get me employee ID, employee name, like that. But if I need all columns here, what do we do? If I need all the columns, what do we write? Yes, very good. We go ahead and then we type asterisks. After select here, we have to also tell MySQL from where are we getting it. So the second keyword that we use here is from. And from here, we give the entire address about it. What is the address here? Address is first your schema names comes in. First you write your schema name or database name. All right. Then we type a period there or a dot there. And then we go ahead and give the table name. We go ahead and we type the table name. So we are giving the entire address from there. Okay. After from here, if we want to go ahead and apply any filter, we have a where clause. This where clause will help us to the filter rows from database directly. It will apply the filter on the rows from within the database there. This is where clause. Now after where clause, we have more options here, more keywords here after where, that is group by, having, order by, and limit. Order by is sorting you out. Order by will sort you out, right? What limit will do here? Limit will limit the number of rows and out. Number of rows and out. So the temporary output that we see there, right, to export. If you want to see only 5 rows, 10 rows, it will simply limit it. From defines the source of data that we are looking to retrieve. Yes, you can say that. So we are simply asking it that go to this particular container. Inside this container, this is the table. So let's focus on these 4 clauses first, right? And then we will move on and learn this. First, let's start a small with select and from. We have the classic models here, right? So how does the syntax looks like for select here? Now we understand that very easily. We have to write select. We have to define whether we want a few columns or one column here. And then we will ask it to select or define columns from schema name right there. This is how the syntax looks like. So let's go ahead and write it here. We're going to write here select. I'm selecting from a drop down, select. Right now, let's get all the columns because we are not aware about how these tables are. Select everything from. See here, I'm simply typing and selecting from the drop down. From where? Classic models. So we will type here CLA. See, classic models is there in the drop down. It says it's a schema there. Select it with the tab or double click on this. I've selected this. Now we want to define the table. So we click on, click the dot there, type the dot there or the period sign. You will see the list of tables inside it. So let's look at the customers table right now. That is the first table here. Click on tab or double click on it and it's there. Now we put a semicolon here. After you put the semicolon, control enter or click here. Once you click here, you will find the entire customer table is here. Also look at the output here. It says 122 rows are written, meaning in this entire data set, we have got 122 rows. Select it from the drop down. Do not attempt to type the entire thing. We are humans, we'll make these spelling mistakes very easily. Currently, we are getting all columns. Okay. Currently, we are getting all the columns. Now, next we are going to see here how to select only one column. Select only one column there from the data set. How do we go ahead and select only one column? If we want to go ahead and select only one column, we will type select. All right. And let's see from the customers table here, we simply want to get only customer name and nothing else. Okay. In that case here, what do we do? I will not go ahead and type that column name. Absolutely not. Okay. Let's use the graphic our interface here. When you expand the customers here, you will realize you have columns right now. When you expand the columns, you will be able to view all the column names right here. Okay. Once you're able to view the all column names right here, if I want to type any column name here, we have to simply double click. We have to simply double click on that. Once you will double click on that, it will automatically types that into the script. First, everyone expand, reach to the customer column names here. Now, after select here, when the cursor is blinking, I'm going ahead and double clicking on customer name and see it appears here. Now, from where do we want it? So we will type from again. We will ask it to go to classic models again. And from classic models, go to customers again. And it will only retrieve one single column for us. In the similar manner, if we want multiple columns, if we want multiple columns to be retrieved, what do? We go ahead and type select again. And this time, we will simply double click on multiple columns. For example, double click on customer name, comma. Next, maybe I'm looking for their country, comma. Next, maybe I'm looking for their credit limit here. So keep typing comma here and we are good. After this, again, I can copy paste from here. Why to write it again? So copy and paste it. We can paste it in another line also. Why? Because we're terminating it here. So it understands that unless the termination doesn't come, this entire is one single command. So if I keep my cursor right here after typing this in 2 lines and I execute right here, you will find we have customer name, country, and credit limit right here. First try it out for one column, then give comma and try it out for multiple columns. We are using the hashtag sign here to tell SQL that this is a comment I am writing. It is not a comment to be executed. It is not a command to be executed, is it? It's a message that I'm writing here for our own understanding. We use the hashtags or the hyphens. Vaishnavi, why it is there? What is the comment? Why do we need it? Because we need to differentiate between a command and just a message that is written for our own understanding. This message is written for our own understanding. SQL doesn't need it. All right. So now we have one column and multiple columns, everyone. Let me show you something here. Whenever we are writing this here, this is how we are writing. Okay. But there is a way to type it. It is not a functional language, but it does have a format to be written. Since we are new and we don't know that here, so go ahead and select these 2 lines here and go ahead and click on this brush right now. This is the beautify brush. What is it? It is the beautify brush, or the shortcut here is Control B. So beautify, or you can call it reformat. It is beautify or reformat here. Reformat. Okay. It will simply write it in a different manner, in a proper functional language. So see here, how does it look like after beautifying it? So I'm going to select this entire command and click on this paintbrush. Once I click on the paintbrush, this is how it looks like. Select properly spaced name from and properly spaced address right there. Okay, you do not have a database called as employee table, Dhanam. Sorry, you don't have a database called as first database. This is the way it should be written. Which one looks better, first or second? First one is better or the second one? This is how we have typed it. This is how it has beautified and written it. Which one looks better? Right. Absolutely. Second one looks better here, right? However, it is better to read. If I revisit this particular script, then it will be easier for us to read and understand. However, it is not that easy to write. So writing is easy here, but when we want to revisit it, this is the better way to do it. Just a way for you. If you're writing a too long queries, always beautify this. It will be easier to read. So let me also write with you here. So here we go. I will ask it to select here, select, and we will simply double click product name, comma, double click on buy price here. And now we know we can simply copy paste from classic models customers. But we don't want customers to we know we are looking for product. So we have to write classic models again and get the products here. We can choose to beautify this and execute it here and we get the answer. There is one issue right now here. Since we are working on one single database, all right, every time whenever we are writing a query, we have to write classic models multiple times. So how do we get rid of that? We go ahead and we set the database as default. Let's see, whenever I ask you here that go and get the products table, go and get the employee table, go and get the orders table, whatever table I will tell you, go ahead and go to the default database. How do we set a default database here? We will type here that use classic models from here on. Meaning from here on, go ahead and use only classic models as a default database. When we go ahead and execute this here, our database turns into default database. And how do we know it has turned into default database? See here, I'm writing this here. I am executing it right here. The moment I execute this, classic models will turn in bold right now. Another way is to set this as a default. We can right click here and set it as a default schema so that whatever table name we write, it will go ahead and get that table for us. That is default schema here. You can also double click on it and turn into default. So for example, if I double click on first database, it will turn bold. It is default. If I double click on classic models, it will turn bold, meaning it is default. So there are multiple ways here to set the database as default. It is a very simple thing that we are writing here. Use database. It is setting this as default and observe that it will turn into bold. Once we will do that here, if I go ahead and say that, okay, select everything from, and let's say we need from orders. So now I will not type the table name. See it very carefully. Now we are not writing classic models name here. I want to directly write the table name here, for example, orders. So if I want the orders table here, I will simply go here and double click even on the name of the table. See here, select everything from. I don't want to type classic models anymore because it is set as default. So we go to the orders and we double click. When you double click on the orders, automatically orders will be written here. We can end it with the semicolon here, execute it, and see the orders are here. Okay. Go ahead and get this, please, without writing the classic models and wait for your responses. From now on, whatever we type in this script, right? We don't need to type the classic models again. If you're using any table that is present within this database. How do we type the table name now? Instead of selecting from the drop down, now we can simply double click here. We get the table name right there. Observe that here selected from is written in caps. Here selected from is written in a smaller case. Both are working fine. Why? Because it is not case sensitive. We will go ahead and now we will see how do we filter the rows here. To filter the rows here, let's go ahead and we have multiple product, right? So right now we will go ahead and get the product name and buy price. We will go ahead and get the product name and buy price. However, this time we will get the buy price and the product name, okay, which are lower than 100. Okay, which are lower than 100, meaning buy price is lower than 100. So we already have this here. We already have the product name and the classic models product. We already have this here. So let's write it again. So we are typing here select. We will go to products table. We will say that get the product name, comma. Now get the buy price. From where? From products directly. So we double click on products now. We have the products here now. If we go ahead and execute this, we can see the buy price is right here. Buy price is right here. Oh, I see everything is already below 100. So let's make it below 50. Okay. Wherever the buy price is lower than 50. So how do we introduce the filter here? After from here, we will go ahead and type where clause. Where. where what is the filter we want to put? We want to say that go and check the buy price. Go and check the buy price. So we can go ahead and double click on buy price again. Where buy price is lower than 50, meaning less than 50. So we can go ahead and use the less than sign here. So buy price is less than 50. 50 is a number. Okay. So when we go ahead and execute it now, this here, execute this here, how many rows we have right now? So originally we had 110 rows. See here, originally we had 110 rows. Once we filter it out, we have only 48 rows. We have only 48 rows. See here. Yes. If I have only 48 rows, can you tell me that among these 48, where do we have the highest buy price? Which product has the highest buy price? To find the highest buy price, we have to sort it. How we can sort it? I'm going to copy paste the exact same thing here. After where we can ask it to order by. Order by which column? By price. Order by a certain column. So we filter by order by. We are sorting also by order by. Sort means arranging my data set. So in the order by, if I ask it to order by price here and we execute it right here, see, this is the lowest price we can see here. So right now we are by default, it is will sort or arrange the table in ascending order, or you can say in increasing order, right? If you want to sort it in descending order, then we will simply go ahead and define that get the descending order. So after buy price here, now we want to set that in descending order. So for descending order, we will simply type DESC here. If we type DESC here and we execute it right here, we'll find the highest value. If we don't define anything after order by and we execute it, we have the lower price up. So what we are doing, we are applying the filter and we are sorting our output too. Go ahead and find it out. First, filter it out. You already have the filtered list. Now what you will do next, we'll move forward and sort your value or sort your result out. See them one by one. And this is the less than sign. It's a simple logical operator, everyone. Or you can call it a conditional operator. Go ahead, execute them one by one and let me know. We still have less than 10 responses. Order by here, right? What is order by? Meaning sorting my data set, arranging my output. So if I simply go ahead and ask it to sort it, or ask the result rate just like this, right? It will give me, there is no sorting order. Is your table arranged, output arranged in any manner? Is it alphabetically arranged? Or is the buy price arranged in some manner? Not arranged. So what we do here? We will ask it that why don't you order it as per the buy price? When we ask it to order by the buy price, by default, it orders in the ascending order, increasing order of the buy price. But what if we don't want this? What if we want it descending or a decreasing order? So we go ahead and we write the exact same thing. We ask it to order by buy price, but in front of that we write descending. DESC. We define that right now when you're arranging the table with the column by price, make sure you sort it in the descending order. So it will sort this into the descending order. That's order by. Order by means sorting the output. Again, I have a question for you. Okay, can you get me the customers from country France, and sort the name in ascending order? Well, can you go ahead and write the query for this, please? What table you need, what columns you need. First, tell me which table we should go for. From which table we can get this information. So we should go to customers table. Very good. Which columns do we need in the output? So you are telling me from customers is done. Right. Now, which columns do you need? Which columns do we need? Country, we do need country. What else do we need? Who are the customers, right? We need customer name too. Is this the output we are looking for? Very good, Mana. Is this the only output we are looking for? No. We need not from all countries, only from France. So now once we have selected everything here, after from, we need to go ahead and apply where clause. Why? Because we are looking for country should be France. So when we are looking for that here, we will go ahead and double click on country again. And this time we use another operator that is equals to sign. And now we will go ahead and type France. When you're typing France here, since France is a text, it has to be encompassed inside either single quotes or double quotes, right? So whenever you are writing a text or a date, it has to be encompassed inside the double quotes. Then only it will able to understand what we are looking for. So when you go ahead and ask country from France here, in the output you will see you have only 12 rows here. Here we have what? Only 12 rows here, right? Now we want to sort it by here. So now the country name is similar. So how do we sort this by here? So we can order by here with customer name. So we will go ahead and double click customer name right here. Even if I don't write ascending, it will be in the ascending order, that is A to Z. You can also go ahead and define ASC, that is ascending, that will also set it in the ascending order. So whatever we are looking at here are, okay, all these are your conditional operators, right? These are all conditional operators. So we are defining conditions, individual conditions with it. So these are known as conditional operators or logical operators, you can say. What are these? These operators are equals to, less than, greater than, or any combinations of them, right? This is not equals to, you can also write not equals to like this. So these are the conditional operators, everyone. And this is how we use them to define one single condition, right? I will go ahead and write this in the code share. You can get it from there. And let me know when we can move forward. Because next, what I would like to know here is list of countries. What I want list of countries customers belong. List of countries customer belongs to. This is what we want to get. Okay. I want only one column. That is country. So we want list of country. So let me know when we can move forward. I will be waiting for responses, okay? Yeah, they are also called as comparison operators. Okay, how we can get to the country column only? How we can get only country column here? Where we can have all the countries, everyone. So this is simple, right? We want to select what we want to select. We want to select country. From where? From customers here, right? If we want from customers here, we execute this here. This is the country list. Is this correct? Do we have here 122 countries? No, there are duplicates. There are repeating items. Duplicates are there. So how do we get rid of duplicates here? We get the unique list. So what exactly we are looking for is to get the unique list. How do we get the unique list here? So basically we want to go ahead and remove the duplicates, right? We want to remove anything that is repeating, that is duplicates. So we will go ahead and copy paste the exact same thing, but we use now functions, right? Functions and keywords. The keyword here is distinct. The keyword here is distinct. Distinct means unique, right? So if I go ahead and write here distinct, it's a keyword, right? If I use the word distinct here and we execute it right here, now we see that we have 27 rows written and there are 27 countries there. This distinct can be written either as a keyword or sometimes you will also find distinct written or used there as a function. So when it is used as a function, distinct will be followed by the opening parenthesis. And after the country, it will be closed within the parenthesis and closed like that. So sometimes you'll find it like this, sometimes like this. Both are absolutely correct. They will get you the same answer. Okay. So this is how we get the distinct here. So go ahead and get this distinct unique list there. If I ask you how many countries are there, you have to look at the output, right? 27. Now what if I don't want to see the list of all 27 countries, right? We don't want to see the list of all 27 countries. I simply want to know that how many countries, how many number of countries are there? How many number of countries are there where we are shipping our product? I simply want to know how many number of countries, meaning total number of countries, meaning total number of countries. To get the total number or answer for how many, the function is count. The function is count, right? So how do we use this count here? We want to count how many total number of countries are there. So we already have the list of countries. We want to simply count this list of countries here. So here I'm going to select this here, select and copy and paste this here. And now we will ask it to go ahead and count. We'll ask it to go ahead and count. Count what? Count is a function, everyone. So you open the bracket here because count is a function. And inside this count here, if you will go ahead and type count country directly, you'll get the answer here as 122. Is 122 is correct answer? No. We know the correct answer is 27. So we have to go ahead and say that no, don't count country column entirely. You go ahead and first you get the distinct country there and then you count. So see, distinct is written in blue color, right? It is a keyword. It can also be used as a function, but count is a function. Also see that after count, immediately it is followed by the opening parenthesis. Now, once we execute this, we have count distinct country as 27 right here. So it can be written like this, or we can simply go ahead and write it like this also. So we will have count here, open bracket here, and close bracket right here. If we type it like this, then also we get 27 as the answer. However, is this column name looking good in the output? I will give you enough time. Answer me just one thing here. Is this column name looking good to you? No. So we need to rename this column, right? We need to rename this column name here. To rename this column name here in the output, we will go ahead and give it an alternate name and we call that name as alias, right? So alias is nothing but an alternate name we are giving to that particular column. How do we rename the column here? To rename the column here, so this is our select query, right? I will keep from in the next line. I will keep from in the next line here. And once we will write the entire function, after this here, we'll go ahead and type AS here. And within the double quotes currently I'm writing, what we have here? Total countries, right? Total number of countries here. So I'm writing here total number of countries. Right there. So if I go ahead and write like this, total number of countries within the single or double quotes here, and I execute it right here, it will rename it right there. This is called as alias. However, there are multiple ways to type the alias here, right? What is the other ways here? So let me copy and paste this here. Another way is that I will not go ahead and give the double quotes. I can directly go and type the name here. But if I go ahead and directly type the name here, I'm not allowed to give spaces anymore. I'm not allowed to start it with a number or something. So I have to go ahead and write total countries or total countries right here, or count of countries. So even if I will not give the double quotes here, I am good. I can give the name of the column here. It will be renamed, but we cannot give spaces anymore. If it is in double quotes, we can give spaces. We can type it started with number or anything else. Okay, it can be alphanumeric. What is the another way? Another way here is we are every time typing AS to define that we are giving an alias or alternate name. Even if I don't write it here, and I will directly write total countries as it is. And let me go ahead and change the name here so that you can see in the output. So if I go ahead and execute this, see, it is renamed again. So even if I don't type AS, SQL understands that we are renaming a column. So go ahead, count it, and rename your column in the output. That's alias. It is very basic. We always go ahead and name it. This is another way to type it. So even if you're not writing AS, whether you give the double quotes or not, okay, you will still get the output. Double quotes are given when we want to give spaces in the name. However, in the standard practice, we don't give spaces in the name, even if we are giving the double quotes. Okay, preferred way is this. Preferred way is this. There is a reason for that because as a beginner, okay, if you will see something written directly here, you might try to find this as a column name here. So to avoid the confusion, okay, we will always type AS and we will always give the double quotes like this. Makes it easier for us to recognize the names we are. I have a question for you, an exercise. For others, I'm waiting. This is just an exercise. Product line means product category. So product line is one column. So this here will remain similar, right? This part is going to remain similar here. So I'm going to copy paste. And now we have to work on the products table, everyone. So we will go to products table here. Inside this, we want to count the distinct product line. We double click on product line here. We will name this as, yes, we can write it in any case there, doesn't matter. And I'm writing this here as total product lines. From where? So from product table, from products here. And here we go. So currently we are using functions like count. Okay, you can use sum, average, standard deviation, and a lot more. Maximum, minimum, right? So we can go ahead and use these kind of functions in the similar manner. So we can use multiple functions like that, right? So not only functions, we can simply use mathematical operators too. We can not only use the logical or comparison operators and functions here, we can use mathematical operators too, or simple mathematical calculation. So with the help of these here, we can actually add the entire calculated column in front of the output. So let's take an example here. So we already have the product table with us, right? We know how to extract product ID name, and after buy price, we have one MSRP column also there. That is the standard pricing that we are selling it for. Correct. We can go ahead and get these three columns from there. However, now the company has decided that whatever is the standard price is there, we will increase the standard price by 10% of every product. They will increase the standard price by 10% for every product. So they want to go ahead and add here a new calculated column called as new MSRP in the output. And that new MSRP will be simply 10% more than the old MSRP here, right? So this MSRP now will become old MSRP. This MSRP will become old MSRP. So if we want to write the formula for new MSRP, okay, we can write it like this, that MSRP, old MSRP plus 10% of old MSRP. This MSRP formula, the column there. Can we write the equation like this? MSRP plus 10% of MSRP so that we get the increased price for new one. Can we reduce this? Since we know with the help of data type that we have seen at the start of the session today, that it doesn't recognize that percentage sign, right? So instead of typing the percentage sign and off here, can we reduce this to 0.1 and multiplication? We can do that here, right? Because we want the calculation to be done. So now this looks like that get the MSRP value from MSRP column in the individual row, multiply that with 0.1 and add it to the older MSRP. Very straightforward. But if we go ahead and reduce this here, we can get the common value out to reduce it to a smaller version. So once we get the MSRP out, we are multiplying it with 1 plus 0.1, meaning we can simply write the new MSRP like this. MSRP multiplied by 1.1. Correct? So we have this calculated column right there. So how do we write this calculated column here? So we go ahead and say select, right? From where are we selecting? I'm writing from first here. Okay. I'm getting this out first from the products table. Okay. I'm getting this out first. Then I'm typing select so that I don't forget which table we are working on. So in the select here, first we need product ID. So this is product code right there. And I'm going to rename this here as product ID. Easy, right? After that, what we are looking for, comma, we want product name also there. So this is name. Let's take this here as name only. Since it is product ID, it has to be the product name too. After product name, what we want, MSRP. So this is MSRP, but this is old MSRP. So let's name this here as old MSRP, comma. Now we need new MSRP, but that new MSRP is not a column that exists. It's a calculation. So we write the calculation here. How do we write the calculation? We get the MSRP here and we ask it to multiply it with 1.1. That's what we have seen there. Now this entire calculation, we encompass it inside the parentheses here and we call it that name as new MSRP, name as new MSRP, right? I will go ahead and beautify this. I will go ahead and execute this first. See here, we have got product ID, name, old and new, right? I will also go ahead and beautify this here. I'll go ahead and beautify this, right? This looks much better, right? To read. Go ahead and get this, please. Of course, you can choose any name that you want. You don't have to stick to these names only. You can give any alternate name that you want. Also observe, I am not using double quotes. I am writing single quotes here. Okay. Remember that whenever, see, how many rows are we getting in the output, everyone? Observe the rows you're getting, 110 rows, right? So we are extracting each and every number here, each and every row here. And this is a row-wise calculation. We are calculating it for each and every value in each and every row. That's why it is a calculated column. And do you see any difference between the difference in the format of old and new MSRP? Yes. We want two decimal here also. How do we get only two decimals here? We truncate the other decimal points here. Correct, we round it off. So the function here is round. Function here is round. And we will say, and then we go ahead, we type a comma there and type 2. Now, once we execute this one here, we get two decimal points. Right? Yes. Our functions are exactly similar to Excel. You'll not find it is very far from there. You need to get the average price for vintage cars only. Where you will find the vintage cars, you'll find the vintage cars in the product line column of product table. Product line column of products table. The formula is ABG, simple. And price means average MSRP. Get the average MSRP, okay? But only for the vintage cars. Vintage cars is the name of a product which is present under the product line column. So if I show you the product table here, see, under the product line, you will find vintage cars, see. Okay. And it is not case sensitive. You can write it anyways. Just the spelling should be similar. Now, how do you go ahead and solve it? That's the question, everyone, right? So first thing you always figure out from. First thing that we always figure out is from, right? So what we should type in front of from here? Product. We're aware about that. After from here, what is the second thing you will look for? What do we want in the output? What do we want in the output? We want average. Average of what? Average of MSRP. That is also fine. Other than that, do we have any other requirement? We have average MSRP from the products table. What is the third requirement here? Do we have any other requirement? Right. We want to filter only for vintage cars. How do we give the filter? Where clause. But on which, now where clause here, on which column we want to put the filter? What is the name of the column where we want to put the filter? We have to give the column name, right? So the column name is product line. Why? Because product line is the one that holds vintage cars. This is how you, when you will break it down, it will be easier for you to write. So here, if we go ahead and type select now, so here we move here, select, right? In select here, we want to calculate the average. So let's calculate the average. Average of what? MSRP, right? From where? From the products table right here. This products table. We want to apply the filter. We will apply where? There on the product line. Product line is equals to what? Vintage cars. So we can go ahead and simply type vintage cars here. First, check the spelling in real time and then type the vintage cars here. Yes, that's it. However, this is just average MSRP. This is just average MSRP written here. We can type it properly, the name there. And see, there are too many decimal points. So let's round it off. So we will round it off the average. Let's round it off to 2 decimal points there and give a proper name here. So this is average MSRP. This is average MSRP. So we have given the proper name also here and we have rounded off. Once we round it off, give a proper name. See how does it look like better. But this output doesn't tell us it is for vintage cars. So what we can do here is we can type a comma here and we can ask it to get the name of the product line too. And when we execute this here, we can see one single name is written because filter is there. Yes, because we need only one single output here. It is a one single number output. We have just one single number here. While typing round to clean the data, I had overwritten the average function. Yes, that happens. Okay, because if you are selecting it from the drop down, all right, then you will get you will replace the upcoming or already written values there. So what you're doing is you're all rounding off MSRP, right? So you're going to have error and very different output. You'll have multiple vintage cars and each and every row will be out. Because right now we are asking you to calculate an average. What is an average? Average is an aggregate calculation there. So if the average will not be there, it will simply go ahead and extract each and every row. Now it is not aggregating anymore. Observe that in all the three conditions and every condition that we have seen yesterday, we are only going ahead and filtering it by one condition. We are only going ahead and filtering it by one condition. What if this is the orders table, right? In the orders table here, if I ask you to go ahead and only get the orders, okay, which are on hold, what you will do then? So we are now going to have two conditions. We are saying that I want the orders which have been placed after 1st month 2005 year, and they should have, and the status should be shipped. Let's get the shipped status here. And the status should be shipped. So now what we have here, we have got two conditions here. So how do we ask SQL to go ahead and give us two conditions? Filter the data by two conditions. This is where logical operators comes in. That is and, or, and between. This is where the logical operators will come in. That is and, or, and between. What and will do here? These will help us to look for two or more conditions. And have we heard about and, or, and between? I'm sure we have heard about it. And, or, and between. Not in SQL, but somewhere else. If you are from engineering or just you have learned Excel anytime, we have heard about these conditions and, or, in between. And in general cases also, we do use that in general life. I want apple and mangoes from the market. Get apple or mango from the market. There is a difference, right? So in general also we use that. Logical gates and Excel. And at many places in general life also we use it. And here first. So what will and do? And means I need both the things here. I need apples also, I need mangoes also. So in one single row here, it has to check that in this per one single data row, the end all the conditions should be matching, meaning the order date should be less than 2005 and this status should be shipped to. Both the conditions should be matching in each and every row. So let's go ahead and see how we are going to type it here. So we will get the same thing here, which orders have been placed. Let's get it right here. Which orders have been placed after 1st March. and the status is shipped. How do we write it? So we know that this is select, and let's figure out from first. So from we have orders, right? What we need here in the orders table. So let's get the order number, comma, we have order date, that's what we're looking for. And the status is shipped. So here we are. Till here it is fine. Now we go ahead and we type where. Now inside where, first condition is that our order date should be after 1st March 2005. Now we know how to type this. This needs no explanation. There is one more option now. One more here. And. So we'll type and here and we ask it that now your status should be equals to shipped. This shipped that we are typing is purely not case sensitive. You can type it as you want it. The spelling should be correct. Now if I go ahead and execute it right now, see here, we get both the conditions are matching. Both the conditions are matching. Yes. Okay. So this is and. What and is doing here, and is helping us to go ahead and check two conditions in one single order. So if I go ahead and beautify this, this is how it looks. You are getting me the orders which are placed after 1st March and the status is shipped. But now I want the orders that has been placed after 1st March and check for whether status should be equals to shipped and resolved. So whether the status should be shipped and resolved. So there, if you will see here, there are status like resolved here. Okay. See, there is a status like resolved. So we want both the type of rows here is shipped and resolved both. How do we get that? Why are we using or? Let's understand. Reason is in one single row, it cannot be both. So we have to go ahead and write or here so that it goes to every row and check either it is shipped or resolved. So I will copy and paste exactly this thing here. And what we type up, we type or. So here, status equals to result. This you can write it by yourself. Is this order date greater than 1st March 2005? Is it holding on with the status shipped or resolved? Are all the order dates after 1st March 2005? Are we having all the order dates after 1st March 2005, everyone? Yes or no? Does this look like 2005 to you? 2003 is in the first row. You don't have anything after 2005. March 2005 specifically. You have January 2005, November 2004, October 2003. This order date is not holding up anymore. Yes. So when we are writing the or condition here, right, the and condition here, this order date is getting thrown out of the window. Why? Because it is right now with the and or what is happening, or is getting the privilege. So first it is resolving the or and then it is resolving the and. Since and cannot be resolved anymore, it is not holding on to this filter anymore. Because what we are writing here is everything is in succession. We are saying check for order date and shipped. After that, check for or. So what it has done here is it has taken all these two as here, and then it is checking or status equals to result. So this is a problem. So what we need is that order date should be, doesn't matter if it is shipped or resolved, right? It has to be after March 2005. So we have to simply go ahead and encompass this inside the parenthesis. Once we do that, now it understands that, oh, okay, you want this to be held true always. And I have to check whether this or this. So this is what we need. This is how we write. So once you keep it inside the parenthesis here, it will go ahead and check between these two. It will apply the OR only between these two. It is not going to apply the OR with the order date. So when you want something to be held true, keep it separate. When you want something to be held true separately, just keep it inside the parenthesis. Now two conditions are matching perfect. Okay, just simply go ahead and give the parenthesis around it, and it will be resolved. This is the question for you. Now I'm writing here is please look on the screen here. Okay, find the product whose MSRP is greater than 100 but less than 180. How many conditions are here? Two conditions. So if I have, and both the conditions should match, it has to be greater than also and below 180 also. Both the conditions should match here. So we can use and here. So first let's figure out from here. So from the product. So this is the from products. And we are looking now in the product here. I don't need all the columns. So we get few select columns here. Let's get the product name, product code, and here's the MSRP, right? This is what we are looking for. Now we go ahead and type where. In the where, this is MSRP right here. MSRP is greater than 100. So we can go ahead and type greater than 100. And again MSRP, because there are two conditions. So MSRP less than 180, less than 180. This is going to give us, see here, the MSRP between 100 and 180. So what we are looking for, a numerical range. So whenever we have a numerical range, we can easily apply between. We can apply between here. Instead of and here, we can have written between. How do we type between? So this much will remain similar. This much will remain similar. After MSRP, we'll simply type here between and we'll say MSRP should be between 100 and 180. So between cannot be used without and. So type 100 and 180. Yes. Now in both the cases here, the answer is going to be similar. Now answer me here. Are we including 100 and 180 when we are filtering with the AND function here? Are we including 100 and 180 when we are typing AND here right now? We are not including upper and lower limit here. If I want to do that, we can go ahead and write equals to here. If I want to include it, I have to type equals to here. Then I'm including upper and lower limit. Meaning I have the choice. Meaning I have the choice here. It works as Excel, not as programming language as you have seen before. It works as Excel. It has to go to each column every time to filter something out. So we have to type MSRP equals to MSRP equals to. When we talk with between everyone, in between, upper and lower limit are automatically included. Upper and lower limit in the range are included automatically. So when you're using between and here, it will include upper and lower limit both. So this is your between and. It will be included automatically. We don't have exact 100 or 180 here, so we cannot see the difference. But yes, it works like that. So this is and between here. This is the difference between and between. Solve this. Verify the spellings first. So you can click here and look at the spellings here first. See the spelling. The logic is absolutely correct. So let's see list of customers living in USA, customer of France. So we now know we are talking about from customers here, right? So of course we don't want to select everything from customers, but we are looking forward from customers right here. What we want to select from customers, let's select few columns here. So customers, this is customer name here, and let's get the country. That's what we are looking for. And from customers. So we are good with that. But we don't want all the countries, of course. We don't want all the countries. We want select few. So we'll go ahead and use OR function here because in every row, we'll check for individual country, not all. So now here we have to go ahead and say that where country is equals to, let's say USA here, or country equals to again. We have to go ahead and type it again. Why? Because this SQL here will treat this country as three separate columns. It is not going to treat this as one single column with multiple filters. So every time it will go ahead and check it as it going ahead and checking for another column right there. So when you're typing this here, it is not case sensitive, but you have to make sure that the spelling is absolutely correct. So we have to go ahead and type or, and or. Of course, you get the correct answer here, and that is going to be, see, USA, France, and Australia, right? That is 53 rows. Okay, that is 53 rows here. So if your spelling is correct, you'll get 53 as the answer. Most of the time, you'll be making mistake at the spelling of Australia. But just imagine, what if you have 10 conditions to check for? What if you had 10 conditions to check for? That too in one single column. Then it is going to be too hard to type, and we will make mistakes in typing the spellings right there, because you have to check and write and copy and paste. So here, in this time here, we go ahead and we choose in operator here, and we go ahead and choose an operator here. What is in operator here? In operator will help us to give the entire list at one place. So in operator acts like or, right? So if I go ahead and type in operator here, inside this, we can go ahead and write the entire list. And what it does is it goes to the country column and it will check from the list if any one of that is present. So it automatically works as or, but it is convenient to write. How do we type in operator here? So we will first go ahead and get the column here. In front of column, we type in, and inside in here, we will go ahead and type here value 1, comma, value 2, and value 3. So if it is text, we will type inside the quotes. If it is not a text, we will simply leave it as it is. So this is how in operator works. An operator helps us help us to type the filter here properly. So this will remain exactly similar here. And after country, we'll simply type in. And inside the in here, we can give the entire list. So this is our USA. I'm going to copy and paste here, comma. This is France here. And now here Australia. So we don't have to type or again, we don't have to type country equals to again. We'll type that only once. And we don't have to type or anymore. In automatically takes part of that. And we still have the 53 rows right here. So this in is actually working as multiple or, like an operator, we also have any operator or operator, any, all, and exist. We do have that too. For now, we'll focus on N. So let's look at the employees table right here. In the employees table, what we have got employee number, email, office code, and the job title. In the job title column here, do we have managers? Only typing manager will not work. Why? Because there is nothing that is exactly equals to manager here. So we are currently not trying to find out the exact phrase inside a data point. Correct. What we are trying to find out is a part of the string. We are trying to filter out the rows from the part of the string. So we want wherever manager is written in the entire phrase, in this entire string, wherever manager is written, based on that, you filter out that row. Correct. So in this case here, no equals to comparison operators will work. This is where the comparison of, this is where the wildcard comes in. This is where we have wildcards. Wildcards. What are wildcards here? Wildcards are activated with like operator. So whenever we want to use the wildcards here and we want to get this small part of the string out, we first activate the like operator. So in the like operator here, there are two things we can work with. One is the percentage sign. One is the percentage sign and another is the underscore sign. What is the percentage sign here? Is for variable here. That you will have variable, what do you should say here? You should have variable letters and symbols, right? And this underscore here simply means fixed number of spaces, fixed number of letters or blocks. What does that even mean? Let's understand it. So if I go ahead and I will type here percentage, after percentage, for example, I will go ahead and type manager. What does that mean? It means here that if I'm typing percentage before manager. So we are communicating to SQL that see, the phrase should, the entire phrase or entire string should end by manager, and before manager, any number of variable can come there. Any number of variable can be written there. So it can be a letter, a symbol, or a space, anything can be here. But it should be before manager. If we go ahead and type that, okay, this is manager, and if I type percentage afterwards, so we are communicating to SQL that this particular data point should start with MMJR and end with anything. There can be spaces and any number of variables, anything will be there. If we go ahead and type percentage first and then manager and then percentage again, we are simply saying that in the middle somewhere, in the middle of the entire phrase, this particular words should be there. It doesn't matter what it starts with, what it ends with. Okay, this is percentage. This is percentage. So if you want to go ahead and extract manager from here, what we should be using then? Should we be writing percentage and manager? Or we should write manager and percentage? Or should we write percentage, manager, percentage? We are 2 to 1 right now. This is the correct answer. Why is this the correct answer? Look at this. Manager is somewhere in the middle. At the end also we have some variables. Yes, Samrita, Vinay. So this is our while operator. Let's go ahead and get the employees table right here. Now, in the select everything here from the employees table, let's go ahead and get employee number and their job title here from employees. And now we want to go ahead and give a filter here. So inside the web, we'll say that, see, I want to put a filter on job title. Job title should be like similar to percentage manager percentage. The spelling of manager should match there. Manager percentage. It should be encompassed inside the single quotes. Once it is like that, we got our managers right here. I would like to remind you, you are not supposed to type these things here. Like you're not supposed to type the keywords or the name of the columns or name of the tables here. I would like to remind you, you simply need to double click. Okay, please double click. Do not make spelling mistakes. Double click, please. Yes, Samrita, absolutely correct. 3 rows. There are 3 records. I would like to see now which employee is sales manager. What will I do if I'm only seeing these 3 here? I want to know who are these people. That's why. Otherwise, how does it make sense just to see 3 titles here? I need these people detail. I want all the managers. Maybe I want all the managers to invite them in a meeting. That this meeting is only for the managers. We should be actually getting first name and last name also, and their email ID also, because I need to share this list with someone, right? They will call these people and tell them to report to somewhere. Okay, this is what the percentage will do. Percentage, wherever percentage is written, it will look for multiple characters. What it will look for? It will look for multiple characters or variable characters. Any number of characters should be there. So percentage manager, meaning in front, there can be any number of characters. If we go ahead and type manager percentage, meaning it should start at MMGR and end with any number of characters. We don't care. And when we are writing percentage first and then percentage here, meaning start and end, we can have any number of multiple variable characters. That's what percentage is. Now, next here is underscore sign, everyone. Next here is the underscore sign right there. It is fixed number of letters, or you can say fixed number of characters. What is meant by fixed number of characters here? It means that if I will go ahead and type underscore once, if I go ahead and type underscore once here, so basically we're asking it to get to the 1 letter. So if I go ahead and write that there should be 2 letters at the, then there should be a letter O, then there should be 1 more letter here. So we are looking for a letter, maybe it is from. So it can have only 1 character. So this is the underscore, this is the underscore, 1 letter here. This O is something that a pattern should, we are looking for a pattern. So in the entire column, all the data points following this pattern here with having third character as O will be extracted out or filtered out. So this is what underscore means. It means one character, one means one character, one means one character, like that. Yes, you can use combination also, right? But most of the time, this is something that we use. This is something that we use, right? So let's see an example here. Let's see an example here. For some reason, let's say, we want to go ahead and find a customer whose first name starts with letter M, and should have exactly three characters, So we want a customer whose first name starts with letter M, and not only starts with letter M, it should have exactly three characters. So how we will go ahead and write this here? To write this here, we have to go ahead and write that start with M. And it should have exactly three characters here. So I'll go ahead and type two underscore signs here. I will go ahead and type two underscore signs here, one after the another. How is it going to look like when you type it? It looks like a single line, but there are two underscore signs right here. So this is M, and exactly have three characters in total. So let's see if we have any names like this. So here I'm select. This is our from customers. Let's select customer first name right here. Okay. And let's go ahead and see if there are any names like this there. Again, contact first name is like M and two underscore signs here. We have just one person. If I go ahead, I put one more underscore sign here, it will be total 4 characters. You will have 4 people. So if you're working for 4 characters, you will see more answers here. So this is how it works. In general, you will not find many use cases other than pattern recognition. If you're looking for a strict pattern recognition, then it will be useful. Otherwise, most of the time, manager will be that percentage thing will be handled. Why? Because if we simply want the first letter start with M, we could have written it like M and percentage, and that would suffice. So after M, any number of words can be there. Any number of characters can be there. So if I go ahead and write here, M with percentage here. Now the letters afterwards doesn't matter. See? So that's the difference between putting the underscore signs and the percentage. Now go ahead and get it. This is another way to put the filter in wildcards everyone. We already done this once here. We wanted from the orders table. We started with that. So we wanted to get order number, order date, and a status where order date is 2004. And then we are getting AND function here. So here, right now, we want order date from January 2004. So I'm changing this to January 2004. Till here, it's fine. But afterwards here, it is asking that the R. So we will type AND here, but after N, they are either shipped, in process, or on hold. So now here we go ahead and we use in operator because we have to use or here. Instead of writing or multiple times here, after and we will say that go and check the status. And in here we go ahead and we type M, shipped, in process, or hold. And we type this here, make sure we are in the single quotes right here. Now we don't need to type or anymore. We can simply type entire list. Remember that there are no extra spaces. Yes, we can write like that too, Michelle. So let's check. Do we have any answers here? Oh, yes, we do. We have got shipped here. In process or in process and not hold. Everything is getting checked out. So this is the one. This is the first answer then. Now let's look for the second one. Second is retrieve customers whose name start with A or B and they are from Germany. Do we have any people like that? Go and check it out. I have no idea whether we have any rules like this or not. We have 2 people like that. Wonderful. Here is the question. Okay, retrieve the customers whose names start with A or B, and they're from Germany. So what, see, you all are applying the filter on different columns, right? Someone is, few of you are applying this particular filter on customer name. Few of you have chosen customer contact first name. In both the cases, you'll get the answers. You might get one row or the two rows. So for example, if I take this here, the first one that I've got, if I take this solution right here, so this is customer name and country from the customers. After country and Germany, we are typing and. Now we have to encompass it inside one another, like A starting from A or starting with B. So right now we are using customer name here, a direct customer name, the first one. And see, now we have two people here. If instead of customer name, I will go ahead and use customer first name, that is contact first name, then the answer will differ. So for this, I will take the second solution I have got. And see here, we have contact first name has been taken here. See, so the logic is same. So both the answers are correct. Okay, let's go ahead and look into multiple different types of functions here. Basic type of functions that we have here is text function, date functions, conditional statements like if else and the case and when. And here we will also look for the null values. First thing that we are going to learn about is string functions. They are also called as text functions or simple characters, right? What types of string functions that we've seen so far? If you know Excel, you have seen string functions. If you have known Tableau or some similar languages out there, you have seen text functions there. For example, there is a text function called as upper. What does it do? It goes ahead and converts a smaller case letter into a uppercase letter. Similarly, we have called as lower. What does it do? It gets the uppercase letter, converts this into a lowercase letter. That's upper and lower. Another here, an example here is length function. What does length will do? Length will simply go ahead and give the length of the string. Whatever is written inside it will give us length of the string. We have another function called as trim. What trim will do? Trim will get rid of extra spaces. It will leave one space. It will get rid of any extra spaces if they are written before or after the string or the characters. So if I have an address written somewhere and if someone has given too many spaces between the addresses, line 1 and line 2, then it will get rid of that. So on the similar basis, we have another options like substring. We have got reverse. Reverse will reverse the data point. Substring will simply get a few words out of the entire string. That is substring there. Okay. These are few very common text functions right there. Now, can you think of any other function which is very common in text functions? We do have left and right function. Left will go ahead and get a few characters from left. Right will go ahead and get few characters from right. Varchar is the data type manager. Yes, we do have proper in Excel. The most common one that you will ever see is concatenate or concat. Most common that you will see there. What concat does? Concat will go ahead and it will join. Yes, it joins the strings. Very good. It can join two or more strings together. It combines them. So let's see an example. For example, we will go to the customers table again. So I'm getting from customers again. So this is here from customers. Right again. Now in the customers here, see we have contact first name and last name. We want to write it together. So here I will go ahead with select again. In select, what we want to do, first I will get the customer number, of course, comma, get customer name, that is the name of the vendor, the company. And inside that company, this is our SPOC name here. So now we go ahead and we type concat. So here is concat, everyone. You can see the function right there. This is concat function. Inside this concat function, I will simply ask it that now you concat first name, comma, last name. I'm going to name this here as full name. So we are applying the concat right here. When I'm applying the concat function here, look at the column full name and tell me, is this output correct? Can you simply go ahead and give this, share this output outside? Is this possible? There is a space. See here, Karine has the space. Janine here, this has the space. Diego has the space. Jonas here has the space. Not in all. Why is it like that? Why do some names have a space, some name doesn't? Because if I add the space now somehow, they are going to have extra spaces. Correct. So if I add the space now, few will have extra spaces. So tell me, why do we have extra spaces here? First, figure out why. Why does this appears like this? Why is it happening? Because when someone was updating the data, right, they have written the first name or the last name, and by mistake, they have added the extra spaces either before that or after that. So either first name or last name, these have extra spaces before or after them. Because of that, here we are having extra spaces. So we need to go ahead and trim the extra spaces first and then add the required space. So first thing we do is we use trim function here. Absolutely correct. So I'm going to go ahead and type trim. Now, what is the problem with trim function here in SQL? We have to go ahead and apply trim function to individual column name here. We cannot simply go ahead and encompass trim for the entire concat. We have to go ahead and trim the individual names here. So once I trim it here, you will find that now see, we do not have any spaces. See here, I have applied trim function here and you can see there are no spaces. Now we can go ahead and add a space. After this comma here, I will type one more comma. Now we are having one space, character space in between. So here we go, single quotes, space, single quotes right here. Single quotes, type the space bar, click on the space bar and single quotes again and press Control Enter and see we have got full name right here with proper one space in between. So we already have this, right? So just copy and paste this here and also get the full address column here because we have address here. We have got address line 1, 2, 3, 4 till country, right? So we want to get all of this at one single place. So let's move forward. What we wanted to get here, we wanted to go ahead and get the full address. So when we go ahead and try to get the full address here, I'm sure you all have written that there, right? So let's go ahead and type it out for others too. So after concat and getting the full name here, now we type concat again, but in this concat here, we want to get the address here. This is address line 1. This is address line 2, comma, city, comma, state, comma, postal code, and then we have country. Now this here is address. So I'm going to go ahead and write this as address 1 for now. And let's look at the output, okay? When you look at the output here, what does it show us here? That these are null values, meaning these we don't have address for these customers. That's what it tells us here, right? So let's check it out. Don't we have the address for Karine and Jane here? Let's figure it out. So if I go to customers right now, everyone, and I look at these people here, okay, do we not have the address for them here? Do we have the address or not? We have the address, correct? However, when we are trying to concat it here, are we getting the address? No, we are getting null values there. Why not? Yes, Amrita, absolutely right. Why is it happening like that? Because what is happening with concat here is, it is reading it here. It is reading it here. However, as soon as it reaches the null value in the second column, it stops right here and give us the null as the answer. So whenever everything is present, whenever in every column there is a text present, it is giving us the answer. But as soon as it reaches or looks at any null value, it will not move forward anymore. It stops here and give us null as the answer. It means that concat cannot deal with null values. Concat fails to deal with the null values. So this concat will not be able to work at all for our, because it should simply ignore the null value and move on, right? It is not able to do that. It fails at that point. So what we will do here now, we'll go ahead here. And first thing that we should know is how to find null values. How to find null values. To find null values here, we are going to use very simple thing here. will ask SQL, is there any null values? We can simply ask. So we can go ahead and ask it that go ahead and select and count. What to count here? Count every column. Count every column. Whatever we list here from the customers table. From the customers table. Where you have to count wherever address line 1 is null or address line 2 is null or address city is null, and likewise. So you'll go ahead and ask it to go and check if these columns are null. So when we ask it to do that, it will tell us that yes, there are 113 null values out there. And it'll simply tell us that yes, there are 113 values out there which are null. So go ahead and see this here. Now we have to go ahead and find out that how do we deal with null values here. So we have null values, fine, I know we have null values. So how do we deal with it? So there is a very famous function called as queries. Queries is a function that is used a lot to deal with the null values. Why? Because it can successfully ignore the null value. It can also replace the null value if required with any text, number, or symbol. So queries can be used as a nested function with another function very easily. So go ahead and first get the concat properly and see how to go ahead and count the null values, and then come back here. You'll go move forward with queries right there. Okay. First, check this out. So we are using the function queries now. So how does the queries looks like? The syntax is like this. So queries can be applied here to any column name or a string, right? And afterwards here, we can go ahead and ask it to either replace it with blank or replace it with any text, number, or symbol. So queries, whenever it will find the null value, it will simply go ahead. What queries will do? Queries will go ahead and check for non-null value. If the value is not null, it will give that as the output. If value is null, then it will give you whatever you ask it to give as the replacement. So if you wanted blank, it will give you blank. 2 single quotes without any space, that is blank. Okay. So let's go ahead and find it out. How does that work? So I'm going to copy and paste it right here. I'm going to copy and paste it right here. And comma, enter. What we want here is we want to go ahead and work with concat, but concat cannot deal with null values. So we will ask here, we will ask queries here to go ahead and check, is address line 1 is a non-null value? If it is a non-null value, we will type a comma here and we'll say, if you find a null value, go ahead and leave it blank. If there's a null value, leave that blank. Now we type comma again, and here we will go ahead and type queries again for address line 2. For address line 2. In address line 2, if this is blank here, go ahead and type NA. I'm going to type a bigger NA here so that I can show you that it replaces the value. Okay. I'll type comma again. Now we go ahead and check for the non-null value again. That under queries, if city is null, go ahead and give this as the replacement. Okay. I'm not typing anything else right now because I want to show you how queries works. And I'm going to type this as address 2. Let us see how does it work. Let's see here. Observe everyone. Observe everyone. Here, do you see NA is here? Meaning, what is empty? What is null? Address line 2. So wherever you see NA here, address line 2 is null. If I go here, say here, everywhere NA is at address line 1. We have the city name everywhere. We do not have any null city name till now. Okay. So this is how queries works. So within queries here, right now it is showing NA, right? Right now it is showing NA everywhere. If I ask it here, let's simply go ahead and type a comma. Simply go ahead and type a comma with some spaces before and after. Then see how easy it looks. See here, how clean the output looks. Yes. So this is how queries works. And yes, it is a lot more work to type concat with queries. It does take some time. So go ahead and type concat with queries, everyone. And I will reformat this to show you. It actually looks very good after reformatting, and it is easy to follow also. So if I reformat this here, I will go ahead and reformat it with this here. Look at this, how easy it looks to follow now. Now here, when we have seen everyone that we can write concat and queries, but it is not looking that good also because we have to go ahead and trim also. So when we are writing here concat and queries here, we have to go ahead and trim them individually too. If we are not trimming them up, the problem is same. See, we have too many extra spaces everywhere. So we have to go ahead and apply trim here too. So yes, it does get tedious to type. Okay, it does get tedious to type. So what is the another way? So now what is the another way here, which can help us to reduce the effort right down here? So another way here is to use another function called as concat ws. Concat ws. Ws means concat with separator. Concat with separator. Now, why is it called as concat with separator? So let's see something here. This is here is city name, right? And this part here is the address line 1. So somewhere we have address line 1, 2, and city name 2. So now what is happening here is we are not giving any separator here. If we want, we can. So after every comma here, we have the choice to give any separator that we want. We have a choice here. We can go ahead and give any separator that we want. So if I go ahead and type separators after address line 1 and after address line 2 right here, this see separator can appear like this here. Okay. So these are the separators that are appearing here. Meaning, if we are using concat and queries together, we have the option to give as many separators we want, and we can choose different types of separator here. However, when we use concat ws is going to give us exact similar output. It is going to ignore the null values. It is going to concat whatever we ask it to do. However, it will only give us option to write one separator and no more. So concat with queries can replace null with a message or blank, right? With multiple type of symbols and delimiters. However, concat ws is going to be just opposite of that, and it will ignore null, but it will give us only one type of separator, and it will not give us an option to replace null value with any values or message. So we cannot replace null with concat ws. So these are few differences here. The best part here is our work does get easier. Okay, how it will get easier here. So this is how concat ws works. So this is concat ws here. Okay, in concat ws, first here we give separator, any separator that we can define. Separator defining here means we can go ahead and type a comma, maybe a semicolon here, or maybe just a forward. Okay, whatever we want, or just the hyphens like this here. If I go ahead and type a comma now you go ahead and you maybe want to type trim, you get column number 1 here, then you comma again, then you type trim here, column number 2 here, and so on. But the separator that we give here, it is going to be only one. Separator can be any delimit, any kind of symbol right there. Okay. So let's go ahead and see how we are going to write it there. So here we go. I'm going to copy paste it here. I'm going to copy paste the same thing here. And we add one more column, everyone. We add one more column right here. Now in this column here, after address 2, comma, enter. And now here we are getting concat. This is concat with separator. So inside concat with separator, first you have to define the separator. So let's give a separator with 2 forward slashes so that I can show you where separator is coming up. And after this here, we simply need our address line 1, 2, and 3. So we are looking for address line 1, comma, address line 2, comma, we have got city, state, postal code, and country. If you want to type trim, you can. Currently, I'm not going to do that. So here we have got address 3 right here. It looks easy to type, and let's look at the output then. Let's look at the output, everyone. See here. This is address 2 and this is address 3. It was easy. We are able to get the proper output. And if I want to change the separator here, I will go ahead and type a simple comma right now, and it looks much better. See, easy. But in real time, what happens here is, in real time, everyone, we use concat and coalesce together, but because it gives us flexibility to type whatever we want, wherever we want. That flexibility we get in coalesce. Because every time we are not looking for one single separator, neither we are, and sometimes we want to actually replace the null values with something, some message out there. Or maybe we want to give a default value if something is not available. In these type of real-time cases, we will use concat and coalesce more as compared to concat-ws. And coalesce can be used with any other function whenever you want to deal with the null value. Yes, it is much easier to type concat-ws. Absolutely correct. I will also show you the reformat version, because reformat version is easy to follow. Do you see this minus sign here? This minus sign is you can actually go ahead and collapse them. You can simply go ahead and collapse them. So you will be only focusing on what you want to work with. It is still there, but they're collapsed. So you can expand it, collapse it. So that's the reformat everything. Why not we reformat it from here? This brush, remember? So when you will reformat it, observe that this is how the reformatted query looks like, right? Select customer number, concat, concat, concat here. All the 4 formulas are here, right? So do you see this minus sign here? Do you see this minus sign here? This is collapse. So see here, we can collapse the lines right there. Saving on the screen part. So we can simply collapse it if you want to focus on one single formula. All right. Yes, it is easier to follow, but not easy to write. See here, I am writing concat here, and it is ending up with the name. I'm typing concat only once. It is ending up with the name. In your case, it is not like that. I don't know what you're typing and from where. Can you copy paste from code share and compare first? So copy paste from the code share and compare what you are typing and what is written here. You will be able to understand what's going wrong. Okay. So here, next function here is substring function. What is substring function here? This is how the substring syntax looks like. As the name suggests, what does it do? It will go ahead and create a subset from the existing string. It creates a subset from the existing string. Meaning, see here, we will pass the column to it. We'll ask it the starting position. And from the start position, how many letters we want out, or how many characters we want out. Yes, part of the string is retrieved. So if I simplify it, we simply extract a few letters or characters out of the entire string. Okay. So for example, I'm going to type just like this first, and then I will show you the example. So for example here, if I am writing here, product, right? So what is meant by start position? Start position means this P here is 1. This R here is 2. This is 3. This is 4, 5, 6, 7. Okay. So if in the substring here, if I'll go ahead and I will ask it to go ahead and read the letter product, read the word product. Start position is 3. And the length here is 4. So what it is going to type? What is the start position here? 3. And what is the length we need here? 4. 1, 2, 3, 4. So it will simply extract that position from that position till whatever length is there. 1, 2, 3, 4. So that's how substring works. So let's go ahead and see a simple example right now. So we will work on the products table. We have got product code everyone here. So let's work with that. So here is our product table right here. So I'm typing from first from the products. And here we have select right now. In the select here, I'm simply taking the product code for now. And after product code here, let's type here substring, everyone. This is str substring, everything is same. They work exactly same, absolutely no difference. In this substring here, I will ask you to read the product code and let me show you how the product code looks like, okay? This is how the product code looks like, everyone. This is how the product code looks like, okay? So this has here is 10, 1678, 1949, 2016, and all. Done. So what we are saying to the is here is that go and read the product code and start with the first position and get me the 4 characters out of that. Start with the first position and get the 4 characters out of that. And see, it is including the first position, including that it is getting 1, 2, 3, 4. It's a simple substring here. And whenever you are learning any new function, everyone, you can always ask for help. So you can go ahead and ask here, help. Help with what? Help with substring. When you ask for help here, okay, it is actually going to give you the entire description right here with the example. Okay. And it will tell you that substr is the synonym for substring. Go ahead and get this, please. Simple substring. We will see an application of that. We'll see the application of that. Yes, it is like many of Excel. In Excel also you'll find substring. There is substring like formula in Excel too. Let's look at the comprehensive example now. So let's go ahead and generate a custom product, everyone. Okay. Now to generate a custom product code here, we want to combine few things together. First, we'll go ahead and get the first 3 letters of the product line. So this is the products table, everyone. So let's look at the products table right there. In this product table here, first we want to go ahead and get the first 3 letters of the product line. That we will combine with, that we are going to combine with a formatted by price with 0 decimal. A formatted by price with 0 decimal. So we do have a by price at the end, right? We want to go ahead and format it by that. Formatted by price without the decimal part. We will want 0 decimal values there. Then we will combine it with a reverse product code. Then we combine it with the unique reverse product code. So this product code that we have it, we will reverse it. Absolutely reverse the entire string. And we only want to view first 5 rows. We just want to sample the 5 rows. We don't want to get the entire 110 rows. Okay. So let's go ahead and break it down one by one. So first, let me write here, select everything from customers. So from customers is fine. From product is fine here. Now in select here, we want custom product code. So let's begin here with product name because we are creating the code for these product names right there. Now we want to combine them together. If we are about to combine them together, we have to go ahead and type concat, everyone. Okay. Now after concat here, what is the first thing we are looking for? First 3 letters of product line. First 3 letters of product line. To extract the first 3 letters of the product line here, what will be the function? Left. So we will apply the left function here. We apply the left function here and we ask it to read the product line and get 3 words from there. Get 3 words from there. And see here, we are getting the 3 words out once we apply left. That is first part done. Now let's go ahead and get the second part. We need now a formatted by price without decimal number. So if we ask for the buy price directly here, if we ask for the buy price directly here, it is going to look like this. We don't want decimal point. So what we will do here, we will format this. To format this buy price here, the function is also format. Function is also format. This format is equivalent to the text function in Excel. It is equivalent to the format function in Power BI. Meaning this format function will convert any column or any parsed field inside it and format that into whatever we want. And most of the time, whatever the answer is, right, that answer will be converted into a text. So this format function, you can pass it any number, and after comma, you can go ahead and type whatever text, whatever format you want. It will convert it into that, but the data type will be also converted as a text. That is format function right there. And see, now we do not have any decimals. We can also go ahead and give a separator right here. You can also go ahead, give a separator right here. So now we will see it like this. So this is let function. This is format function right here. Now afterwards here, I will type comma and we go for the third option here. What is the third thing? That here is we want to go ahead and reverse it. We want to go ahead and reverse it. So we will simply go ahead and say that yes, go ahead and use reverse function right there. Inside reverse here, we want to reverse the product code entirely. And remember to give the separator here. So we are giving the separator, we are reversing the product code right there. And see, we have reversed it. Absolute reversing. Okay. Once you have reversed it here, what is the next we are looking for? So this becomes our custom ID. This becomes our custom ID. So I'm writing this as custom code. Okay. This is our custom code right there. This is the customized code. But do we want to see here it like this? Everything should be in caps, right? It's a code. So let's go ahead and convert this into caps. So numbers we don't need in caps. S in here is already in caps. So we'll go ahead and simply the let function that we have written there, we can encompass it within the upper here. We can encompass the entire into the brackets or the parentheses here. Now this looks like a code right here. That's the custom code. But remember that after all this here, we don't want to see all the rows. We only want to see 5 rows. So we will go ahead and use here the last keyword that we have seen, that is limit. And we ask it to limit the output by 5 rows. And we'll be looking at 5 rows only. Go ahead and see there are multiple functions inside it. Type them one by one and see the output. I will talk about format function. Which function? Upper left function, format function, reverse function. Because I will talk about the format function. We are using format function right now to display the 0 decimal values. Left function here is simply taking the first 3 letters out from the left-hand side of the sentence. Upper function is converting this into uppercase. Reverse here is simply reversing whatever is written. So if it is written ABC, it will reverse that into CBA. And then we are concatenating all together while typing the separators here. So here we go. Let's talk about the format function in detail. When to use this format function? When to use this format function and what it is for. First, let's look at the syntax of the format function. The syntax here looks like this. Inside the format, we can format any number to anything. So if we can go ahead and decide the decimal places with it, right? We can also define the locale with it as per the zone. So we can go ahead and format the numbers in any type of format we want. For example, if we want to go ahead and we want a currency display. Currency display means ensuring 2 decimal points. So we can type a number, comma 2. That's our currency display, meaning 2 decimal, fixed 2 decimal points there. Second here is, we can go, if we had a large number, we can add 1,000 separators to it. Or if we want a localized number format. So maybe if someone is writing currency in their own format, not everyone is going ahead and applying 1,000 operators every time. So every country has a different norm to type the numbers and the currencies. So we can go ahead and define that too. Or if we simply want to multiply by 100 and add a percentage sign there. So in these multiple cases, we can use the format function right here. These are one of the many answers where we can go ahead and work with it. So I will show you few examples here. So let's take a very simple example first. So if I'll go ahead and type select, here, and in select here, I will use format. This is format. And let's say I will go ahead and type a big number. Okay. And I'm typing here as 0. I'm typing this as formatted. Okay. See, it has added the 1000 separators for us right here. Now, if I want to add a percentage sign here, what we do? We again go with select here, and now I will type format. Okay, I will go ahead and type format. Inside format, let's go ahead and I'm writing, let's say something like this, some decimal values right there. And we multiply it with 100 because that's what we are looking for, right? Comma 1. I need one decimal here. If I go ahead and type it like this, right? We want to change it into percentage here. So look at this, what happens? We see 76.8. Now what I want to add a percentage sign in front of it. To add the percentage sign in front of it, now I will use concat here. And after format, we can go ahead and type the percentage sign right there. And it is going to concat and type the entire column like this too. So these are the few examples here. Okay. Go ahead and check out the format function. Yes, all right. So I have one question for you here. Okay, we all know about the products table, right? We have all seen the products table right here. And we know about the product line too. If I ask you right now, to get the average buy price, of each product line, here, how should the output look like? What should be the table structure of the output? Let's say you're creating that on pen or paper or in Excel. So how do you think the output in the result grid should look like? How many columns we should have in the output? If we want average buy price of each product line here, then how many columns we should have here? Which two columns? Product line, and average here. Now in this product line here, what do you expect? Should we go ahead and extract the entire product line column from here to here? Should we go ahead and extract the entire product line column here as it is? Should we simply copy paste it entirely same? No. What we will do here is we'll look for unique entries, right? We'll go ahead and we look for the unique entries without any duplicates, of course. So with these unique entries here, when we type unique entries only here, meaning each product line should appear only once, right? So that if it is classic cars here, and then we have got motorbikes here, and we have got vintage cars here, whatever we have. In front of these unique entries, we will only have one associated average number right here. Correct. So this kind of reporting, so we all know this is how the reporting has to be done. So this kind of reporting is called as aggregate reports. These are called as aggregate reports. Okay. So these are called as aggregate reports, everyone. Why? Because we're aggregating as per individual data point. Right. If you have learned Excel, it is exactly what pivot table does. If you have learned Excel, this is what exactly pivot table does. So how do we create these kind of reports in SQL? This is where group by comes in. group by comes in. We haven't touched it yet, right? Remember in the sequence I have shown you there is group by and having. So this is where group by comes in. What group by will do here is group by will go ahead and simply fetch the unique list of any categorical variable. Group by fetches the unique list of any categorical variable, any categorical variable. That what the group by will do. Okay. And we already know if we want to do any kind of calculation, that calculation is done within the select query that we are aware about. So that is fine. That is done by select. But group by will be the one who is going to fetch the unique entries right here. So last example, everyone, let's go ahead and see how group by is applied here. So we'll go ahead and we apply group by right now. So what we want to get, we want to go ahead and get the average buy price of each product line. So first thing that we do here is we type select. In select here, we are working with the product table here. So let me go ahead and type product first. And after select here, let's expand it here and we will get the product line here. After product line here, what we are looking for? We are looking for to calculate average. Average of what? Average of buy price. So I'll ask it to get the average of buy price here. I'm calling this here as average. Okay. However, after from product here, we have to use group by here. Why group by? Because group by has to inform select that do not fetch the entire column. So when the select is in the select, group by will tell it, let's see, you're not supposed to fetch the entire column. I will go ahead and pass you the unique list of product line. So remember that whatever categorical value you write here, it has to be written here too in front of select. Okay. Because select is the one that decides the output table structure. So if we are grouping it by product line has to be part of the output. So group by will actually pass the unique list of product line to select, and then select will go ahead and calculate the average right here. So once I execute this here, you will find the average right here. Of course, it doesn't look good. Okay. So we can round it off or we can format it out. So it all depends on you. What are you looking for? So currently I'm rounding this off here. So this is how group by works. Now, why I have taught you group by? Because I'm going to give you multiple practice questions with the where the group by will be used. Okay, so let's begin here. So what we are looking for here is, let's go ahead and see for each country, let's figure out that for each country, what is the average credit limit? What is the average credit limit? And while we are looking for it, we want to see only the top 5. We want to only see the top 5. Let's go ahead and see how to solve it. So first thing we have to understand is we are going to use classic models. We have to make sure that the classic models is default. All right. Once you set that as default here, now let's break it down here. In breaking down here, first we want to go ahead and get 2 columns here, right? First column should be country. Second is average credit limit. Then it is asking for top 5. Let's see how we will get to the top 5. First, let's solve country and the credit limit right here. So first thing that we understand here is we have to work with the customers table right here. We can go ahead and right here select. Select what? So we need country. We'll go ahead and get the country right there. And comma, we need average right here. So we'll calculate average for now. Average for credit limit, everyone. Now this much we understand. And we can name this here as average credit limit. Okay. Till here, everything is fine. However, we need aggregate report because we cannot simply fetch the entire country column. We need unique list of country there. So go ahead and ask it to group by and country right here. Now, this much we understand from our previous example. So this is it. This doesn't look good. Why? Because it has got too many decimal points right here. So let's round it off. We'll go ahead and we round it off here. We already know about the round function, everyone. So here we go. We will go ahead and ask it to round it by the 2 decimal points, right? And now here we have the average credit limit with us. Now in this average credit limit here, we want to see top 5. Now how do we get top 5 here? This is where it is very, very interesting. Remember our select query right here, right? In this entire select path here, this group by right now, after group by here, we have order by and limit. Order by means sorting. So afterwards here, if I want to go ahead and see who has the highest or the lowest credit limit, which country has the highest or lowest, we can simply ask it to order it by. So when we go ahead and ask it to order by, meaning sort this particular output, this result grid output here, by what? By average credit limit. So we can simply go ahead and write the name here. Since average credit limit is already a name inside this aggregate report, order by works when the select has given us the output. So in the output, average credit limit, this name is taken as name of the column there. So if I go ahead and ask it to order by average credit limit and we execute this right here, it gives us everything in ascending order. Okay, it is giving us an ascending order by default. So if I want to see who has the highest, how do we get the highest here? We go ahead and we give the descending order. So we move forward here and we define that go ahead and give us in descending order. Now here, when we define descending order, we do see the top here. See? But we don't want all the 110 product rows here. We are not looking for all the rows out there, all the 27 rows here, right? We don't want that. And so what we do, we go ahead and ask it that, okay, I don't want to see all the rows here. Limit the rows by 5. Now, what is limiting the rows here? Limiting the rows here means we will go ahead and use another keyword, that is limit. Limit is pretty simple. Okay, limit here goes ahead and simply limits the number of rows from the output, right there. So this is limit 5. The moment I put limit 5 here and execute this, we have top 5 right here. So this is limit. So it is just in succession, everyone. So right now we have each country average limit and we want a top 5. To get the top 5 here, we'll use the order by and limit. Okay. Very simple. We are simply talking about the group by and we have joined with order by and limit. After the order by, remember the sequence. We will put the limit where we want to go ahead and limit the rows in the output. It is always written at the end of the query because this is the last thing we execute. Let's go ahead and see it just quickly once more. Okay, just a quick review here. What is the order of execution here? Order of execution that happens at the back end. Okay, we don't have to go ahead and do anything about it. Since we know about group by here, and we will soon see having also here, understand when these queries are actually executed at the back end. Whenever you're writing a query, even you're writing a query, a simple query like select everything from customers table, it will first go ahead to your address. What is the address here? That which particular database it is and which particular table it is. It will first go here. And then it will go to all the columns that you're asking for. If you're giving a database filter, so it will go to the address. Inside the address, it will go ahead and then put the filter there. Maybe you want everything from USA. So it will go to the address, it will filter out all the rows from USA, and then it will go ahead and select the columns for us in the output. In the similar manner, it will go ahead and execute everything out here, and then it goes to select. So once select will decide that, okay, this is the calculated output that you want there, and these are the columns you want there. Once this is done, then the remaining answer or the output is sorted and chosen that how many rows we want to view. So this is the order of execution. If we know this order of execution and we understand this here, it will help us to write the queries properly. At least help us to break down the query and understand that what goes where and which one of the queries is helping us to actually apply certain conditions. So this is the order of execution here. I will go ahead and share in the session materials at the end of the session. I will share a write-up, okay, which will talk about the order of execution in detail. But that is what we have to remember. So this is the limit, everyone. Okay, and this is the group by. So we'll move forward and we'll talk about group by and having here. Sales rep. We have customers here, right? So let's go ahead and count the number of customers mapped to each sales representative. So what we want here is that for each country, we have got sales representative and we want to go ahead and count the customers for it. So we need first country column and then we need the sales representative and then we want to count the number of customers. So far, we have only written one categorical variable here and we want it to group by just by one. Now we'll go ahead and add the sales representative too, meaning we want the select to filter out by two columns here, one with the country, one with the sales rep, and then count the number of customers mapped to each of them from each country. How do we write that here? One thing is simple, that we are working from customers. That is there. We are working in the customers table. Now within the select here, we want to select country. This is also fine. After country here, now we are looking for one more categorical value, that is sales rep employee here. The name is too big for me, so I'm going to go ahead and give it a smaller name here. Next here is we want to count the number of customers. Next, we want to go ahead and count number of customers. What we should be counting here, everyone? What we should count here? If we want to count number of customers, what we should count in the third column? Out of the customers table, of course. Okay, we have two options right now. Anyone else? Right. So remember that we want to keep it easy. We can go ahead and ask it to count customer number. However, we can go ahead and ask it to count anything. However, we can go ahead and we can ask it to count anything, any column right here. Why? Because if we go ahead and count any of these columns here, it will still count the entire rows. We can ask it to write count asterisk, meaning it will simply go ahead and count the entire rows in the entire table. Of course, it has null values, then we'll have a different answer. So count customer number seems fine. Why not name? Because name can be similar. So it might not count all the rows out there. So instead of asking it to count something else, it is we'll count customer number because it is always going to be unique. Yes, primary key concept, correct point. So count customer number and I'm going to name it as total customers. Customers mapped, because these customers are mapped to each of the representatives to take care of. So here we will go ahead and type customers mapped. There we go. Now what's after this? Is it done? We have to group it by. So when we are writing the group by, everyone, when we are writing the group by here, we want to group by country, right? So country, comma, we want sales representatives. So we'll go ahead and get comma here. And after this here, we can order it by. Okay, so let's order it by country then. Let's ask it to order it by country. Now, when we ask you to do this here, look at this. What we see right now, that Australia has only one sales representative here. Australia has only one sales representative here, and there are 5 customers mapped to that person. Similarly, when we move below here, we see USA right now. And within USA, we can clearly see that we have got multiple sales representatives here, and they have been mapped with exactly 6 persons each. So likewise, we can see Switzerland has these many customers, but few customers have not been mapped with any sales representative there. So we do have null values. All the null values will show up right here. And telling us that there is no sales representative mapped with these 10 customers in Germany. Like this. Now, this is a simple group by. In this group by here, we can go ahead and write 2 categorical variables right there. And we can still get the correct answers. While the number of categorical variables increasing, what if there are 10 columns right there? That one has got year, another has got employee number, another has got your employee name, then you need their month details, quarter details, their sales target and whatnot. So if the number of categorical variable increases, okay, how do we there is one more way to write this query. See this very carefully. See this very carefully here. Till here, everything is going to be exactly similar. Till here, everything is going to be exactly similar. Now, see right here. Remember that in group by and select whatever we type whatever we type in select, if I'm typing two categorical variable in select, exactly those two categorical variable has to be mentioned in group by. For example, if you will mention, if you will say that, no, it's okay, I want the sales employee number here, but I don't want it to group it by. I just want to list it there. It cannot happen. It has to group by both the categories here. Otherwise, it will try to grab the entire row of 1,000 customers maybe right here when we have just 27 countries. So we have to go ahead and write the exact number of categorical variable right here and the exact name too. So to avoid the conflict and the errors here, there is one more way to write it. Before I write it there, do you understand that in this result grid, country is the first column? Do you agree to that? In this result grid, sales rep is the second column and customers mapped is the third column. It's the similar manner we type here too. This is the first column we want. So in the select query, we write country as a first. If we want sales employee number to be second column, we type it on the second space. We want count as the third column, we type count at the third place. That's how we write. Do we agree to that? 1, 2, 3. Number of columns here. Do we understand this part that yes, this is in the output is 1, 2, and 3. So what we do here is this. We go ahead and we say that, okay, do one thing, group it by the column 1, comma, column 2. And order it by, in this example, let's order it by customer mapped. That is the column number 3. Column number 3 right there. We can go ahead and write it like this too. So if I go ahead and execute this right now, we still get the same answer. If you want this in descending order, you get that in descending order too, right there. See? Okay. So go ahead and see that there. This is one more way to type your group by queries. And yes, order by also understands the column number here because select by then has already given it the output. So see how do we can go ahead and get the group by done with 2 columns plus another way to type it. Now here, all right, let's add one more condition to this. Now we want to see customers mapped. Now we want to see customer mapped. We want to see the countries. We want to see the country list. Where customer mapped to sales reps are more than 5. Okay. Only the country list where customer mapped are more than 5. So in this case here, of course, I'm talking about what the output that we are looking at here. But please tell me one thing. Where do we apply the filter? On which particular column we need to go ahead and apply the filter? We know that we have to apply the filter where customer mapped is more than 5. All right. So on which column do we need to apply this simple mathematical filter, comparison filter? Customer mapped? Do we all agree that yes, customer mapped? Okay. Where is the customer mapped present? Is it present anywhere in the database? Our customer map is present right here in the result output. It's a calculated field. It is in the result grid output. We do not have any customer mapped named column here, right? It's a calculated field here. So whenever we have an aggregate report created with the help of group by, and we have some filter to use here inside the calculated group or aggregated option here, okay, where group by is already fetching the unique list. In this case, we always give the filter with having. We always go ahead and give filter with having. Why? Because we have to give a filter exactly on a calculated value, aggregated value here. So now inside having here, having clause here is used to give the filters only on the aggregated reports created with the help of group by. So here we can say having customer mapped greater than should be equals to 5. When we go ahead and write that here, okay, this is it. See, we are getting all the customer countries here with customer mapped greater than 5. We can go ahead and ask it that can you go ask it to order by 1 here and see. We have got country right here. Okay. So this is how having is used. Remember that having is a filter clause, meaning that this filter clause here can utilize all the operators that we have seen so far and learned with where. This is having clause, everyone. Remember that this having clause that we are looking at, right? This clause here is avoided if we can avoid it with the help of where clause. It says that because having is executed once the group by and select and calculations all are done. then only the having takes effect. That's why it is avoided if we can. If we can apply it with where, we will apply it with where, not with having. I would like you all to beautify this here, because once you beautify this here, it looks really good and legible. You can read it easily. How many product lines that we have here? Okay, we have got classic cars, vintage cars, and trucks, buses, ships, planes, motorcycles, and more. Okay. However, what we are asking here, it is asking here that they don't want to see classic cars or something else, ships or something else. They simply want these from the list. So first we will figure out from. So which table are we working on? We have figured that out very easily. We are working on the products table there. Fine. Now from the select here, which columns do we want in the output? What should be the first column? We need product line with average MSRP, meaning the first column has to be product line. We agree to that there. And after this here, we want to calculate average MSRP right there. Now, after select here, we have to group it by. We agree, okay, we understand that we have to group it by two. And we have to group it by the product line right here. We want to group it by the product line right here. However, now things will be different. What's different here? Now it is asking here that it doesn't want all the things there. It simply want to go ahead and filter out only these lists. So tell me here, how do we filter out the entire list, everyone? What do we use to filter out from entire list? We use where clause, very good. Now with the where clause here, we use the where clause here. Why are we using where clause? Because which column do we need to go ahead and filter out? If we want to filter out every row which contain these four names, which column contains these four names, everyone? Product line. So we need to go ahead and bring the product line. Since product line is present in the database, we will be using the where clause. Great. Now tell me which operator helps us to filter from the list. Because we have to go and ask here that go and check the entire list. And if anything is present from the entire list, go ahead and give me the output. Right. Very good. We will use in operator here. We use the in operator here. Wonderful. So now we have covered almost everything. Last is the remaining here, average price less than 100. So whatever average MSRP we have seen here, all right, from whatever output we have there, we need to go ahead and filter that also. So if you want to filter this here, what do? We will go ahead and use having. Why you are using having here? Because we are using this average that we have calculated out. We want to go ahead and calculate it out average. We want to filter this out. If the average MSRP is less than 100. Are we leaving anything out? The first line, everyone, the alphabetical order of the product line. So we can go ahead and we can order by. Order by what? Product line, we can type one, right? So this is the product line. We want to go and order. That's how we type it. So first I'm going to write select here. We select here, we know we are looking for product line, everyone, and we want to type average there. I'm rounding it off. I'm rounding it off here. Easy to write it together. And this is here as I'm taking this as average MSRP. Now, from where we are talking about, we are talking about from the products right there. After from products here, now we go ahead and write where clause because select from and where. So in the where here, we'll say, and go to product line here and find it out where any of these names are present. Remember, we have to go ahead and give the single quotes right there. After where is done, now we go ahead and type group by. Group by what? We can type one. And in the having here, we cannot say having find out the 2 greater than 3. We have to go ahead and write the entire name here, where average MSRP has to be less than 100. And let's figure it out. Is it 100? Yes, we do have the option there. Now we need to order it by. So we can simply ask it to order by here. Order by 1. And here we are. Even if I don't write order by 1 here, it will be order by 1 right there. Go ahead and check this out, please. And I would like all of you to reformat this too. After reformatting, it does look better and legible. There is one task that I've written there. So now we will go ahead and we learn about a little bit about the date functions too, and we will talk about group by, roll up, and subtotals too there. So we're going to talk about two things. So first thing is we will go ahead and see how do we add the subtotals and totals there, while we also delve into some date functions. Okay. So the first question here is we want to go ahead and figure out total number of orders placed each year in the orders table. So what we are getting here is total number of orders is fine. Yes. Yes, we have to. Because see here, it is asking us not only total number of orders, it is asking placed each year in the orders table. So if we go ahead and we look into the orders table, everyone, we'll see that orders have been placed every year. Orders have been placed every year. Yes. And almost every day. And every day there are multiple orders right here. Right? It means that we have to go ahead, we have to extract the year, and then we get to count the number of orders each year. So let's go ahead. What do you think we extract the year with? Which function can we use to extract year? So let's go ahead and see. So first thing that we figure out here is that we want to go ahead and get everything from the orders table. So this is the orders table right here. Now what two columns we want here? So inside the select query here, first we want to extract year. So we'll go ahead and use the year function. See the year function right there? Yes. We want to go ahead and extract the year out of order date. Okay, we are going to name this as order year. So we can name this as order year, comma. And what we want next? We want total number of orders. So how do we get total number of orders, everyone? We use count, right? We go ahead and we ask it to count there. So you go ahead and ask that, see, this is the count function. Go and count the order numbers right there. We don't want to add them up. We simply want to count them, that how many are there. I'm going to name this as orders count. Okay, this is our orders count right here. Here we go. Now we have two columns and year has to be aggregated. We have to extract the year and then we need list of the unique years. So we go ahead and ask it to group it by. So you have to group it by what? First column, we can directly write 1 here. We don't have to go ahead and write everything again. So we can simply write group by 1. When we write group by 1 here, we get 2003, 4, and 5. Now this is something very easy to do and understandable too. Now what we want here is we want to go ahead and add the grand total right here. We want to go ahead and add the grand total of the orders count right here. So what happens here? We have to, how do we add that up? If we want to go ahead and see grand total through and see grand total at the end, we will simply go ahead and use the roll up. What is the roll up here? So we will go ahead and write that I want the group by done, but at the end, I will want it with roll up. With roll up is the entire keyword. Once we add it after group by here and we execute it, it gives us the grand total right here. And no, we will not be able to go ahead and replace this null value with the grand total or some name there because it is not the part of the order here right here. So this is group by 1 with roll up right here. So go ahead and get this, please. Date and group by. The caution that I am pasting here is, okay, it simply means which day, Sunday, Monday, Tuesday, which day we are having the most number of order placed. Because if someone knows that, accordingly, they can roll out the offers, discounts, and everything. Read it first completely. Find out which day of the week has most orders. What is meant by most orders means most number of orders are placed. Meaning, number of orders are placed, meaning we need to go ahead and count the orders too for each day. Then only we'll have the answer, right? That's Sunday, Monday, Tuesday. When did we had the most days there? So 50% there. So how do we go move forward this with everyone? So we will go ahead and type select. And we already are aware that we want count there, right? We want counts again. So I will go ahead and write the counts again. And we know we are looking at from the orders here, and we have to group by the days that we have there. So this much is fixed. This much is fixed. What we want in front of count right now, we want the count to be done by individual day. So let's figure out which function is going to help us. So if I go ahead and type day right now, look at the list. And here you'll find day of the week. So once we find the day of the week here, we'll go ahead and ask it that extract the day of the week from the order date right here. And I'm going to call this as order date. Okay, I'm going to call this as order date. Now in this order date here, from the orders group by one, this is what we get. So we want to find out most count of orders. So let's order by 2. So I will go ahead and write order by right here. Let's order it by the second column. That is the count there. And that's the order by. Let's make it descending. And now we know this is the highest. The only problem is I have no idea what day number 6 is. Is it Monday, Tuesday, Wednesday, or what? Because I cannot say that this one is Monday or Sunday. No idea. So we have to find it out. Whether this 6 is what? Whether one is a Sunday or a Monday. When does the week starts here? To figure that out here, okay, we will go ahead and add one more thing here. After day of the week here, let's go ahead and see one more function called as day name. Day name here will tell us name of that particular day. So here we go and ask that go ahead and get the day name here. I'm going to call this as order day name. Here we go. Now here, since we are adding one more categorical variable in group, I will say group by 1, 2, and we want to find out who has done the most, right? Which day has the most. So now we say count is 3 here. So we'll say order by 3 right here. And so here we have. So 6 is the Friday. The day starts from Sunday. Go ahead and get this, please. There are more date functions out there. Now here, let's go ahead and see what if we want here that count of orders placed in each month of each year. So again, we want count of orders here. So this is going to be similar. So this much is going to be similar. The only thing that is going to change here is the functions. So count is going to be remain same here. What we want here is that we want for each year and month. So order year here, and then we want to get order month. Then we want to get order month. Okay. Now, first here is year. We are aware of the year function there. We can go ahead and type year function right here, and we are good with that. Now, let's go ahead and find out another function which can get us month. So now we have two options here, month and month name. Now it is quite evident. If we take month, it will give us numbers. Month name will give us the numbers. So let's go ahead and get the month name there. So here it is. We have got month name here. See, this is ordered month. And of course, we have got two things here, year and month both. When we go ahead and execute this right here, it gives us two columns right here, order year and month. And fortunately, this order month that you see here, it is properly sorted to in proper January, February, and March. Right here. Okay. We are good here. So this is order and month right there. However, what if instead of writing year and month in a separate column, we want to go ahead and write it in a formatted manner in one single column like this. Meaning I don't want year as a separate and month as a separate column. Instead of this here, how about we want to write it something like that? This is 2005 here and maybe January. Okay. So we want to go ahead and format it in one single column. So how do we format this in one single column? To format this in one single column, again, this part is going to be similar, right? This part is going to be similar. What is going to differ right now is the select statement. Is the select statement here. And the select statement, count is fine. What we want is a formatted value here. So if we want to customize the date format, we will go ahead and use the function called as date format right here. And inside the date format, in the syntax right now, we'll go ahead and pass order date because we want to format out of the order date. what we want to format here, we want to go ahead and get the year and month out. Yes. So we can go ahead and give formats like this. We can go ahead and type percentage uppercase Y, a hyphen there, and then percentage uppercase M there, and close the parenthesis right here. This will become as our order, year, and month. So this is what we are looking for. This is what we are looking for here. So this becomes our order, year, and month. So that is our first column right there. Okay, let's see how does the output looks like. Here we are. All right, first year and month separate here, and then we are getting year and month together in one column formatted properly. So it's a custom format, everyone. There are many ways to use this custom date format. Let me show you here what happens if we go ahead and instead of uppercase, what happens if I go ahead and write lowercase? Because now we understand here that if I'm writing M here as for in the uppercase right now, we have written M as the uppercase here, right? What we are getting in the output? Entire name of the month, correct? And if we are typing here Y in caps here, we are getting the entire 4 digits of the year. So what will happen here if we go ahead and type all of this here in a smaller case? In a smaller case right here? If we go ahead and type it like this here, observe right now what is happening. Both of them are in numbers, right? Both of them are in numbers right now. Meaning, and that too, when we are typing lowercase m here, we are getting only last 2 digits. We are getting only last 2 digits here. And m is now written as a number. So if you want to go ahead and if you want to go ahead and properly write it, maybe we can change it a little bit. Maybe we can go ahead and write it like this, that this should be y here, right? And this m here can be in numbers. Either this is a combination, or maybe we want to go ahead and get the abbreviation of the month. So if you're looking at the abbreviated month name like JNMAR, DC like that, then we will go ahead, instead of lowercase m here, we type lowercase b. And when we type that, we get it like this here. And it is not required that you always write percentage y slash b there or hyphen b there. We can always go ahead and mix it up. Okay, when we say mix it up here, maybe we want to type b first and y later. It will come up like that. Okay, so go ahead and find it out. Go ahead and check it out, please. When we use AI, this is so faster. AI can help you in understanding things here, or maybe you can ask AI to explain the concept to you with some examples. But when you're working in real time, first part is Sudhanshu, we will not be able to give the database structure to it. However, it can help us write the base queries for us. It is good for practice measures, but in real time, if you want AI to work with you, you have to give the entire detail to it. So unless your organization is not giving you any internal AI application to you, never ever use AI for your organizational data. And with AI, it is not faster. Why? Because you have to fact check it by yourself. So you have to know at first whether AI is giving you the right answer or not. Because no matter how powerful the AI is, even perplexity that writes in the bottom that this is AI, fact check it first, and then only believe that it is correct. And I have seen that in my experience also, AI not always gives you the correct code. You have always have to go back and cross check it. For beginners, it does look faster, uh, but it isn't, because now there are the ethics to use AI. And of course, it's a danger for organizational data too. So let's go ahead and find this out. So next here is a very simple question, everyone. We want to go ahead and find out how many average days are we taking between order date and ship date for each month. Every month, how many average days are we taking to ship something? Meaning once we get the order, how many days does it take us on an average to ship it out of the warehouse? Okay, so that it can then take that many days to reach that person. So what is the average days between order date and ship date for each month? But we want to focus on wherever we are taking more than 5 days to process an order. Okay, this is where we want to focus on. Can you please go ahead and try that by yourself? Can you find the function that will actually give us the difference between the two dates? Okay. First thing that we understand here is we have to go ahead and first get the month here. So we can go ahead and type select here, and we can ask it to get month. So we are taking month name out here, month name out of what? Order date. Now till here, this says we are calling it order month. Okay. After this order month here, we want to go ahead and calculate difference between the dates here. Correct? No. So to get the difference between the dates here, I will type date here and see we have got date, date add, date format, date sub here, and date diff. Date diff, everyone. Date diff is the difference between the dates. This is the common function here. You will find that in Excel too. So in the date diff here, okay, it is very straightforward. It will ask you to the last date first. So we will go ahead and find the difference between two dates. So please understand what we are trying to say here is, I want to see that how many days we are taking between this order date and the shipping date. See here, if someone has given the order on 6th January and we are shipping it out on 10th January, what is the difference between this? How much difference of date is there? 4 days, right? Now, similarly, we want to go ahead and do this calculation for each and every row. Now, what we want to do here is we want to go ahead and we want to do this calculation for each and every row. And then for example, January here, right? So for January here, we want to go ahead and do this calculation here. See, this is the whole January right now. Once we have done the calculation for each and every row that, okay, what is the difference between these here, we want to go ahead and calculate this average difference that you have calculated for each and every day for each month right there. So we want to do two calculations here. One is row-wise calculation. Second here is we want an aggregate calculation within that. So let's go ahead and solve it step by step. The first thing that we are looking for here is in each day, we want to see the difference between shipping date, comma, order date, right? See right there. Now here, when we are asking you to go ahead and find the difference between the two here, first thing that we do is we don't want to add a calculated column in the extracted table now. We are looking forward to calculate an average out of it. So we'll ask it that whatever calculation you will do here, go ahead and calculate the average of date diff right there. So this is, we get the average difference of days here. Average difference of days here. From where? So let me type here from orders table here. And of course, we need to go ahead and group it by. So here I'm typing group by one, that is month. Let's look at the output for now here. There are too many decimals again. So we need to go ahead and round it off. So we'll go ahead and round it off here. We ask it to round the entire function. And here we go. Format. Okay. So now we are getting that every month here, this is the number of days we took to ship something right there. Now what we want to focus on average where that is more than 5 days here. So this is the average difference in days. We have to go ahead and apply having here. And having here, we can say having average difference of days is greater than 5. And we have got 1 month only, that is October. That is date diff. Date diff will go ahead and give us the proper difference between the two dates here. It sometimes also get hold of the leap year. If we go ahead and yes, you can ask it to go ahead and minus the shipping date with the order date. You can do that. When we type it like that, okay, there are a few discrepancies might happen. That's why we have a function here. So let me show you about this function right here. So if you ever want help, right, you can simply ask for help by writing help like this, that help me with the data function there. Once you write this, what you get the description of it, right? So as you can see here, this is the syntax, everyone. What we see in the syntax here. Date diff has only two expressions. Okay, it will give us the value in days from one date to other. Expression 1 and expression 2 are date or date and time expressions, and only the date part of the values are used in the calculation there. And they're also giving us a simple example right there. In this example here, they're giving us 2 date and timing there. and we are getting the answer. And we are getting the answer in number of days right there. So it works with time too. And a simple minus will not work on time. Okay. So this is dative. Difference between date here. This you will find in Tableau, you will find that in Excel, you will find this in Power BI almost everywhere. In Excel, it's a hidden function, not shown there in the sequence. It is more fun to type in Excel because you cannot see it there. And in Excel, it will also give you an variation. Okay, in Excel, you can actually see the differences in years or months or days. And Power BI also. It is quite interactive in Excel and Power BI. And Tableau also, it gives us multiple options. Go ahead and find it. I need to have a column name for it to work. Yes, you do need the underscore. There, you cannot have spaces because it doesn't. If you give single quotes, it thinks that it is some text. It doesn't understand that as name. You got it right. While you're working on that, okay, I will simply show you subtotals here. So with the roll up here, we have seen subtotals here. So we have got year and month separate, remember? If we go ahead and add with roll up here, and we have two categorical variables, we will go ahead and get subtotals in between, say. Okay, we get subtotals in between. So after every year, you'll find a subtotal for 2003, for example, here. And then you go ahead and get subtotal for 2004. Then you go ahead and get subtotal for 2005 here, and then a grand total. So like this, you will get the subtotals and grand totals here if you have two categorical variables. So subtotals are automatically added. Not be able to replace the null values here because by default, okay, when we are using this engine here, it doesn't allow us to replace these null values here. So there are a few preferential settings and the admin access we need here to change that. And then only we get to replace the null with queries. We can easily replace the null with queries here, but there are some settings that which will not allow us to do that. But for that, we need a professional version. This is the free version that we are working with. Use not complete code. Created here a small aggregate value here, where we are saying that this is the person 1, this is the person 2, and this is the person 3, right? And these people have been hired on contract, and they have been paid here, everything in thousands, okay? Everything in thousands here. So they have been paid 2K, 3K, and 5K here. Done. But so here we have got more people here. So they have all paid in thousands. Then we got to know about that they have been employed for different purposes there, right? So they have been hired for different departments here. So now we will go ahead and add the department name here. So these people hired for department 1 here. These were department 2 here. And these for department 3. Done. Now, if I ask you here to give me totals right now, so tell me how much total we have paid so far. So how will you get the grand total here? How much total we have paid so far? What will be the grand total here? We add that up, everything, right? So we have here, 5, 5, 10, 11, 12, and 13, right? Very good. So we are adding up it to 13, right? That's grand total. But if I ask you now here that, okay, tell me department-wise how much we have paid here. Then give me subtotals also. So how do we get the subtotals here? So we have to go ahead and write some thing along here. What is the subtotal for department 1 there? We have to add a row here. What is the subtotal for department 2? Add a row here. What is the subtotal for department 3 here? Add a row here. Correct? So what's the subtotal here? 5. What's the subtotal here? 6. What's the subtotal here? 2. So we have to add a row here and add the subtotal right there. That's the total for department 1 total right there, department 2 total right there, and likewise. So that's what rollup is doing for us. We don't have to do this. This is what rollup does for us. It will go ahead inside that. And if we have two columns there, it will give us the total and the subtotal for us. So we don't have to define or do calculations. It knows that it has to go ahead and add everything up. Okay, do we understand the rollup right now? Next here, we are moving forward, everyone, for logical statements right there. What are logical statements? We have seen comparison operators. We have seen and or between, where we can go ahead and find comparison operator one single statement, and then and or in between we can filter out with more than one condition, right? Then why do we need logical statement like if else and case and when? Or in this case here we have got if function there, we have got if function there. Why do we need if and case and when? Remember that with the help of comparison operator and with the logical operators out there, we were able to only filter out by those conditions here. Logical statements are used when we want to go ahead and add a logically calculated column or a logically calculated column within the data, within the result grid there. For example, this is our customers database, right? In this customer database here, we want to go ahead and read their credit limit. And based on their credit limit, we want to give them credit cards. That if you belong to this particular limit here, we can offer you this credit card. However, the calling team that we have there, the basic sales team that we have there, we cannot simply go ahead and share the credit details of some customers. We cannot do that. So we have to go ahead and get name, customer name, all right, their contact, their contact, their contact, plus which credit card they are eligible for, which credit card they are eligible for. All right. We cannot simply share their credit card score with someone or credit card eligibility with someone in a sales table there. We will simply tell them the credit card eligibility, that these are the cards that you're eligible for, right? Have you received these calls? That they know your name, they have their contact number, they even have your email ID, they know which credit cards you are eligible for. Okay, we all have received those calls. So we can go ahead and do that. Why? Because we can go ahead and say that, let's see, if your credit limit is more than 75K, we are offering you a gold card. If it is between 50K and 75K, then we are offering you a bronze here. And other than that, we are offering you a silver or something else, right? So what we are doing here is we're simply checking the number and writing it out. We're not doing any calculation. It is a simple logic we're applying here. So when we want such kind of logics applied here, we go ahead and we use if and else. Another option here is, for example, we want to go ahead and we want to go ahead and assign performance category to our employees. So if right now the season is going on, okay, those who are working, those know that appraisal season is going on. So maybe now they want to go ahead and based on the job title and the performance, they want to give us a performance category. They want to assign a category to us: good, bad, and excellent. Okay, they can go ahead and do that based on whatever logic they have with them. So when we want to add any kind of calculated column like this is where the if and case and when comes in. First, we'll go ahead and look into the if function there. Those who have worked in Excel, you already know about the if function. It is exactly the same here. If you will look into the if function here, this is how the syntax looks like. This is how the syntax of the if function looks like. Inside if function, it asks you that, okay, what is the condition that you're looking for? And if the condition matches, if the condition is true, what is the value you want to give? If the condition is false, what is the value you want to give here? This if function right there, this if function right here, helps us to check one condition and give two outputs based on that. If condition is true, what is the output? If condition is false, what is the output there? And if we want to go ahead and we want to check multiple conditions and we want multiple outputs, then we have to go ahead and use nested if. We have to go ahead and use nested if, or we resort to case and when. Case and when is easier than nested if. Okay, let's go ahead and solve it out. So first thing that we see is that we will see customers here. we assign them the categories based on the credit limit right there. There we go. So first, let me explain. Okay, so let's go ahead and learn about the logical statements right there. And logical statements and the functions. First, we are going to talk about if here. If is pretty straightforward. Okay, we have to give a condition and the output value. If the condition matches, output value if the condition doesn't match here. So let's go ahead and apply individual customer. Okay, which credit card do they qualify for? So we will simply give them two categories, right? We'll say that they are high credit. They are high credit if their credit limit is above 50K. All right, we'll call them low credit if their credit limit is less than 50K. So if there's 50,000 or below here. So let's see how do we go ahead and get that. So here I'm writing select. In select here, we are getting it from where? We are getting it from the customers table here. So once that is established, now we can go ahead and get what we want. So from the customers here, let's get their customer number, also let's get their name here, and then we are looking for their credit limit. Now in front of credit limit here, now we want to add one more column where we have these categories assigned. So now we go ahead and type the if function here. See, here is the if function. Now we open the parenthesis here without any space, everyone. And what is the condition here? Condition is that go and check the credit limit. If the credit limit is greater than 50K, if it is greater than 50K here, if it is greater than 50K here, and the condition is matching, go ahead and type high credit. Go ahead and type high credit. If it's not matching, so value if true, that is high credit right here. And if it is false here, go ahead and give low credit as the output. As the output right there. So we are asking if function here to do that. Of course, it's an entire function right there. So we go ahead and give it a name here. So I'm going to give the name here as customer categories. You can write the entire name too. And see, we have a calculated column. There is no calculation there, simple logic application right there. I will beautify this so that it looks better, right? See how easy it is to understand now. So go ahead and get this, please. Simple logical function right there. If. Next question here is, go ahead and try to solve it by yourself first. Okay, just solve it with me. We'll solve it step by step. It says that assign a performance category to employees based on their job title. What are the conditions here? Condition here is if someone is president, okay, we will give them a category of top management. So not performance category, let's give them management categories. That's correct. And if they are manager, any manager, right? If there are any kind of managers out there, we'll call them management. And if there is anyone else other than manager and president, we will simply go ahead and call them staff. Okay. So tell me here, first tell me here, which table are we talking about here? Which table we have to work with? Employees table, right? Very good. So first thing that we have figured out is that we have to work on the employees table. I'm getting this out here. Now we go ahead and type select. Now in select here, which columns are we looking forward? Of course, we want to see the employee number, right? And we want their name there here. And of course, we're looking forward to their job title. We need these three columns right there. Yes. Now tell me, how many conditions are there that we need to check right now? Because after a job title here, we need to go ahead and type if there, okay? But if can check only one condition. And how many conditions do we have to check here right now? 3. So how do we check these 3 conditions? Right, we write the nested if. So before I go ahead and write the nested if here, maybe there are few newcomers out there. I will go ahead and explain it here, and then I will go ahead and type it out, right? Because if I type it out directly, it might look a little bit complicated. So we will first start with if everyone, right? Inside the if here, we have to give a condition. What is the first condition here? Precedent, right? So we can go ahead and say that if the job title here is equals to precedent here, if it is equals to precedent here, and if this is true, If you find that in that row, president is written there, and if it is true here, what we want in the output? Top management. Correct? But what if this is false, everyone? What if this is false? Then what do we do now? What if job title is not president? What we do then? Then we ask SQL here to check for another condition. Right, we ask you to check another condition. So if we wanted to check another condition here, what is the next condition? In the job title, somewhere manager has to be written. How do we find this kind of condition, everyone? We will check one more condition here. So how do I go ahead and write this condition that somewhere manager should be there in their job title? How do we write that? Wildcards, absolutely right. So we can go ahead and say that job title might be like anywhere manager has to be written. Anywhere manager has to be written. So here when we are asking you to go ahead and check for another condition, okay, we have to go ahead and after this value if true, when it will assess value if false, we will have to go ahead and type if again. Since we are typing if again here and we are asking go ahead and check if job title is like manager, if this is the second condition we are giving here, again we have two options. Either this is going to be true or this is going to be false. If this is going to be true here, what is the output? Management. We want them to write management here. If this is also false, so the first condition we have given, that is false. That's why we are checking second condition. If second condition is also false, what happens? What do we do now? Next, here, staff. We'll simply go ahead and say that whatever is left now, you go ahead and tell them it's a staff. That's it. And now here we close our if that we have written the second time. We have also closed the if that we have written the first time. So we have to take care of parentheses here. Okay. So if this is the parenthesis, we are closing for this. And this parenthesis of if, we are closing it for here. So this is nested if. If you have more conditions, keep on writing more conditions there. And keep on writing if every time we check a new condition. So go ahead and see, let's go ahead and see here, how do we write the nested if here? So we follow the syntax here. So we are typing here if. Inside if here, we are asking you to go and check, is this job title is equals to president? Remember that it is not case sensitive. If it is president, what we want in the output, we want it to write top management right there. We're asking to go ahead and type top management. Till here, everything is fine. Now comes the catch here because we type a comma again and we type if again and we ask it here that now go and check another condition. What's the another condition? That go and check job title again. But this time the job title should go ahead and find out manager. Now that manager can be written anywhere. I have no idea. So that manager can be written anywhere inside the entire phrase. If job title is like manager there, we type a comma again and we want to type management in the output. Now, if it is not the top management, not the management, it is simple stuff. We go ahead and type a stuff, right? Now we close the bracket here, first bracket and the second bracket right there. And I'm going to call this as management category. And here we are. Okay. So right now I'm going to beautify this so that I can show you properly. See if, and if. Likewise, you can keep on writing multiple conditions right here. One thing that you have understood here is while typing nested if, we have to remember by ourselves what to type where. We are not getting any help for the syntax like we would get in Excel, right? We can, when we write something, Excel actually guides us with the syntax. SQL doesn't do that. Since SQL is not doing that for us here, the best way to work with this multiple conditions is case and when. And we will go ahead and see how do we use case and when statement to apply multiple conditions. Great. So if there are multiple conditions, writing nested if is going to take a lot of time and a lot of attention right there. Effort. Instead of that, we use case and when statement. So let's see, for understand case and when here, this is how case and when looks like. The syntax here, everyone. It simply says that here, okay, the case statement starts with case. And then we write when, so whatever we are working in, inside that, when condition 1 is there, if condition 1 matches, then give the output 1. If condition 2 matches, then the output 2. and else here. It's quite easy to follow too. So let's go ahead and get this from here. So we will go ahead and use the same customers table again. We assign the customer categories based on the credit limit, but this time we'll go in detail. We give them the credit cards here. We are giving them gold credit cards eligibility if they are above 75K. We're giving them silver category here if they are between 75 and 50K. And if they are below 50K here, okay, we are giving them bronze. Right? We are giving them bronze right there if they are below 50K. So let's go ahead and see how do we write that here? So one thing is similar. Okay, we know that we are working from customers table. I will get this out of the way. And now we go ahead and we type select. In select here, we can ask you to get customer number, customer name, and now we go ahead and write case and when. So here we are writing that case. See, it's a keyword right there. And now we will go ahead and type when. Now, what is when? When here we will define what we are looking for. The first condition that we are looking for, the credit limit should be greater than 75K. Okay, greater than 75K. If it is greater than 75K, then we want to give them the gold credit card. They're eligible for that. After this here, we go ahead and we type when. When again credit limit here. The credit limit is between here, is between. How do we go ahead and type between here? If credit limit is between 75K and 50K here, and 50K here, then we are giving them silver. Right here. Else, meaning if none of these two are true here, we can go ahead and type else. Else, if none of these are here, go ahead and give them bronze. If none of these conditions matches, go ahead and give them bronze. Here everything is done, right? But since case and when we will go till infinity like this, we have to go ahead and tell SQL that see this is a statement and this statement ends here. So we will go ahead and type end. Just to tell SQL, let's see this ends here. And after ending it, we have to go ahead and give this a name because this entire thing cannot go inside the name here. So here we are writing here that right, this is their credit card eligibility right there from the customers table, right? So this is how we are writing case and when. I was writing that in one single line. Okay, and this is how it looks like after reformat everyone. Okay. So with simple practice exercise, everyone, we want to find out and check whether the customer has a sales representative assigned or not. Remember, we had multiple null values when we checked it right now with the group by. So we want to find out assigned or not. First thing is simple. We are working in the customers table. Okay, that is fine. We are also aware that in the select here, we simply want to see whether the customer has been assigned a sales representative or not. So this is what I'm getting here. Of course, I'm going to write this as sales rep since it's too long name here. Now, please tell me, how do we check whether the person has been assigned or not? Let's see. To find this out here, we'll simply go ahead and use if function here. How do we decide that? First, tell me how many conditions do we need to check? Let's understand here. We have just one condition. What is the one condition? One condition here is if customer has a sales representative. If customer has a sales representative here, there are two outputs where we can say yes or no. So we have to check one condition and we get the two outputs there. So this is how we work here. Now here we will, if I have one condition and two outputs, we use if function right here. So inside if here, we will, what do we ask? How do we ask this? We'll simply ask it here that go ahead and check if this sales representative is null. That's it. Because we are automatically getting the customer number and name there and sales rep. We'll ask it if sales representative is null, go ahead and type not assigned. Otherwise, type assigned because if there is a number there, it is assigned. And let me call this as a status. See, wherever there is a null value, it says not assigned. So let me beautify this right here. Oh, this looks much better. There are other ways to type it too. I'm not saying this is the only way. Okay. Have you observed one thing here? Even when we are learning about group by, we are learning about the statements out there. We need to go ahead. We are still working every time on one single table. Every time we are working on one single table, right? What if we have to go ahead and find out, for example, we are working right now here, okay? We have got customers table and all the tables out here. What if I want to find out that which sales rep has given us the maximum sales? So, because in the customers table, we don't have any sales data, but we do have sales rep data here. In employees, we can find the name of the employees too. In the employees table, we can find name of the employees here. But from where do we get the sales data, everyone? How do we get the sales data? That how much sales have been made? Total amount the customer has paid that has been assigned to them. Which table do we need for that? Where we can find out which customer has paid how much and when, or how many number of orders that person has placed under that sales representatives. So we have got orders table here, right? After orders table, we have got payments table here, that how much that particular customer has paid for that. Okay. So right now we have orders, payment date, customer number. So if I want a very simple answer, now this is a very simple and direct question. If someone will ask that, I want to see that how our sales representatives have performed and how much sales their customers have done so far. It seems like a very good direct question here, but the problem is now we are not working on one single table. You want to go ahead and work with multiple tables together. Now, how do we do that here? Because in the from here, we don't want to use one table. We want to go ahead and work with multiple tables right there. So when you go ahead and want to work with multiple tables here, this is where joins will come in. This is where the concept of joins will come. Now, what is joins here? Join here is very simple. Okay, it goes ahead. It merges the two tables there. And remember, it merges two tables only at once. It can merge only two tables together. Okay. So it merges the two tables there. And in the output, it will give us one big single table. It will give us one big single table. That is joins. That is joins. Okay. How many types of joins are there in MySQL? We have very basic 4 joins here. Okay, very basic 3 joins here first. It is left join, right join, and inner join. These are the 3 joins that are present in MySQL. There is one very specific join for MySQL, and that is called as cross join. So when I say that this is present in MySQL here, so now when we say that these are the joins present in MySQL, I mean that the keywords are present. I mean that the keywords are present. Direct keywords are there. If I say left join, it will do the left join. If I say right, it will do the right join, and so on. However, in general, when we talk about data models there out there and database out there, we have some other joins too. For example, full outer join. So there is something called as full outer join here. But this full outer join is not present in MySQL as a keyword there. So we have to go ahead and use a permutation combination of other keywords to make a full outer join, right? So full outer join is not present directly as a keyword in MySQL. It is present in MSQL. It does present in MySQL, Oracle, and others. Other type of join here that we can perform within MySQL and anywhere else also is self join. And if you want to go ahead and do a full order join inside MySQL there, we go ahead and we use union for it. So you will understand about this union keyword too. First, let's go ahead and understand about joins there. Now, how many of you are looking at joins for the first time? We'll go ahead and look at the simple concept here first. So let's go ahead and understand what joins are. I'm going to reshare my screen here. You should be looking at an Excel sheet. Okay. Now, when we talk about the common when we talk about merging the two tables here, okay, we cannot merge unless we don't have a reference column. All right, we cannot merge two tables unless we don't have a reference column. So before we move forward, let's understand what is meant by merging of two tables here. Okay, let's talk about that. As you can see here, just focus on what I'm trying to show you here. Do you see we have got two tables, everyone? We have got order ID and customer ID right here. Yes, we have two tables here. Now, in this order ID right now, we know that these are the orders here. These are the orders placed for these products, and this much they have paid so far. Of course, we want to go ahead and analyze it there. But here, when we have observed that the customer name is right there, customer name is here, and maybe more customer details are there, contact number, address, phone number, and all that. More details of customers are here. So why to keep two tables here? Okay, if I want to figure out that who has placed the highest order here, I would like to know the name. So we want this customer number to be fetched right here. Okay, so we want the customer number from the table number 2, which is placed on the right hand side of the sheet here. We want to fetch the customer name right here. If I want to do this here, if I want to go ahead and do this here, can we simply go ahead and copy and paste it right here like this? Is it correct? Can I simply go ahead and copy and paste it right here? Because I want to merge two tables here. Is it right? Why not? Why it's not right? What do we need to do then? Customer IDs are wrong. Yes. Right. We cannot simply go ahead and copy and paste, right? We cannot just simply go ahead and copy and paste. We have to go ahead and match the individual customer ID too, meaning we need to have a common column. What is the, which one is the common column we have here, everyone? What is the common column we have here? Customer ID. Customer ID is a common column. So if this is a common column here, how do we work with it? We'll go ahead and read if this is CR1. Yes. Now we will move from here to here and we'll check, okay, do we have a CR1? Yes, we have. What's its name here? John. So we will go ahead and copy and paste, right? We copy and paste it right here. Now we check again. Okay, this is again CR1. Now we will check again. This is John here. We'll go ahead and paste it again. If this is CR2, we'll go ahead and find CR2 here. Okay, this is Peter. This is CR3. This is here. This is CR4 here. And we get it there. This is CR3, CR4 here. We are matching them right here. Now, do we have CR6 here? Do we have a name of CR6 here? So what do we do here if we don't have a CR6? So we go ahead and keep it null. We can write null here. It's null. There's nothing there. Do we have a merge table right now? Do we understand what we did? We simply matched it everything and we kept it null. What about others? Those who are looking at after a very long time or for the first time. Do we understand what we did just right now? We merged the two tables together based on a common column. Yes. Now, observe one thing here. We when we were fetching everything here, did we even cared about this? CR5. Currently, we have currently in the merge table here. Do we have CR5 in the merge table? No. It means we compromise this data set. For this current analysis, do we need the name of this person here? Why don't we need the name of this person right now? Because this person has not done any sales yet. No need of that because this person has not done any sales here. So if there is no sales here, we don't need their name too. Exactly, because it is not part of the sales table yet. This kind of merge right now. So what we have done here, we have made sure that all the rows from the left-hand side table are intact. All the rows from the orders table are intact. We are not compromising any data here because this is our main table. Okay. So we are keeping all the data and rows intact here and we are only fetching the matching data from the table number 2. This kind of match is called as left join. This kind of merge is called as left join, where we'll make sure that we are keeping all the rows from the left table and we have only matching values from the right side table there. This is called as left join. Do we understand left join right now? Yes. Now, can you please tell me if this is left join, what will be the right join? The opposite is going to be, in the opposite right join here, we'll keep all the rows from the right side table here. Okay, and we keep only matching values right here from the left side table right now, right here. In this particular scenario, right join is not a good choice. And 95% of the times you will be using the left join. And there are very rare cases where you will do the right join. Very rare cases out there. Okay, that is right join here. Now, what is inner join? If this is left and right here, what is inner join here? Inner join is it will keep only matching values from both the tables here. Meaning we will not fetch CR5, neither CR6. Why? Because CR5 doesn't have a name, CR6 doesn't have a name here, And this CR5 has not done any sales here, has not given us any sales here. So in the inner join here, we will not be fetching anything which is not common. So we keep only common rows here. Okay, so this is inner join. So this is inner join, everyone, right? If this is inner join here, is it the right choice for now? Is this the right choice for in this scenario? Yes. Is inner join a better choice? Let me show you here. Okay, when we do go ahead and do the inner join here, what happens? We have not even compromised one, we have compromised two details here. First is this person has given us the most sales. We didn't had any name of this person here, but this person has given us the most sales there. We have compromised our data set because of the inner join. Okay, it is just like the inner join. So here in the inner join here, we are compromising a major detail. Most of the time in the real time, we will stick with the left join here. Why? Because in the inner join, most of the time we will be compromising our data set just because of few values or few details are not available. So it doesn't matter if I have the name of the customer or not there, but if I have the customer ID, I can figure it out later, right? So that's what inner join is. What is inner join? And when this inner join is like intersection in Venn diagram, yes, it will look like that, intersection. Yes. So this is inner join, right? So now we have made sure that we have everything from the left side. We have made sure everything from the right side. In the inner join, we have the common table right there, but it compromises the values. Of course, we do not have null values, but it compromises the data set, right? What is the full outer join? What is left? Which permutation combination is left, right? So what happens here is full outer join, what is left? We'll keep each and every row from both the table. It will going to give us too many null values and too many details which are not required. So most of the time full outer join is also avoided at all cost. So the types of joins that we have seen so far. So in MySQL, we have understood that there are basic joins are there like left outer join, right outer join, inner join, and full outer join. Other than these four basic joins, what we have seen, other than these joins here, and of course self join is also written here, what other join we have heard about? We are also clear that inner join, left join, and right join, these are the three keywords that are present in MySQL. Full outer join is not a keyword that is present. Neither the self join is a keyword that is present. These both are the concept these both are the concept of merging the table together. However, full join is achieved, full outer join is achieved with union operator, and self join is achieved with inner join. So we will go ahead and of course it's a second one here, last one here is the cross join. So yes, cross join is a keyword that is present with us within these MySQL here. And this will differ with each platform. So here left, right join and full outer join that is present in MySQL and Oracle and other places, but not in here. So let's go through the concept here. I will go through the concept here quickly because we will go ahead and do the hands-on practice. That will be much better than that. So what is inner join here? Inner join is the one where we will get only the matching values. Only the matching values will be given in the output. That is the inner join. What is the left join here? Left join will make sure that we have all the data from the table number 1 and we are getting only matching data from table number 2. What is right join here? In the right join here, we are getting all the data from the right hand side here and all the data that is matching from the table number 1. What is the full outer join? Full outer join doesn't care. It will simply go ahead and grab all the rows present in both the tables. So these are the four basic joins, everyone. Now we'll go ahead and we'll see the hands-on practice. So we are at the workbench, everyone. And today we will see in detail. And remember that while we are learning about joins here, right, we'll go ahead and create our own small table so that we are able to understand how to type join better. So with the joins here, we will also learn about DDL, that is data definition language. Okay. So we are going to talk about data definition language here. We are going to create a database. Inside database, we are going to create tables, and inside the tables, we'll go ahead and use DML and we will insert rows of data inside it. Okay. So first we start here, we start small and then we go ahead and join them together. Let's first go ahead and create database, right? We create these schemas here and understand joins, how to write them and the variations of it, okay? So first here, I would like all of you to just view things here because I'm going to show you something and how to create the table right now. So in here, I'm going to say that I want to go ahead and create a database. I'm going to name the database as DB joins because we're going to learn about joins. So this is database we're using for the purpose of joins here. I am not executing it right now. Inside this DB joins here, I will make sure that from now on, we will be using DB joins as default. After this here, we will say that I want to create a table. Where do we want to create a table here? We want to create a table in DB joins and dot. So when we talk about creating a table here, basically we go ahead and we prepare the structure of a table. To create a table here, we go ahead and we create the structure of a table. What comes inside the structure of a table? When you type a create table here, first thing that we do is we go ahead and we give it a database name and then the table name. Then go ahead inside this database and create a table with this particular name. And inside that table, we want you to go ahead and create column number 1, which should have a data type like this: number, a string, and date. We have var, char, float, decimal, double, the small integer, big integer, date and time. All those are data types. So we'll go ahead and assign the name to each column here, and we assign the data type too. And like this, we will keep on going and giving the column names and everything else here. So what we do here is we go ahead and we prepare the structure of the entire table just by writing this here. Remember that we are only creating the structure of a table. Yes, we're only creating the structure of a table. It is still empty. So we'll go ahead and create a table here, everyone. So I'm writing create table. This is the database name. Let's create a simple table here for employee info, which we can all relate with. So we're creating a table called as employee info here. Of course, the first column we can think about is employee ID here. And let's keep the character 4 here. That employee ID will be of 4 characters. We are keeping it easier. After employee ID, we can have the employee name there. Employee name can be of variable characters. Every employee name is going to be different. So we can say maybe employee name can go to 50. And then their skill set, what they're working with. So we will go ahead and keep that as varchar again. And this is 52 because these are the skills that we are talking about. They are also going to vary it. And then we have their experience. Experiences can be in years. So we are keeping it integer for this purpose here. So this is a small table, a structure that we are creating right there. Now see here, we have created a database, we have created a table, but I'm not going to execute any of it right now. After creating the table here, we are inserting the values. Now, how do we insert the values here? To insert the values inside a database here, we again go with the same structure. We say that, see, I want you to go ahead and insert the database, insert the values into the employee info table, where the employee info table is. Employee info table here is in certain database in a certain table. And what we want to enter here, we want to go ahead and enter the values. After entering the values here, now we will go ahead and actually write individual row there. So for example, whatever column number 1 data is there, we'll go ahead and type that column number 1 data for row 1. Then we have again a column 2, row 2 data. So for example, here we have a skill set. Third is the skill set. So we'll be typing the skills here. Fourth is the experience. We're typing the experience in years. We type a comma. This is just first row. Then we go ahead and we add a second row. So maybe this is the employee ID there. And here we go. This is some name there. And then now we have got a skills there. We give these skills there. And here we have some experience. Like this, we'll keep on moving and writing individual rows. We'll keep on moving and typing individual rows right there. This is how we insert the values of row by row. So if we have 4 columns there, we will be typing 4 values. So here we go ahead and type insert and into where? Into DB joins employee info right here. Into DB joins employee info right here. Now inside this here, we want to go ahead and add up the values. And how does the values look like? So here we go. We can say here that this is A123 here. That's the employee ID we are giving with 4 characters. Since all of this is either alphanumeric or it is right now pure numerical here or alphanumeric or the alphabets here, we have to type it within the quotes there. If these are in numbers, the numbers will go right away. So if there is a number, all right, number will be written without the quotes because it's a number, it can be read as a number. Now, like this, we'll go ahead and type each and every row here. So if it is A1 to 3 here, so maybe it is A1 to 4 here, and more names and SQL follows. So I'm not going to type all the rows here. It is going to take a lot of time to type each of that. So I have pre-written rows of data here, and we are here. Done till here. So now what we have done, we have went through, we have created a database. We went ahead and we created a table right there, and we inserted the values too. Now, how do we go ahead and execute this one? Now, listen to me very, very carefully, everyone. I want everybody's attention here, please. I'm going to go ahead and select all the three statements together. These are three different statements, right? See the semicolon here, right? All three are separate statements. I'm going to select them all together. And we are going to go ahead and click on the first lightning bolt right here. Why first lightning bolt here? Because this means execute all. This means execute all the selected rows. So we'll go ahead and click on execute all right there. So it will go ahead and execute them one by one, and it will be executed right here. So I'm going to click on here. Look at the output, everyone. Now, once it is executed, of course, nothing will be shown in the scheme. So we have to go ahead and refresh it. Once we refresh it, we see it. See? And inside this DB joins here, you'll find the tables. And inside tables, you'll have the columns. Found it? I'm going to go ahead and provide you this right now. Go ahead and execute all with the first lightning bolt. Here is the link. Remember, select all the three statements. Great. Now let's go ahead and create another table. Okay, another table will be created exactly similar to this. We'll go ahead and type create table because we need two tables to join everyone. We'll go ahead and type create table again, and again we are going to create table for DB joins here, and let's name it employee salary. So we'll have the employee salary details here, and I'm going to call this as column number 1 as employee ID because that's what we need here. It is going to be exactly similar to here because data type has to be similar. It is the exact same column. Exact same column name here. Now here we need designation there. This is designation. It can be varchar. It is the name of the designation there. Let's give the maximum 25 here, meaning maximum 25 characters can be inside this particular designation name. And we have salary details. So we'll go ahead and keep the salary details under float. Float is decimal. Okay, remember that here. So that's float. And here we have created a table. Now inside this table, let's go ahead and insert the values here. So let's insert some values here. So we want to insert the values inside the DB joins employee salary. This is the table here. And we want to go ahead and set some values here. Remember, 3 columns, 3 values, everyone. So first is employee ID. So let's say the employee ID is 1, 2, 3 here. And let's say their designation is L1, for example. And then what we have salary. So I'm writing some random numbers here and salary right here. So again, let's go ahead and type A126 here. And maybe table will 2. And again, a random number here for the salary part. Here we go. This is another employee number here. Let's say they also belong to L2 here. And again, a random number here for the salary part. Let's add one more row right now. So there are too many rows here. Okay, so here we go. I'm adding one more part here. And this person belongs to L3. So these are different designations right now here. And let's have again a random number right here. And that's it. So these are the 4 rows we are adding up. Okay. So these are the 4 rows. Let's go ahead and create another table. How do we create another table, everyone? We will go ahead, we select everything. We'll go ahead and we select everything right here. Okay. And we execute all together. Once I execute all together, only once we refresh the table here, we get to see the employee salary right here. Okay. So how do we go ahead and write join, everyone? So to write join here, we again have a syntax, the way to type it. How do we type joins here? We start with select as usual, right? But we want to go ahead and get data from two tables right there. So first thing that we are going to do here is I'm going to show you how the tables look like. So this is the employee info table, everyone. This employee info table has how many rows? 5 rows right here, right? So this is our 5 rows from the employee joins table. Let's look at the employee salary here. It has got 4 rows. It has got 4 rows right here. So this is our second employee salary table right there. Now what we want here, we want to go ahead and see how to type a join. We will go ahead and we want to go ahead and merge both the tables together. If we want to move forward and see how to join the tables together, this is how we type it. First, we start with select. We start with select. And in front of select right now, we'll say, I want all the columns from the merge table. We have no choice for now about the columns because you have no idea which columns are there going to come when we merge it together. After here, we go ahead and type from. Where do we type the joins here? Inside the from, because to the from keyword will inform that, okay, this is where you have to go and get the data set. Now in the from here, we need data from two tables here. So we'll say that go to the employee info there. Now where the employee info is in the DB join. So you'll say go to DB joins and go to the employee info and then join it with the second table. So what type of join we are looking at? So let's say we are first looking at here the left join. We are first looking at the left join. So we type the keyword here, left join. Now which one is the second table? Second table here is again that go to DB joins and employee salary. This is our second table right here. Is this enough information? Now we have to go ahead and also define which one is the common column. So we go ahead and we type it here using. Using is a keyword which will inform which one is the common column. Which one is the common column between the two tables right now? Employee ID. So we go ahead and we get employee ID. Yes, thank you. So we go ahead and type employee ID here and then we close the statement right there. Now, why are we writing employee ID here? Why we are able to write the employee ID here? Okay, for a very simple reason that we are simply informing right now SQL that, see, I want you to merge these two tables together by using the employee ID column. And that employee ID column, we are mentioning it only once. Why? Because the spelling of common column is similar. It's exactly same. Common column is exactly same in both the tables. And this is not true in real time. In real time, this doesn't happen. We do not have the exact same name. For now, we have it. So we are going to go ahead and execute it right here with simple bolt or control enter. And look at the left join, everyone. Do you see the left join right now? How many rows do we have here in the left join? 5. Why 5 rows? Because employee info is my left table and this contains 5 rows. So here we will also have the 5 rows. And look at the right side table here. We have null values. Only the common rows here, are having the values written properly till the end. However, you must be wondering that why we are typing DB joins multiple times here. Okay, if you will go ahead and you make sure that you are making sure that DB joins is a default, then we don't have to type that. We can then type directly. So if I want to go ahead and type directly here, we again go ahead and start with select here and we type asterisk signs and we'll say that from where? Now we can go ahead and type directly that, okay, go to employee info. And this time, let me type right join here, right join it with what? We have employee salary right here. But now this time, instead of typing using here, we have one more option. If the names are not exactly same, okay, what if it is employee ID and maybe employee ID space is there? If there is any kind of discrepancy or the change, maybe it is writing employee number and another table it is writing employee ID, right? It's still they're both same, but the names are different. In that case here, we use another keyword on. In this on here, we can now define that go to employee info. Inside employee info, you're going to find a column called as employee ID, which is exactly equals to the employee salary table, which has a column called as employee ID. So we will use on here, right? So preferable method is always on. Why? Because we have no idea that whether it is always going to be same or not. Okay, so preferred method of defining a common column is on. So if I go ahead and type it like this is also absolutely correct. And when we execute this, look at the right join. The output is 4 rows because the right side table has 4 rows here. And see, we have got the entire employee from the different side here. We have got only 2 matching rows right here. All right. So this is how we can go ahead and type left and right join. You can see the difference. We have to simply go ahead, instead of left join, we are simply typing right here. Let me go ahead and beautify both of them here just to show you how it is going to look like. And right here. Okay. Go ahead and find out left and right join. This is how we type join. Take your time and see both the joins right here, one by one. First, we are typing the keyword using to define the common column, and then we are typing on. Great. So see right now, okay, we have seen left join and the right join. Easy way to type it out here. Now here, after this right join here, let's go ahead with the inner join. Let's go ahead with the inner join. Now there is one more way to type. So before I go ahead and show you here, let's see. Again, we go ahead with select. We say everything here and from. In the from here, we want to do the inner join here. So if I go ahead and get the employee info here, and we want to do the inner join, so we type inner join here, with our employee salary. Now here, I'm going to show you three possibilities here. If I go ahead and type using, because we have the exact same column name here, okay, this is the inner join output that we see right here. We have employee ID, name, skill set, experience. And from the second table, we are only getting designation and salary right here. Okay. What is the other way here? Other way here is this will remain exactly similar. And now we go ahead and we type on. Now in the on here, the again one major problem is we have to go ahead and type the entire thing, right? Employee info equals to employee ID, employee salary dot employee ID. So we are going ahead and typing this multiple times, the table name. So what we can do when we don't want to type table name multiple times here, we go ahead and we give alias to table name. We go ahead and provide alias here to table names. We'll simply say that, see, this is employee info table, right? I'm going to call this as T1 from now on, and I'm going to call it employee salary as T2. So when I go ahead and type on here, I can write T1 dot. And from T1, that is, we are saying employee info here, get the employee ID, which is going to be equals to the table to employee ID. Okay. And now, if I go ahead here and execute this right there, I'll get this answer right there. So when I type on here, observe that I have the exact same output. There is only one difference. Can anyone notice that difference here? Aliases here are simply making our job easier to define on and the common columns. It has got no job from the output. So I would like you to go ahead and see the inner join right now. Go ahead and see the inner join here. Okay, and tell me the difference between the two outputs. Same inner join output, but go ahead and tell me the difference. At first, we are typing using to define the common column, and second, we are using on here to define the common column. Go ahead and get it. Go ahead, solve this and tell me, do you see any difference between the output of using and output of on? Do you see any difference between these two? And look at the output when we are executing with the using here. Since using assume that both the tables here have one single column name here, it will keep employee ID only once. It will keep employee ID only once. However, in real time, that's not the case here. So when we are going ahead and executing here with on right now, okay, we will go ahead and see that employee ID here is added twice, one from the table number one from the table number 2, even though they have the exact same data set inside it. Okay, but since we are typing on here with the pre-assumption that the both names are different, these will be added twice. That is the difference here. The preferred is on because in real-time practices, That's what we use. And it's just easier to keep track. So this is how we type the alias. And this is how we use, this is what the difference between using and on. And yes, this is how we type alias and we use alias right here. It is easier to go ahead and define the two separate, it is easy to define the common columns with the help of the alias right here. So let me show you one more thing here. What is inner join, everyone? Have you observed something here? In the inner join right now, please pay attention here. In the inner join here, one very distinct option is here that the employee ID that are present in the first table that are going to be exactly equals to the employee ID present in the second table. Correct? This is what inner join is. Out of these two here, this values in the employee ID 1 should be exactly equals to employee ID present in the second table. That's what inner join is. Because of this unique quality here, we can actually type the inner join without the keyword inner join. And how do we do that? How we can write, we can create an inner join merge table without the keyword inner join here. We'll go ahead and type the where clause. We'll go ahead and type the where clause. We use the where clause there. So let me show you how to type it there. So this will exactly remain similar. Let's write everything from employee info, and after that we type comma here and we say employee salary. So we need the data from both of these tables there. Now we go ahead and type the where clause and we'll say that where the table 1 employee ID is exactly equals to table 2 employee ID. So without even typing here, without even typing the inner join, okay, just by typing the comma here, we will still get the output of inner join. See, exact same output. So most of the time, whenever you will see inner join written there, it will be written here, not with the keyword here, but they will be using the where clause here. Why? Because this where clause will act as a simple filter and it will be quite more quicker in a larger table as opposed to inner join right here. So whenever we are typing inner join, most of the time professionally, they will be using the where clause to define inner join. And remember that this can be done only with the inner join and not with the left and right. For left and right, we have to type the keywords. Write down, what do you mean can we write from T1, T2? These are aliases, right? So in this line, we are actually defining that these are aliases so that we can use them afterwards here. So this was very simple, left, right, and inner join, everyone. Okay, let's go ahead and learn about full outer join here. About full outer join, as I've already told you, there is no keyword for this. All right, so what we do here is we go ahead and use an operator. Which operator do we use here? We use the operator union. We use the operator union. What does this operator do? This operator will go ahead and copy paste the table one below the other. So basically this action is called as append action. What is append action here? It is simply going to go ahead and copy two tables one below the other. Let me give you an example here. Let's say every month you have been given the monthly sales data to you, okay, for the analysis purposes. So once you get the data for 1 month, let's say you got it for January, then you got it for February, then for March. Now they're asking at the end of the quarter, they're asking that, okay, now can you give me the quarter-wise analysis? So in this case here, you have got three separate tables. So how will you go ahead and join all the three tables together? They have exact same table structure. You're getting that data every month consistently. What you will do in that case? So if these are the three data set here and you're getting it one for January, one for February here, how do you go ahead and keep them together in one single page? So if these are three Excel sheets, for example, if these are three Excel sheets you have, one for January, February, and March, and now they are asking you that, no, go ahead and give them the analysis by combining all the three files here. How will you combine them as one? Yes, how do we merge it? We merge it like this, one below the other. So basically, we are copying, pasting them one below the other, making sure that we have exact same structure of the table. Okay, so this here, this here is called as append action. This append action we can do here with the keyword union, right? So as we have the keyword union here, we have one more operator called as union on. So we have got two operators. One is union, one is union on. What is union here? Union here, when it goes ahead and copy paste two tables together here, it will make sure that there are no duplicates here. It will remove the duplicate rows. It will remove the duplicate rows if there are any after merge. What will union all will do? Union all will make sure that all the rows are still there. Okay. So how do we create the full outer join? With the help of union here, because we don't want the duplicate rows there. So basically, what is full outer join? What was the definition of full outer join? We simply wanted to go ahead and get all the rows from both the tables, right? If we want all the rows from both the tables here, meaning we have to go ahead and combine the left join and right join. So whatever is the output from the left join will go ahead and we append it with the output of the right join. So let's see how do we do it. How do we do that? So this is our right join here, right? So I'm keeping it right there. This is our right join. And I will convert this into left join. So if it is left join, this is how we see the output. Employee ID, name, skill set. And see, we have got a lot of null values here. Now, if we have the right join here, look at this right join output. This one. When we go with the right join output here, we on the left hand side, we have got the null values. So we'll simply keep them one below the other. To keep them one below the other, first thing we do is we get rid of the first semicolon here because now this entire thing has to be one single statement. And we go ahead and write here first union. I'm going to go ahead and type union first here. So if I go ahead and type union, this entire thing will become one single statement and look at the output. If you look at the output here, this is the output from left join. This is the output from the right join. This output is from the right join and the upper one is from the left join. And it is simply written one below the other. And now we have the proper entire full outer join in front of us. That's why union is written. We have 7 rows in the output, okay? But now if I go ahead and type union all, which will keep the duplicates here. If you go ahead and type union all here, means keep it, meaning keep all the rows there. The output has 9 rows here. Why does output has 9 rows here? Reason is when we are doing right join and left join, we have 2 common rows, remember? Those 2 common rows are repeating here. So see here, 1, 2, 3 is a common row. 1, 2, 6 is a common row. It is repeating here. It is repeating here from the right side. So union is actually taking care of this repetition. Union all is not able to take care of this repetition. That is why in full outer join, we will take care of union. And if we are merging or appending data from multiple timelines or time periods, we'll use union. Okay. Go ahead and observe the difference between the two. And this is how we go ahead and write the full outer join. So we want to go ahead and see the customer numbers and name of all customers. What we want to see? We want to go ahead and see customer numbers and name of all customers along with their order IDs, along with all the orders they have placed so far in the year 2005. In the year 2005. A very simple question, right? A very simple question here that we want to see the customer numbers and their details along with their order IDs, meaning they should have placed the orders in the year 2005. So first, let's break it down. Okay, let's break it down here. Please tell me, first let's figure out from here. So please tell me which tables do we use from classic models to get these details. So customers table can give us customer number. And orders table here can give us the order details. The order numbers are here. That's orders here. Now, which one is the common column between the two? What is the common column? Which one is the common column between the two? Which ID? Order ID or customer ID? So which one is the common column between the two? With both of them in between, there is a customer number or customer ID right there. Now here, which type of join we should do here? Which type of join we should do here? Left, right, or inner? How do we decide that? We decide that in line with the objective. That we are right now looking for customer numbers or customer details of those customers who have actually given the order so far. in a particular year. So which rows are we talking about? Are we talking about all the customers and only and fetch only their order, only the matching customers order IDs? Or are we looking for the common rows out there? That if the customer has placed the order, then only we need the detail, or we need all the customer has to be there. And if the order is placed, we'll get only the related orders. What are we looking for? Because in a customers table, we have all the customers that are currently registered with us. But have they given order in 2005? Is there a guarantee? So do we want all the customers to be present in the output? So in this scenario here, we can go ahead with inner join. Why inner join? Because I want the customers who have placed the order so far. Maybe some customers registered with us, but they haven't placed any order yet. And if I do the left join, they will still be there. All right. So that is why we'll go ahead with inner join here, because we want only the customers who have placed the order so far. So you go with the inner join. Till here we are good, right? So let's go ahead and start typing here. So I'm typing here select. As usual, first I'm typing everything for now. Let's figure out from first, and we'll go back to that later. Now in the from here, I'm getting customers table. I'm going to name that as C. We are going to inner join it. We are going to inner join it, and we will inner join it with the orders table right here. And we are going to name orders here as O. Even if I don't write AS there and write directly CNO, it will still get it. But I will still type it here just for the clarification. Now, when we type on here, we can use this aliases right there. We can say that go to the customers here, right? That is, we are typing as C. Get the customer number here, which is going to be exactly equals to what you are going to see in the orders table, customer number right here. Now, we don't want the entire table. Do we want the entire table connected like this here? No. We just want a few select columns from here. Okay. Now, I would like you to pay attention on few things here. First here is, do you see we have a customer number here? This is the merge table, everyone, right? Do you see this is the customer details right there? When I am scrolling towards right here, towards right, after credit limit, we have started with the order number. This is the orders table now. If I move more towards right, the last column is also customer number. Yes, meaning in the output here, we have got two columns with exact name, that is customer number. Done? Do we understand this part? Yes or no? That yes, we have got two separate columns and they both are named exactly similar customer number. And they both are coming from two different tables. Now, so this is why when we ask you that, see, I don't want all the columns here, you go to the customers table, there, and from the customer table, you get me the customer number, comma. Now here we need customer name, right? But customer name is not ambiguous. It is the exact one single name here. We can type it directly that, okay, get me customer name, comma. What we want next here, we need order ID. So order ID is also singular. It appears only once. So this is order number right there. After this here, they're asking us for the year 2005, right? So let's go ahead and get order date. That's what they're looking for, order date right here. So we need only 4 columns. Since it was the common column here, we have to define from which table do you want this. Otherwise, it will give us the error. Now, once we have this here, all right, are all dates are from 2005? Are all dates are from 2005 here? No. So how do we go ahead and filter out 2005 then? How do we apply the filter? Select from where? We apply the filter with the where clause, everyone. So select from and where. Now inside where, what is the filter? That the year should be 2005. Do we have a year column here? No, we don't have a year column separately, but we can go ahead and extract the year as we have done before from the order date. Yes, absolutely correct. And we can say whatever year you extract from the order date here, it should be equal to 2005. And now when we execute this right here, we get this. Now dates are already from 2005. Okay, I'm going to beautify this right now. so that it looks cleaner and visible. Go ahead and check this out, please. Remember that whatever problem you have with you have to simply go ahead and break it down. Remember that we do have keywords, right? We have keyword called as cross join and natural join too. So we have got these keywords there, and then there is a self join. This is only a concept. First, let's talk about the keyword cross join here. What is a cross join, everyone? Cross join has no common column considerations. It is a simple Cartesian product. It is a simple Cartesian product. Those who are from the mathematics background, they might remember this. All right. Those who are not, they're like me. Don't worry about it at all. Let's understand what Cartesian product is. So for example here, okay, here are few numbers. Okay, this is our column number 1. And this here is the column number 2. So here we have got few now more numbers right here. So let me write some different numbers here. Okay. So these are the 2 columns that we have here. This is first column here, and this is second column. Now, what we are looking for here, we are saying that we are trying to understand Cartesian join here. What is a Cartesian join here? That in the output here, I want to merge these tables together. However, since there is no concept of common column here, what it does is this one will get merged with 4, with 5, and 6. So if I'm going ahead and typing 1 here in the output, in front of the 1 here, all the 3 words will be typed, and this one will be repeated. This is going to be the output, that is Cartesian product. Then we have got 2 here, right? So this 2 here will get multiplied to all these 3 numbers right here again. Here we go. And same happens with 3 here, okay? The same happens with 3 here, or 3 will also go ahead and get multiplied to all the 3 values right here. So this is what Cartesian product is. Now, it actually doesn't make sense when you talk about numbers, it's fine. Okay, when we talk about only numbers, it's fine. But okay, 111 is getting multiplied by these 4 numbers here, and this is called as Cartesian product. But how does it make sense if we have got 2 separate data sets and we are merging them together without any consideration of the common column? So let me give you another example here. Let's say we work in a FMCG sector. I hope you all understand FMCG there. All right. And we have got different product mix out there. So this is my products. And this here, the flavors that we will provide. Okay. I don't know what to call them, flavors or something, whatever you want to call them. So let's say this is the shampoo line. We want to create a product mix for shampoo based on flavors. We have got hand washes there and soaps out there. And we have 3 flavors we have figured out. We have got 1 flavor here, we have got 1 flavor here, we have got 1 flavor here. And generally this is what happens, right? So we have figured out that these are the products we are going to offer. And we have got these 3 flavors. And based on these 3 flavors here, we are going to create the entire product line for these. Now the Cartesian product or the cross join will come in action, and it will go ahead and give us the output. What will be the output here? It will go ahead and get the shampoo here. And this shampoo should have all the 3 flavors right here. And this shampoo is going to get repeated, of course. Now this is the hand wash here. We will get the hand wash here. Since we have merged it with this here, I will go ahead and merge it with all the 3 values right there. Same happened with soaps here. And this is the soaps here. Now, in the output right now, in this output here, everyone, this output now contains the entire product mix that we were looking for because of the cross join, and there is absolutely no consideration of common column. It was not required, right? So when we are talking these kind of mergers here, okay, this is where the cross join comes in, and this is called as cross join. So let's take a quick example here, and we have all been to cafes, yes. And when we go to cafes, everyone, they have combo offers, yes. So let's take an instance that right now our cafe has come to us and they have opened newly. So they want us to go ahead and create a combination menu for us, combo menu for them. So they have beverages, they have got food. So they want to go ahead and create multiple combination of food and beverages, and they want us to find out what will be the prices and what are the possible combinations they can offer. So we'll go ahead and create that combo menu there. And plus, of course, we will go ahead and figure out what is their total price that they should be offering there. So first we'll figure out the multiple combos they can offer. And of course, the total price they can charge it for. Okay, so this is what we're going to see. This is an example here. So first here, let's understand how to type a cross join. Okay, so let's go ahead and first understand this. What is a cross join? Simple Cartesian join, Cartesian product there. Basically what we are looking for multiple possible combination between the two tables. And of course, we will not go ahead and consider any common column right there. Now there are two ways to type it. Okay, there are two ways to type it. First way here is to use the keyword. Okay, first way here is to use the keyword. And since we do not have any other table here, we will go ahead and make sure that we're using DB joins this time. Remember that we have to go ahead and set the default back as DB joins. Please do that. Now here we will type select again. In the select here, we are getting everything from all the columns from both the tables here. That is employee info. I'm calling this as T1 for now. And we are going to cross join it because we have the keyword available with employee salary here. I'm calling it T2. So there is no common column consideration. We don't have to type anything else here because when I go ahead and press and execute this here, look at this. It makes no sense for now, but we can see here that here this 1 to 3 is getting repeated 4 times, and this is also 4 times getting repeated here. And this is true for each and every employee ID. What is the other way to type it? What is the second way here? In the second way here, we write a simple query. We will not type the keyword at all. So if I don't type the keyword at all here, what we type here? We'll say select everything from where? From employee info, comma, employee salary, and we end it here. And once we execute this, this is what we see. Exact same output. Okay. So we can type it without query 2, keyword 2. Right, go ahead and find out the cross join here, very simple thing here, and then we will create a small 2 tables. Once we'll come back, first we create these small 2 tables there, okay? Then we'll move forward and create a cross join and create combo offers for the cafe there. So let's create the database here. I'm going to call this database as cross table because that's what we are going to do here. We are going to use the cross join right now. And inside this, we are going to create table. What is the first table we are going to create? Inside the cross table here, first is the food table, everyone. Please pay attention here. We are first going to create food table here. Inside the food table, we are going to keep item code, item price right here. We'll go ahead and keep item code, item name, and item price right there. Now we insert the values into it. So we can say insert into where? Insert into cross table.food. Now we need at least 3 food items here. So what would you like to eat? We're very close to the break right now, everyone. So tell me what would you like to eat? So this is I'm typing item code is 1 to 3 here. What would you like to eat? The first thing that comes into my mind is pasta. And I'm going to go ahead and give some random pricing there. Yes, what would you like to eat? What is the next thing that comes up in your mind? All right, so let me go ahead and give another food item right here. And here we go. One more easy to type food item. Easy to type, easy to eat food item, everyone. Tell me one more here. Maggie. Okay, I saw Maggie first. So let's keep the Maggie right here. And let me give it a random pricing again. These are the food items, all right? This is our food table right there. I will select this entire thing and execute it right here. Refresh it. And here we have the cross table right here. After food here, we need beverages table, everyone, right? So I'm going to create beverage table also here. Now cross table dot beverages. Now you will keep thinking what would you like to drink. We will keep three things here, okay? And beverages also will keep the three columns here: beverage code, beverage name, and beverage prices. Now inside this here, we'll go ahead and insert the values again. So which values do we want to insert here? In the cross table beverages, and we want values right here. That's values. Now first one here is the code. So let's say code is V12 here. And yes, what would you like to eat here? Sorry, drink here. First thing that comes into my mind is tea. What would you like? You have got two options left, everyone. What would you like to drink? Second, I'm keeping, let's say, B13. Let me correct this. Coffee. Okay. So we'll have the coffee right here. Very good. What's next? What else would you like to drink? We need one more drink, everyone. So B14. I'm naming it B14 here. Ah, very good. Yes. So we'll go ahead with lime soda right here. And this is a random pricing again. And here we go. We have two tables, everyone. So I will go ahead and select this all together, execute it only once right here. And we refresh it here and see we have two tables. One is the beverages table right here. And second is the food table right here. Okay. I will go ahead and share this with you right now. And during the break, simply get these codes there and execute them, select them together, execute them together only once and refresh it then. Okay. Both the tables are there, food and beverages. Okay. We will make sure that we are typing here use cross table so that I will make sure it is set as default. Okay. Now let's go ahead and merge them together. We simply want the Cartesian product, the cross table here. So we get the right here that we would like to select. Of course, we are looking to select all the columns there. And from where? From both the tables here. So we'll say from the food here. We are calling it T1. And we are going to cross join it with beverages here. And we are calling it T2 right here. So what we see here right now is just the list here. But we have to create the combination here. We need a combo here. So the combo is in front of us, everyone. All right. This is the combo that we are looking at. So the one item here, okay, is combined with all the three beverages right here. Okay, so again, see here, this says here, it is combined with the beverages right here. So this is also combined with here. This is what we are looking for. So we have got multiple combinations here. However, we still have their individual prices. What we want to add, we need to add a total price and then the discounted price of the combination if the combination is what. So first, let's go ahead and now we'll add two columns here. All right, we are calling it total price and the combo price. We'll add two columns in front of it. So let's go ahead and see how we are going to type that here. I'm going to take the same thing here, select everything from here and copy this and paste it here and type. I'm going to make right from in the next line here. And after all the columns, we want to add two more columns. So after the asterisk here, we'll go ahead and type a comma and we add a column. First column is very simple. We'll ask it that go to table number 1. That is the food table there. And from the food table, get the item price. And add that with the table 2 beverage prices there. We can keep it under the parentheses here. And we can name this as total price. We can name this here as total price. Okay, so we have total price here, but we usually give the discounts for the combo prices. So for the combo price here, we have to get the entire thing here. So let's say if we are giving the 10% discount, let's say we are giving the 10% discount for the combo price here, meaning we are charging them only 90% of the total price. So we'll go ahead and we will type here 0.9 right here. So that's just the 90% of the total price. We cannot simply use the total price here. Why? Because select query will be executed at the end. And at the end, these calculations will be done one after another. So it doesn't understand total price as a column right now. So we'll go ahead and type 0.9 here. I'm going to call this as combo price right now. This is combo pricing. If you look at the combo price here, this has got too many decimal points. Okay, let's round it off here. Currently, I'm going to round it off to no decimal point. And here we have total price and combo price right here. See, okay. I'm going to go ahead and beautify this so that we can see both the options right here. So that's why we have given the name here so that we can utilize these names inside the calculation. What is self-join, everyone? Self-join is not a keyword. Okay. And let's understand it clearly. Self-join is very different from any other join we have seen so far. Self-join is done on one single table. It is not done on two tables merging together. We will go ahead and we'll do the self-join in one single table based on columns within the same table. Based on columns within the same table. Why do we use the self-join here? Whenever we want to go ahead and create a hierarchy within our table itself. So self-join here is a special type of join. It is commonly used to create hierarchies. It makes it easier to retrieve the interconnected data within the same table. And remember that there is no specific keyword called as self-join. Okay, let's understand it better. To understand it better here, let me show you here the employees table. Okay, so let me go ahead and show you the employees table we have in classic models right here. This is the employees table, everyone. Okay, in this employees table here, do we have a column which has almost common data set inside it? So what is happening here is these are the employees, correct? And this is another column that says reports to. So basically what is it here is these are employees and these are the managers or anyone whom they are reporting in. Okay. So this is our management here. This is our management here. Okay. Where these employees are reporting. Now let's understand how this table is created. To understand how this table is created here, see very carefully. This is employee number 1002, right? Who is this employee here? Let's figure it out. So this employee 1002 here, who is this person? Is this person Diane Murphy? Yes, that's the name here. This person, Diane Murphy, has the employee ID of 1002, and this person is president. That's why Diane is not reporting to anyone. Let's talk about 1056, Mary Patterson here. Mary here is reporting to 1002. Who is 1002? Diane. And what is the designation of 1056 Mary here? The designation of Mary is VP sales. But Mary here is reporting to president. Quite confusing to understand, especially the job title column. Yes. Because if we see 1088 William Patterson here, William is reporting to 1056. That is, William is reporting to Mary. And is 1056 sales manager? No, no, no. William is sales manager. So here, everything is written in one single line. However, will it be easier to read if we will go ahead and reconstruct this table something like this? Look at very carefully here. Will it be easier if I go ahead and type manager IDs first? In front of manager ID, we will have manager name, and then we will have the manager job titles. Manager job titles here. After this year, now we can go ahead and get the employee IDs and employee names and their job details. If the table is created like this, will this be easier to comprehend and analyze, right? So this is what self-join does. If we go ahead and use the self-join on the same table, right, this particular self-join will help us to restructure the table so that we can see the hierarchy properly. Okay. If I have product ID, product brand details, product details like that, this is also a hierarchy. So product category, product subcategory, product brand, product colors, product sizes. This is all is hierarchy. So if you want to see a proper hierarchical table, okay, this is not how the tables are actually collected. The data is collected. So we restructure it by using self join. So this is what we are looking for. Okay. Now, how do we restructure it? So to type the self join here, everyone, this is how we go ahead with it. Now, remember that how do we type the join here? Let me show you here. How do we type the join? Let's take this right here. Okay. How do we type the join, everyone? To type join here, we will use inner join. We will go ahead and use the inner join. Now, we are about to the inner join on one single table, right? So how do we mention only one table inside the select statement? So we'll go ahead with start with the select everything, get all the columns. We can choose the columns later. And how do we define the join or the merge there? We'll start with simple from and we'll say that go to employee table and we name the employee table E1. And then we will define the inner join. And after this here, we will go ahead and write the employee table again, but we give the alias as an E2. So now it will treat the same table as two separate tables. And of course, we go ahead and we define the common column. Now the common column here is going to be our two separate columns. One is employee ID and another is manager ID. We'll say that this is the same table, treat them as two. And based on these common columns, you go ahead and merge them together. That's how we go ahead and get the self joining. Okay, so stay here. Okay, I'm going to show you. I'm going to write this here inside the classic models. Okay, so here is the classic models, everyone. Make sure it is default, and then I'm going ahead with the select. Currently, I'm typing select everything, and then from where? From the employees table, right? I will call this employees table E1. And we want to go ahead and inner join it with again the employees table, but this time we give the name here as E2. When we are defining the common column here, we'll say that go to E1, and first we'll ask it that which particular column is similar here. Employee number, okay? And this is equals to E2 dot reports to. This is our name here. These are the two which are the common columns here. Now, let's look at very carefully in the output. Let's look at very carefully in the output here. Remember that this is the same table, right? This is the exact same table. We will look at the output right now. Let me give you a better view. Here we go. Let's look at the joined output here. See here we have our employee number, last name, first name. Observe here that this first column here contains employee number of whom? Whose employee numbers are these? Inner join only keeps the common column, everyone, right? If you will see this Murphy, Mary here, these both were the managers. Even if you see the titles right now here, I would like you to extend your view. I would like you to extend your view till the job titles. Look at the job titles. Okay, all these people are, this is for Murphy, who is president, Mary is VP sales, everyone else is a sales manager. If you go here, no one is below than sales manager other than this one. All are here, meaning someone is reporting to them. So the first part that we see here, it is the manager part. And when we move towards the right here, we again have the employee number, first name and last name here. But this time when you look here, all these people are reporting to someone. Mary is reporting to the president here. Jeff is reporting, William is reporting to Mary back here. So we have all the employees staff here. We have got the staff right here. So Mary is reporting to the president. Yes. Jeff is reporting to the president. William is reporting to the VP sales right now. And who is the VP sales? Mary. So right now in this part here, everyone, the first part here are the manager's part. This is the manager ID, manager name, manager first name, and manager's job title right here. In the second join table here, these are the people who are the employees, reporting persons here, and this is their job title right here. So now we can go ahead and pick what we want easily. So I'm going to copy and paste here, and we are going to pick up the columns right here. Now, which columns are we looking forward to? First, we will need this employee number. Remember that each of these names are repetitive. So we have to go ahead and say that, okay, go ahead to employee 1 here, E1 here, because it is on the left-hand side, and get the employee number right here. And this is our manager ID. This is our manager. Okay. Now, this is our first name and last name. I'm keeping only first name right now. You can concat them together too. So I'm saying that go to E1 and get the first name. And this is going to be manager name here. This is our manager name right here, comma. After this here, we need job title, right? So we'll go to E1 dot here. We get the job title too from E1 there. And this is the manager titles right here. These are the manager titles right here. Let me show you the output right now, how clean the output is going to look here. So let me beautify this easy here, okay? And let me show you how the output is going to look like. See, right now what we have here, we have got manager here and their names and their manager titles right here. Now we can go ahead and choose again. We'll go ahead and we choose again. So now once we have this, we will go ahead and choose from the second part of the employees table. Now here we can move forward that, okay, now you go to E2 there. From the E2 also get the employee number, but this time these are going to be as employee IDs. And from E2 again, we get the first names there, and these first names are going to be employee names right there. Employee names right there. From E2, once we get the job title there, this job title is going to be as employees job title there. Employee titles. And once we see it right there, say, so this is now easy. Now we can see right there that here, okay, to the president, 2 people are reporting. And to VP, to VP sales, there are 3 people reporting. To Anthony, who is a sales manager and maybe not any there, these many people are reporting. These many people are reporting. So now this is our joined out table. We can go ahead and do more calculations right here. But this is how the self-join works. Go ahead and check it out, please. First, join everything together, okay? After joining everything together, then go back and pick out the columns. Okay, so let's do one thing here. The Chrome has got unresponsive for me. So I'm going to share it right there, okay? So this is the self-join right here. I'm going to share it in the parts. First, we will get everything, okay? Once we understand the output from there, we'll go ahead and pick up individual column right there. And why inner join has such an effect here, if you will see it closely, all right, it is simply going ahead and getting all the matching values in front of one another. Next is this exercise right here. First, here, we simply want to go ahead and calculate the total sales amount for each year and quarter. How we can do that? How many tables we need here? Let's break it down. It's a very, very simple question here that calculate the total sales amount for each year and quarter. Let's figure out from here. Let's break it down. How many, which columns do we need here in the output? What we are talking about? How many columns are we looking for? So if we are talking about select here, right? Which columns do we want? We want year, and then we are looking for quarter. And here it is saying, give me total sales amount. Give me total sales amount. Okay. So please tell me from where we can get year and quarter for the orders here. that when they have been placed inside classic models only. Order details do not have date. Order details do not have date. Order details do have quantity ordered and price each. Which table has date, everyone? Orders table. Remember the date functions, right? So we need orders table. And from where are we getting the total sales amount? We have to go ahead and multiply quantity with price each. That for in individual order here, how much quantity has been ordered and what was the price paid for each. So we need order details table, everyone. So please tell me, is there a common column between them so that we can figure out each year how much has been paid for the orders? Do we have a common column? Common column we have here is order number. Very good. What will be the calculation for total sales here? Remember that this is how the order details table looks like. Look at the order details table right now. Order number is getting repeated. Why? Because inside this order, these many different product has been ordered out. This is the quantity of individual product and this is the price paid for each item. Right, very good. So we need to go ahead and multiply quantity ordered with the price each. Once we will multiply this, whatever answer we get after multiplication of these two here, we need to add it up for individual order and then for individual year. So first what we do, we go ahead and we join them together. Okay, right. So we need to go ahead and multiply quantity ordered with price each. And we need to aggregate it too. Okay, because we want total sales, not row-wise out. So we don't want to add a calculated column. We want to add it up. So we go ahead and type sum in front of it. Okay. So this is how we get the sum. So from and select is defined. Okay, let's go ahead and type it out. So how do we go ahead and type this out here? First here, always look at the entire table if we have the access to. So we will say select everything. From where? So from, we have got orders table first. I'm going to name orders table O. And which join we should go ahead with? Now here, we are not sure. If I say inner join, we might compromise the data set. What if we haven't received anything yet? Maybe that order is cancelled out. The status is something else. So whenever you are in doubt, you're not sure about how the data set is or how the data model is created at the back end. We are not sure about that, about the table structure. We can simply go ahead and type join, just join. And we can ask it to go ahead and join it with the order details here, and we type OD. We type OD right there. Okay. So after we write this join here, we have to again define the common column here. So we can go ahead and say on here. From the orders table, we know the common column that we have here is order number, which is of course going to be equals to order details table order number. Till here, everything is fine. Let me show you the entire table. See here, this is the order number. This is the order date, everyone. In front of the order date here, we have individual price and quantity right here. Okay. What we want here, we don't want everything out here. We are simply looking for year, quarter, and total sales. So now we need to go ahead and get the year out of this year, quarter out of this year, and then we aggregate the each per quantity ordered and price each as per that year and quarter right there. Yes, I'm answering that there. So see here, how many total rows are in the orders, everyone? Total rows in the orders table itself, we have 326. Okay. In order details, we have again 326 rows. So let's see here, order details has 3000 rows here. Okay. So when we are simply typing the join here, how many rows do we have now? 2996. Okay. What does this signify here? What type of join are we doing right now? When we go ahead and define join in MySQL, okay, it will get only matching rows from both the tables. So it will automatically define the inner join. So whether we type join or inner join, it is going to be exactly similar in MySQL. So both of them give you the exact same. Okay. Yes, inner join. So right now we are simply going ahead and typing join here. So one is inner join, another is natural join. Another keyword is there. Natural join will figure out what is the best join to go with, and there you will get the left. So this is it. So right now we will go ahead and simply type join here. It will act as the inner join for now. And now we go ahead and see here with the year. So this is year. What do we want in the year? Order date. And I'm calling this just year. We want quarter there. So this is quarter. This is it. Order date. And I'm going to call this as quarter. Comma. Now we need total price. From where do we get the total price here? We can simply go ahead and say that go to order details here, get the quantity ordered, multiply that with price each right here. And we can call this as total sales. However, we have to aggregate it, right? As per each year and quarter. So we'll go ahead and sum it up. And remember, when we are aggregating something here, select has to work with group by, so that the group by will go ahead and get the individual year, unique year and unique quarters right there. So in group by here, we'll type 1, comma 2. That's what we are looking for. And here we are. We have got year, we have got quarter right there, and the total sales for each year and quarter. And if you want to add the total and subtotal there, right? So you want to go ahead and add total and subtotal. How do we do that, everyone? Within the same thing, we want to add grand total and subtotal. How do we do that in the similar one here? That at the end, we should know for all the 5 years total, and for each year subtotal should be there too. Yes, we will get the exact same thing here, but we will use with rollup. With rollup is the entire keyword right here. And now we will have here grand totals and subtotals right here. And no, we cannot replace null, and MySQL is not inbuilt here. Okay, this is the question there. What we want to do right now, we want to retrieve the customer details right now, name, ID, country, and we want to calculate average order amount, average total order amount by each country. So basically, we are talking about, so this is what we want to retrieve, okay? The purpose is to retrieve customer details and the average order amount by country. So we want to write a query to retrieve average order amount for each customer in each country. Each customer in each country. So what is this average order amount we are talking about? We are talking about this only, quantity ordered and price each. This is the total sales there. But we want to calculate average of it this time. We want to go ahead and calculate average of this time. That's the difference. Okay. And what should the output contain here? Output should have first your customer names and IDs, right? So customer name here, and country. This is country right here. And this is here, we should have the average. This is where we should have the average. Now, but we want to see this report here only for the customers, only include the customer details who are the high ticket customers for us. So we include the customers who have an average order greater than $3,000, who have the average order price greater than $3,000. Now, let's figure out that which tables do we need? Which table do we need out of these? To get customer name, country, and average. An average contains here quantity orders and price each. Please tell me the tables we are working with. From where do we get, see, order details is very evident here because we are getting the quantity details here. Order details is evident. What is so this is our first here, we figured out order details. From where do we get the customer name and country, everyone? From where do we get that? Customers. So our first table is going to be customers here. We get customer name and country from there. And the second table, we are seeing order details. Go ahead and check it out, please. We need a common column to connect them. Customer number you are saying here. Let me check the order details table here. Do we have customer number in order details? Yes, do we have a common column? There is no common column there. All right. Be confident in your answer. You can see that in right front of you, right? Okay. See here, we have customer number, their address, credit limit, country. Do we have any of that here? Absolutely not. But we are sure here that we need to get these three things out. It is a very genuine request. So if we do not have the common column between these two tables here, do we have any common table? So right now we have two tables. One is customers, right? And another is order details table. And in both of the case here, we do not have any common column between them. So if we do not have a common column here, do we have here any common table? Customer has customer ID as the column here, and this has the order ID. So do we have a table which can connect both of these tables together? A third table? So we have a third table that is orders table, everyone. Why orders table here? Because orders table have both the both of them here. It has got customer ID also and order number also, order ID and order ID too. So what we have to do here is, okay, we will simply go ahead and connect customers table with orders table with the help of customer ID, and we can order details with the order ID. But when we will select the columns, we will select the columns only from these two tables here. But we have to join all the three tables here. So writing this, to write this query here, we have to go ahead and actually find a lot about the data set just by scrolling up and down. Yes. So let's go ahead and see how to type it and what we can do to avoid it. All right. So let's see here. How do we type it here? So now we understand we need a third table, the entire table here, that is orders. So we have got multiple joins right there. So let's see how do we go ahead and type multiple joins, everyone. So to type multiple joins here, okay. For remember that we can join one table at one time here. So we'll go ahead and join customer table and the orders table with the help of customer number. Then we will go ahead and join the output of this with the order details table with order number as the common column. Because once it is joined, whatever big table is there, that will contain the order number within it. Okay. I'm going to go ahead and type select everyone. Okay, so I'm writing here select, and in the select here, I will come back to it. First, let's figure out from here. So inside the from here, first we are connecting with orders, customers table here. This is customers table. I'm going to call this as C, and I'm going to join it together. Okay, let it be inner join for now. And here we want to connect it with the orders table. This is our orders table. And this is O here. We want to join it on what? So we want to join it on customer number. So we'll ask it to go to customers table and get customer number, which is going to be equals to orders table, customer number right there. Till here, everything is fine. Now, what do we do next? In the next here, we will simply go ahead and type join again. And here we will ask it to go ahead and get order details. We'll name the order details as OD. That join the order details OD. Based on what? Based on get the from the orders table, get the order number, which is going to be equals to order details order number. This is our from. This is our from. Now all the three tables are joined together. See customer table right there. This is our credit limit order number. This is order state here. And third here you will find is the price each quantity order details table. Now all the three tables are joined together. Okay. And but we don't want everything, of course. So we will go ahead and say that, okay, I'm looking for customer name here. So from the customers table, we can say, give me customer name. And we want country right there. Now we want the average. So we will go ahead and type the round function beforehand and the average. And we know we need to go ahead and simply get quantity ordered and price each. We close the bracket here. Let's keep the 2 decimal points there and close the bracket. Right. Now, let's call this as average. I'm calling this as average for now, giving it a small name right there. So we have right now 3 things around here. When we execute this here, is it going to work? No. Why? Because we are aggregating it, everyone. What we are doing, we are aggregating it out here. So we have to group it by. So we are going to go ahead and group by it with 1, 2. We have 2 things, customer name and country. And here we are. Okay. We want to include the customers who have an average order amount greater than 3,000 only. So how do we go ahead and place a filter here? So we have average amount here, and yes, we have some above 3,000, some below 3,000 here. We have multiple type of amounts here. So how do we go ahead and place a filter on this column right here? Where clause is used for giving the filter if the column is present in the database. So tell me, is average column is present in the database? Is it present in any of these tables here? Any of the columns of these tables here? The average? No, average is a aggregated column with the help of group by, correct? So if we are aggregating some column here with the help of group by, and we are calculating it right here, how do we go ahead and give a filter here, everyone? With the help of having, here. Why? Because having can actually give the filter with any aggregate column which is created with the help of group by and which is not present already in the database. So in having here, we can say that, okay, the average here, okay, should be greater than 3,000. And now we have only 3,000 rows. We can keep on going and give multiple other filters also there that you want to go ahead that and the country should be equals to USA. So go ahead and write that country should be equals to USA. So you can go ahead and keep on giving, you can go ahead and use any filter operator that we have seen so far in where clause. Everything can be used inside having too. Okay. When we will talk about the optimization here, we will learn something, everyone, that we are not supposed to give a filter which can be easily given with the help of where clause. So this country equals to USA, we could have given this with where clause, so we will not give it with having. That is the optimization, but both are correct. What if we can go ahead and keep, why are we even doing joins here? Why can't we simply keep all the columns at one place like this here? Wouldn't it be easier? No joins, whatever you want, whatever calculation you want, you can simply go ahead and extract a column out of this if the entire table is here. All the order details, customer details, product details, order details, and date, its status, everything is here. Wouldn't this be easier? You don't care of the joins, common columns. Then why are we not doing this? Why companies are not doing this? Data will be huge. Yes. Degrading the performance means it will lag a lot and it is going to have too many null values and too many duplicate values so that it will we cannot simply go ahead and ask it to go and count how many customers are there. Not easy thing to do here because there are too many duplicates. Correct. It will have, and it will scale so large that it will be too hard to handle it. You need to scale up your hardware constantly and you have to scale your software too because you need to handle such a huge data. And since it is just one single table, all the updates are done in this. Everyone will be accessing this one single table for each and every purpose. Every marketing department person, an HR, simple order, an operations team who will go ahead and process the order in everyone will be only talking about this table and transactioning with this table only. And there will be a lot of lag because they do this with the help of LAN or any internet connectivity there. So this is quite a huge issue if you have one single table. What are the issues? If I go ahead and define the issues here, first is too many duplicates because one person, there are multiple customers giving us multiple orders. So every time the entire customer detail is getting repeated. Now one order, one product is bought by many customers. So the product will be will be there too. And since we are maintaining only one single table, so if I go ahead and some customer deregister themselves, so can we simply go ahead and delete that person's data from here? If someone deregisters themselves, can we simply go ahead and delete their data from here? No. We have to go ahead and add one more column here and tell them whether they're still active or not. Similarly, if we launch a new product, of course, no one has given any kind of order of that because we have just launched it on a date. And I want to update it right here because it's a new product. I will go ahead and type that product detail only. Just this part. Everywhere else will be null. Everywhere else it will be null because no one has ordered it yet. So here we will face multiple difficulties if we are trying to get the data here. What are those difficulties called? These are called as anomalies here. It is very difficult to insert new data. It is difficult to delete anything out of here. And it is very difficult to update any new thing. If some customer has changed their number, their contact number, or they've added new addresses inside it, it is very difficult to update it. It will create too many null values right there. And of course, there are redundancy or repetition issues. Other are, it will have large database memory, one single database, and it will cause a lot of lag. And because of this reason, what the companies do, they go ahead, they break up this table into the small parts here, which can be handled independently. And when required, then we can join them together. And this process of decomposing or breaking up the table into the smaller table, this process is called as normalization. Okay.
And that brings us to the end of the session. We have seen that SQL is much more than a language for retrieving rows from a database. It connects raw operational data with analysis, reporting, dashboards, and ultimately business decisions. Whether you're preparing for a career in data analytics, business intelligence, data engineering, or software development, understanding how SQL turns business questions into useful information remains an extremely valuable skill. So if you have any doubts or queries, let us know in the comment section below, and our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning.